The second one is necessary data set available. And the third thing is because of data sets and compute power, so you can apply to solve many, many real world problems. The problem can be healthcare area, can be agriculture, can be smart transport, and many, many other areas. Then quantum is another area that is just coming up. Quantum is another area that is just just coming up, because there are problems that can be resolved, because there are problems that can be resolved, therefore moving towards this universe, therefore moving towards this universe to quantum solve. So where some hard problem can be solved. But not as independence. So as a convergence of not as independent. So as a convergence of quantum and infinite state, even though quantum convergence and infinite state exists, but developed in the master physics can exists only. So therefore we answer the science. So therefore we have to learn quantum physics. So the repeated emergence of this means the emergent hands of closing hardly the capability of the hands of closing hardly the capability of quantum to receive the receive the then the other is software development also. The other is software development. That's the approach towards building software. That's the changing around. But now the third generation software engineering model, which is called microservice-based software engineering. So that way we can build applications that are highly scalable and highly reliable. So that approach is essential. So those are the aspects that we cover. So this is the outline of my talk. So I'll give you a quick introduction to computing paradigm. Particularly I will focus on cloud computing today, and then how this cloud computing evolved over a period of time during the last 20 years, and then we come to the today's latest model, and then see how that impacts on the architecture. So there is a second type. Then I will discuss about our own platform called DEC, which we developed at Melbourne University, and it is commercially available. And this technology has also evolved over a period of time. So I will discuss about the latest version of this software. So then this high quantum, as part of this quantum computing concept, will also introduce your own effort in this quantum computing area, which we call high quantum. So this is all about further enhancing the research and enhancing computing capability from the today's model towards the quantum. The high quantum, as part of that, I will discuss both a real platform which you can use to build application having both quantum and also classical code to deploy this in that manner, and then also simulator. So both those of you who do research may not have access to real platform, but you can do modeling and simulation to explore some new ideas. So then you can put it here. So this is the plan. So let us start with the first one. And we all know during the last 50, 60, 70 years, different ways of computing have come and gone. So computing waves and also communication waves. So computing waves in 60s, we had mainframes. Move forward, the web started as a way of accessing remote information. So in the name of web, we have what is called as application communication through a standardized approach with web services, leading to the realization of service-oriented computing model. So then came this virtualization, so that you don't have to you don't have to tie and deploy application on a specific hardware. You can just deploy a virtual machine. Thereby, you can take that capability from one server to other server as necessary. So virtualized environment help you to use resource efficiently better. So then, of course, this cloud computing during the last 10 years has gained popularity because we want to bring this capability of computing just to the big corporate and of course also to the big, large masses. The application services will be available to large masses, anyone, anywhere in the world, even with simple device like mobile phone, they should be able to access this capability. Whether they are simple smart transport or whether they are the healthcare application, whether the medical application, should be accessible to those smart devices. That comes to the cloud. So then the quantum. As I said, quantum is just inconsistent, just begin. So people are doing hardware research, even though a lot of noisy and error is there. But however, it's an opportunity coming up. Then this IoT, Internet of Things, is about combining the physical world and the digital world. When we combine physical world and digital world in a seamless manner, so you look at sensor that sense the physical world, and the data comes in, and then of course you have a digital world. So with that integration, perhaps we can make this environment smarter. Means we can use resources efficiently. If it is the roads, smart transport means whatever roads we got, we need to use efficiently. Agriculture, to do agriculture, we have to irrigate, we need water. Water is also limited in the world, so we need to use efficiently. So all this efficient use of resources to create smart environment is what IoT supports. Then also towards healthcare as well. So we will discuss some of those application case studies. So my focus will be primarily here. Okay. So with that, you look at advances in both computer and communication space. The key drivers the central application, multi application. But today, more and more, the population-oriented application. So this is where, of course, cloud plays an important role in supporting such application. Now, just at a glance, cloud computing. So what do we have? we have various capabilities somewhere in the network, and these are put together by cloud service provider. Just like we have got ISP internet service provider, similarly there is cloud service provider. There are users who can subscribe to this cloud service providers, use it and pay for the consume. And what can they use? You can rent compute capability, you can rent storage capability, you can rent application capability. So as required, then of course use it. Then this is a meter service. That service is measure how much you are consuming. Accordingly, you are charged. Just like electricity, water, gas, and telephone. In the same way, the computing is utility. So it can be compute capability, application capability, direct capability, and so on. Even though we may subscribe to one service provider, that doesn't mean that service does everything for you. So actually, they are using service from other providers, putting them together, and offering them a composite service. So many applications are there in cloud computing. They are most of them follow that approach where they are able to harness multiple cloud services which are distributed physically. Physically means, for example, you may have a cloud data center here in Hyderabad, you might have in Bangalore, you might have in Delhi, or you might have in Melbourne, Australia. So physically distributed around the world. So the purpose can be to provide the best quick response, or purpose can be to provide reliable services. If something fails, we can migrate those services to other place and still provide uninterrupted service to the end user. Now, what are the applications? There are many that we are using every day. That are running in the cloud. So, to starting with the traditional commercial applications such as customer relationship management and ERP and e-commerce, these are primarily running on a big company's data center inside the organization. But now, those are probably those capabilities are also available for small and medium businesses who want to use it. So these are available through cloud already. Then of course scientific applications are in cloud, and more importantly, so these consumer applications that we are accessing, anyone is accessing very commonly from mobile devices, including, for example, say WhatsApp. WhatsApp you are using to communicate one another very easily. Even the people from villages and farmers are calling me WhatsApp, and only problem is they don't know what the time zone difference. For example, in Australia, so I may be sleeping at 2 a.m. and the people here are still awake at 5 p.m. evening. They call me, so they don't know the difference. Of course, in the future, we have to enhance this technology to be personalized. Be aware of who we are calling, not independent numbers. Okay, this person there is 2 p.m. 2 a.m. Don't call. Yeah, otherwise they don't know. They think the whole world is having same time zone. Right? If you are awake, other person will be awake. That is not the case. So this is a problem. So this is WhatsApp. And Zoom, of course, is a cloud-hosted video software. It is running in a cloud. Then, of course, things such as Instagram, Gmail. The Gmail we are not using, but even the enterprises can also have a Gmail. If you set up a new company today, you don't have to worry about setting the web server, setting email server. All that are the old days. The new days is simply just go there, freely you can map your the domain, email domain to the, for example, this Gmail enterprise service. So then everything is as if you have your own dedicated running a cloud. Then more importantly, of course, Facebook. Anybody doesn't have a Facebook account? No Facebook account. Very good. So those who are happy, self-happy, self-satisfied, they don't need Facebook. The rest need it, correct? So for example, if Modi happened to visit this campus, so you take a photograph, selfie, then people are only happy only when they can upload that photo to Facebook. Here they are very anxious. I preferably the photo is picked up by Deccan Chronicle and published for the rest of the people. So they will be happy. So this Facebook is actually multi-cloud architecture. Given that millions and millions of users are using the service, and all of them expect best quick response time. So these are distributed. They have distributed cloud data center across the world. Then based on where the requests are originating, accordingly they map those requests to different data servers. So that way, quick interaction can take place among the who are your clients within the Facebook. Then latest is ChatGPT, natural language processing. So this ChatGPT is made possible by cloud computing. So ChatGPT, is so much popular. Everyone is nowadays seems to be using, and even the people who are in lawyer business, people who are doctors, people who are teachers, people who are farmers, people who don't know anything, or people who are politicians. Everyone is in ChatGPT asking a question because they don't know. Correct? Who is the constitution author? They don't know. Correct? Sometimes you may don't know. So therefore, this ChatGPT is becoming popular. So this is thanks to cloud computing. Otherwise, natural processing has been around. You can ask our CSR from NIC, former director. You know, the natural processing last 20 years, at least 7 years, last 30 years, natural processing is happening. But that didn't reach the mass. It was only within a small scale supercomputer, that's all, NEC center, few people are using. But now the benefits of that coming to the masses, so thanks to the ChatGPT. You can see there are so many applications of cloud, and today if you are someone doing research in cloud computing, you are very proud, and you can easily explain to anybody that, my research is making impact, and you are using, accessing from your own, wherever you like, correct? So these are the applications. Now moving forward, that's not it. But before that, I want to highlight how these applications have worked and how the technology has evolved. So, for example, in 2008, when cloud computing started, in France at that time, there were servers, and for example, companies like Amazon wanted to make those servers accessible to others. So, rather than giving them access to physical server, they wanted to give you access to a virtualized server. So, the concept of virtual machine came into the picture, and then accordingly there was some technology such as Gen and VMware available. You can just take those and create a virtual machine, then within that you have application, either use it yourself or rent the capability to others. Okay, so this is all this subject. So at the same time, the people doing research, most of them at that time, we are doing research on how do we manage virtual machines, when to use virtual machines, then how do we manage the life cycle. That was the kind of research we also carried out. Then how to use those efficiently. So this is in 2008. As we move forward, then of course, say for example, in 3-4 years time, then in 2013 or 14, this concept of containers came into picture. So rather than having your application in the machine, so you can create an application with this container, with having all the environment variables and setup. So you can take that container, put it on any virtual machine or put it on any physical machine as you like. So in the technology such as Docker that came into picture to support this container. So then came what we call, for example, not only virtualizing this computing, but also virtualized networks. The SDN came independently through networking community, but the same SDN also came in the cloud. So that is where the notion of what we call software-defined cloud computing came into picture. And of course, why do we need this SDN? If you have got some mission-critical applications such as remote surgery, for example, remote medical operation. So in those cases, you need to be able to provide a dedicated or allocated bandwidth for each of those such critical applications. And you cannot do with the physical network. In physical network is the best effort. Everybody is pushing the data. Correct? Just like I'm coming from home to the university. So like best effort is just navigate the way you want, somehow reach by 9 o'clock for the keynote. Correct? But if you use a SDN base where I can do service function chaining, so then I can say from this point to this point, there is a dedicated line which you come. For your purpose because of the criticality. So such notion of service chaining, how do you do? How do we do network function visualization? So these are the other aspects. So there was some technology, so this presented an enormous opportunity for people to look into such critical application, the resource provisioning. So then, of course, up to this point, so if you as a application creator or application deployer have to take responsibility of how much resource to provision and how long to provision. So these are up to you. So if you provision virtual machine, even if you don't use it, you still need to pay for it. In fact, it happens to me. One of my students, she created several virtual machines and left and gone home for 1 month. Then she came back, then we received a bill of $40,000 US dollar. Right? Now who is responsible? The company says, you people who have created, you are responsible. Then the student says, I am doing PhD interview, you pay for it. University says, we don't have money. So problem comes to me. So anyway, we negotiated to somehow call. But now, no problem. Now we are going what is called as serverless computing. In serverless computing, you create an application made of functions, deploy. If your function consumes some capability, then only they charge you. Otherwise, you created as functions and they're hanging around, they're not consuming anything, they don't charge you. So that problem will not be there. So this is what we call serverless computing. This is the latest model of computing in cloud. And obviously, this quantum has evolved independently. However, they are not available to everyone. Only select users have access. So for several companies, they cannot really sell you quantum processor if you want to buy also. Okay, so only select quantums are there. What can they do? So therefore, they have attached those to some of the servers in the cloud and then making access to, providing access to those as quantum as a service. So now quantum in cloud. So there are some technology. So this is what now is 124, this quantum as a service. Okay. So this is how various conceptual and what. So today if you look at research in cloud computing, so primarily most of the people are doing research around this area. Okay. So primarily here, I'm trying to push them to here. Okay, so these through some technology we have. Now, if you look at the real world, over these 10 years, so most of the people, most of the companies were focused on the insurance service or this application services, which is called SaaS. And some of them in the past. This was there. But now there are another layer, some more layers are introduced. The latest layer is SaaS. Function is a service. This actually relies on service, that serverless computing. Function service, already number of solutions trying to promote the use of this model of serverless computing for building applications, and then of course people are moving to other models. So that was practical things. Similarly, so those who are doing research, research if you're doing a research on say cloud resource management for big data applications or big data analytics. So to do real research, so it is very difficult to have access to large number of servers. One is in cloud. So usually various providers they limit you. Okay, we will give you 50 or 60 or 100. So if you want 200 servers, you have to make a special case. Otherwise, if somebody might occupy the whole server, then it's not available for others. So therefore, they are restricting. So henceforth, if you want to conduct a big experiment, the large facility might not be available. And even if you have got, you may not have a large amount of money to be able to rent those. And even if you can do that also, then it is very hard to conduct repeatable experiment. So when you're writing some papers for a conference, you have to conduct experiment under various scenarios, but you cannot have the repeatability in the real cloud environment. What do? You go for modeling and simulation approach. Okay. So in 2008, we developed something called Cloud Sim, the cloud simulator. This simulator was primarily supporting virtual machine. As a concept of evolving, something like a bit more advanced network, we had network capability. Then containers came in, we added containers to Cloud Sim. And as this IoT application became popular, the edge computing came into picture. Then we added this IoT simulation, which we call IoT. Then when the SDN came, we added two in SDN. Then of course when serverless came, we added also the service computing. Then now quantum came, very popular. So therefore we also added what is called QPU, quantum processing unit, and quantum circuitry expression. So this way you can also do whatever research you want to do by combining cloud and also quantum capability and looking to the future generation research. Okay. So this is even the simulator of Java. So this simulator already has more than 6,500 users. So actually maybe more than 24 users, but at least 6,500 people have written paper that is published and indexed. Okay, I'm only counting those. So many people around the world. They may be academicians and university people like here, but also company people like Ericsson. Ericsson in Bangalore, Ericsson in Sweden. They use CloudSim for modeling the future mobile application services. Then IBM also uses for the purpose. The person in IBM Delhi, she was working using this 10 years ago. At that time, she was a senior scientist. Today, she is a CTO of IBM. So people also grow in their career along with advances in cloud computing, along with advances in CloudSim also. Okay. So then of course other technology trends, as I said, the software engineering moving from service oriented first monolithic, then to microservices, the second generation. The third generation is the service oriented, the third generation microservices. Now there are many applications out there. Most of them are written in Python or Java, made up of lots of classes. And if you want to transform that application into microservice application, so most of them are doing manually. Manually looking into all the classes in the application, then identify those that can be clustered together and make them as a couple of microservices, then deploy physically, manually, then manage the execution. That is one way of doing. Other way can be, you can do some research in software engineering, develop the tools that unlock this code, the entire code, then identify those related classes and then cluster them and dynamically create them as a microservice and dynamically deploy, across distributed environment. And also some of those services can be have replica. Why replica? If one of the microservice fails for some reason, whole applications would not come down. So we should be able to tie that request to another microservice that is alive and can support similar capability. So that is software engineering. Then coming to what we call, that is we are offering healthcare as a service through cloud. And we want services that are trustable. Right? If my health body is taken and processed on the cloud, and then I get back responses recommending me what kind of tablets I should take. Obviously, can I trust this result? If someone has tampered my input data or tampered the result, then of course it's very dangerous. It might be a poison actually instead of a medicine for me. So therefore, we want to create trustable services. And how can we do that? You can also use blockchain. And in this blockchain to change your data all the way from the data source to the processing, then of course the results come back. So I was just coming there, I saw one MDP blockchain, the future of cybersecurity. So, the Ministry of IT was talking about such an initiative. This blockchain is an important concept. You can use it in integrating the IoT, edge elements, and the cloud elements, and of course, depending on application type, that level of trust you need to provide. Accordingly, you can enhance that complexity of the blockchain encryption algorithm, algorithm. So these are trends. Now let us take a look at how does they impact on the architecture. So if you look at the cloud architecture at high level, at the bottom we have many physical servers that are interconnected. Ultimately, we need to have physical servers also. And then these are virtualized through virtual machine, and the network is virtualized through SDN. Now coming to the user make a request to cloud. So here we go on admission control. So admission control can look into what is the expectation of users. So accordingly, say if you can honor that request, that depends upon how much resource you have, how much you already committed to other users, and what is expected of users. Can we admit given all those? If yes, let's say request is admitted. Once the request is admitted, let's say we create a virtual machine, and these virtual machines are mapped to physical machine. So this process of mapping virtual machine to physical machine can be complex. So for example, if you got an application having 10 independent operations, then it is okay. You can have, say for example, map those operations into each virtual machine, then there can be mapped any physical machine within data center, no problem. So, but as you know, in the physical data center, so these servers are hierarchical topology. Like you subnet 1, subnet 2, subnet 3, and then finally come to the root. Suppose if you happen to place, just say, let's say one virtual machine here, one here, one here, one here, just across the whole environment. So if the independent tasks are there, no problem. So it's all right. But if you have got application that where inside tasks often communicate, they communicate very often some messages. If they are communicating very often, and if they are at different part of the network, what happens? The number of hops they need to take to reach out can be multiple. So if they are spending so much time in communicating itself, the performance of your application degrades. So therefore, what do? Having knowledge of that application structure, I can map those virtual machine to physical machine in such a way that preferably they are in the same subnet, and then with one hop you can communicate. Okay, so this is called topology aware mapping of. Okay, with time, number of users can increase from 100 to let's say 500. So at that time, what do? So when we increase, at that time we need to provision more resources either within one data center or across physically distributed environment. So these new users, imagine, so the old users that we started with, maybe just they are in just Hyderabad. The new users that we are discussing, maybe they are coming from Bengaluru. If they are coming from Bengaluru, so should we map all the requests to here? Number one question to ask. Second, if they are large number, if we map to here, then maybe the quality will suffer. Therefore, what do? We can actually create more virtual machine in other data center in the Bangalore, then move some of those operations there. So this way we can serve users very easily. Okay, so this is how most of the service is supposed to be architected. In fact, that's how we have done. Even the things such as the Facebook application is also managed this way. And the users are coming from all over the world, so it is necessary to scale very easily. Then of course with time, the demand can decrease. So if you have an application service during peak hours of the daytime, maybe about 5,000 users, then during maybe 9 p.m., then you have got only 3,000 users, then midnight, 12 o'clock, only 2,000 users, and early morning at 3 a.m., only 1,000 users. Then of course some people wake up at 4 o'clock for Mangalarati, then it increases, correct? So this way we got many users are expanding. So accordingly we should be able to organize and provision resources so that we can meet the requirement. That's up and down. And having this property of cloud is called elasticity. Is that okay? Okay. So this property of cloud to be able to expand or shrink dynamically is called elasticity. So therefore some people call it as elastic computing. Be able to dynamically switch from handhold machine to Scala machine. So this way the comfort level will increase. You can also speak very nicely, freely. So similarly, what are the benefits having elasticity? Benefits are first we can use resources efficiently. Okay, unnecessarily we don't occupy unless we need them. Second, benefit is cost efficiency. If you are not holding on to resources and you don't need it, you release. So that way you don't have to pay for it. So that is the second benefit. The third benefit is energy efficiency. The cloud data centers are like a power hungry. They are consuming huge amount of power. For example, a typical data center, cloud data center consumes energy equivalent of Hyderabad city. Okay? And today, worldwide, there are more than 10 million such big cloud data centers are there. And how much energy they are consuming? The combined energy consumption of all these data centers is more than country like India. Okay? So the massive amount of energy consuming. So therefore people are thinking of not putting the data center inside Hyderabad city. They want to put in Rajasthan desert. Because there is a lot of solar panels, solar energy is available. We can put out the data centers. So even the Indian government or India is thinking that they are the next superhighway. Now there are so lots of superhighways, highways are being built. Similarly, we need an information highway, and the information highway is cloud networks. Okay, so lots of is happening. So this way, how do we manage those in an efficient manner so that we can provide service to the users? So not only at the infrastructure level, but we also need to think in terms of application level. As you all know, so when you develop an algorithm for effective fast rate transformation or sorting, searching, any of these algorithms, the goodness of application or goodness of algorithm is measured based on time complexity and space complexity. In fact, if you write a paper for a conference, unless you have got this complexity analysis, paper will get rejected. Right? Mostly we look at only time and space complexity. And now the next level of papers should also have what is called energy complexity. So maybe this conference BDA 2030. And if you write a paper on big analytics, they not only ask you how good it is in terms of performance, how good it is in terms of memory consumption, also how good it is in terms of energy consumption. Can you build an algorithm that still do analytics of the data and consume small kilowatt? Correct? Electricity bill is very high, it's not free. In fact, the electricity price is increasing every day. Compared to the computing, the hardware cost is decreasing slowly. Whereas the electricity cost is increasing. So therefore, people are happy to give you free server. As long as you can give me server too. Correct? So if I buy a server, I'm very happy to put in Satish home. He can use the server freely, but pay for electricity. Because it is more costly. So therefore, we need to think in terms of building energy efficient algorithms also. Okay. So now coming to application. So not only able to scale out, scale in very easily, but we also need to build our application that can exhibit this property. Correct? If I am provisioning resource, what is the use unless the application is designed to harness it? Okay? How do we build those applications? Even the people also, the people with specific capability, sometimes they can also select themselves, they can also expand. Sometimes you may have seen, I noticed in one person, so there was a small box, like this, only this much box, this much box. And this fellow with his Astra-Siddhi is able to go inside and go, hide there. So just like Hanuman is able to become smaller than smallest, Suksha Padari, Shai become, then become bigger than bigger. Bigger to look for the Lanka Jala, like that. Therefore, we also need to be able to build cloud services that are Hanuman compliant. If you build a cloud services that are Hanuman compliant, then what happens? Your services will be very efficient, they will consume very less power, and there will be less cost, and this is very good for everybody. These are climate friendly. Right? These as we talk about climate change. And these cloud data centers are the biggest contributors of climate change, even bigger than aeroplane industry. So therefore, how do we build such a system, such application? So now coming to that application engineering. So I will discuss about this Aneka Cloud Application Platform. So this Aneka is a cloud application platform especially created for elastic application. So we build application that can expand or shrink. So based on requirements of users, the quantity of service requirement from the user, accordingly you can deploy. So this Aneka comes with two key components. One is SDK, other is runtime machinery. A software development kit that has got various types of application models that it can use that can exhibit this property. So such as thread programming, thread model. So how many of you know thread programming in Java? Many, very nice, very good. So when you build your application, the threaded application in Java, so let us say that an application has say 200 threads, then you want to deploy on a server. So a server may be having, let's say, 500 servers, 500 cores. So it's what you can deploy. So when number of users on your Java application increase from 500 to 10,000, then you may need more capability. So, but your Java application, standard Java application, even though it is multi-threaded, it can run within one server only. But in cloud, we are saying you can rent multiple servers if necessary to meet the application requirement. What can you do? So the Java threaded threads cannot expand across multiple servers. So this is where Aneka thread comes into picture. The programming model is very similar to Java threads. You build with Aneka threads, then you deploy. When you deploy, you can deploy within multiple servers within the private cloud, or multiple servers in the public cloud or multi-cloud very easily. And this takes care of scaling across multiple servers as you expand or as you shrink. So thread model programming. Then we will have task model programming, which is SQL single program multiple data. We have reduced the different modes of programming you can create. So using them build application. Then you can deploy either a private cloud or a public cloud or multi-cloud in a seamless manner. And in fact, the OS running on this can be Windows or Linux. So in the case of Linux, you use something called Mono. Mono or even Microsoft .NET is also they are now extending new version to Linux as well. So this way you can build this application and then deploy. So this we created in .NET, which means you can build application in theory using more than 20 .NET supported languages. They can be C++ or F#, the different languages are there. You can build those applications using any of those APIs from different languages and deploy. So this is how the system supports. Then when I go deep inside this Aneka, so what we have got this container, the container hosting some fundamental services. By extending the fundamental services, you can build task model, thread model, map reduce, and so on. In the future, if there is a better way of expressing quantum application, today is very primitive, we'll discuss soon. So, but in the future, you will come out with very nice abstraction with which you can express quantum tasks very easily, and that becomes a new model of programming. Then you can easily implement for Aneka. Here, there is a new model of programming. Then, of course, you can map it to wherever available. So, this is where you need to write your own scheduler. So, this approach of Aneka supporting multiple models of programming and deploying across multiple clouds is very unique. We have got both the Indian patent and US patent and Australian. And 18 months ago, we have licensed this approach to so many IT companies that you can think of. Why? Because as the cloud computing has evolved, and more IT, the cloud platforms of IBM, cloud platform Microsoft, cloud platform Oracle, and so on, they are supporting something like this. And then the key is with us. That key we took it in 2007. That was created at that time. So that's why they have licensed this. Otherwise, companies won't license that easily to the companies. Anyway, this is the innovation. So this way you can deploy in private and public cloud in a seamless manner. So this Aneka is evolved over a period of time, supporting different applications. So the latest one being Aneka 6, which is 2000 latest one. So this is we have a lot of examples demonstrating how you can do machine learning, how you can run deep learning application, and of course IoT. So showcasing. So this is the latest one. But earlier one, if you go back, initially we started with bioinformatics and UV application. But over a period of time it evolved. Just like field has evolved, accordingly concept has evolved to support the new requirements. So now, how do we deploy the applications? Say for example, or build and deploy. So this is a simple, let's say we got a couple of servers deployed, then we have a task. So imagine, so you have a task, for example, this task is built for analyzing data coming from a camera. Now it is very common, if you go across the campus, I don't know how many cameras are here, go many places, there are so many cameras are deployed. And if you want to analyze the data coming from all those cameras in concurrency or simultaneously in parallel for real-time object detection, real-time analysis, so how do you do? It can be simple like doing a for loop from 0 to n-1, that's n number of tasks, and each task performing data analysis of one of the camera, unique camera. So this way we can process very quickly. But here, in terms of expression of programming, you don't really need to think about which machine you need to deploy. Just like say objects or functions. So you've got n number of functions, then leave it to Aneka to take care of where to deploy, how long to deploy, what is the suitable resource to do that. So it's all taken care by that platform. So this way you can focus on the business logic. Now just to illustrate how there is deployed. Say for example, let's say this is a data coming from the camera. Let's say this is a photo, and we want to analyze this image. Maybe apply some image filter, then do in real time. So what do? We can split this image into multiple segments, say 3 rows, 3 columns, that becomes 9 segments, and each of those segments can be an Aneka thread. So then you deploy. So the resources are provisioned, then the tasks are deployed, and after processing, after the tasks are processed, then the results come back. Then after results come back, of course, this result is given to application. So now, okay, one of course because we applied this emboss filter, so you can see this became a emboss. For example, if this happens to be Arun Agrawal, let us say, in 20 years time we can have a new coin with one side Ashok Chakra, other side Arun Agrawal, for example, right? So and meanwhile, whatever resources provision, they are not clear, right? So dynamically provision what is needed, how long needed, then clear them up because the work is done. So this is the way we have to manage resources within cloud environment. And this sounds very easy, but in reality, your application is very complex, very hard. Okay. So now you want to deploy this service not only in one cloud but also across multiple clouds. Multiple clouds, heterogeneous, from different companies or different solution architecture. For example, you might set up a private cloud using OpenStack, or you might set up using a Windows Azure, or maybe Amazon. How do we make sure that it can be deployed across different clouds? It is, we need adapters. Why we need adapters? So because each of these companies have got different, interface. Say for example, even electricity. If I come to here, no, electricity is there. Don't worry, just for demo. So this is my optional one. If I want to power, if I type inside, you don't go anywhere. So what do I have to do? I have to bring adapter. Adapter like this for India, insert, then it will work. Correct? So this is for electrical engineering. Although already 200 years over, but still the adapter has not gone. Adapter. Then if you go to some other country, you need another adapter. So that adapter may look like this. Right? So that will be look like if you go to UK or Hong Kong, it look like this. This is good, every universal adapter, like Aneka. But earlier, I used to have a bag with one bag full of adapters, 20 adapters for different countries. Then if you go to Europe or China, in China also 3 countries. Actually 1 country, but 3 times. In China, mainland China, then Hong Kong is different, Macau is different. Just before coming here, I went to all the 3 places, Shenzhen, Hong Kong, and Macau. Then I have to have 3 adapters, correct? So for building so many adapters for given one application is unnecessary, cost of software engineering very high. So to solve the problem, within Aneka, we have got adapters for each of these. This way you build your application once, then take care, as an unable to take care of deployment across multiple of those institutions. So there are many applications of this Aneka. So from China, from India, ISRO, then of course from Washington State University, deploying medical data analytics on the cloud. So when you deploy medical data, there are sensitivity cards. Sensitivity card has been performed on the hospital cloud. The non-sensitive ones can go to public cloud. So then also like the deep learning and so on. So here is the China Railways one. There are various design scenarios using Maya software and composing application as HTML. But before that, they were running on this 4-core server. This was taking time anywhere between 24 hours to 80 hours to reduce the time. So they set up this private cloud using Aneka. So we have a Design Explorer. Using Design Explorer, you compose an application as a SPMD, single program multiple data execution model. Then using that, when you run it on enterprise cloud here, so they are able to get the same answer. What took 80 hours, they are able to do it in 2 hours. Now, sometimes you have a deadline. You want to answer in 10 minutes. You can check the QoS parameter. Deadline be equal to 10 minutes. Then, of course, budget. Because you are using public cloud resources that are expensive or price, and different service providers charge different price. Therefore, you want to minimize the cost of computation. You set budget is equal to 50 rupees. Given a deadline of budget and deadline of 10 minutes, budget of 50 rupees, the system on your behalf identifies the marketplace, what is the services, what is the cost. Accordingly, rank them and move tasks across all of those access and then get back result within the deadline 10 minutes. So this is called deadline and cost constraint resource management within the domain. Then coming to healthcare, so in healthcare also, so these are the sensor, IoT sensor. These days people commonly have a electronic watch that can measure your various body activity, and the data comes in. So it's an app running on mobile phone, and from here, so you send it that request to the cloud environment, right? So from here, the data connection to the app to the here, and do some processing, then of course get the result. And of course, in this world, the users can come with different requirements. Those with the emergency, they define deadline of say 2 seconds, give answer. And those who are very free, they might say, give me answer in flip over. According to the price, they will pay stages. So like this, lots of requests come in, comes into the service system, and accordingly, those are provision users, the tasks are managed so that they are fulfilled. So this is how actually they are done. So that is healthcare. Now coming to this deep learning. In AI, as you know, three kinds of things people talk about. One is NLP, natural processing. Second is doing something deep machine learning. The third one is the deep learning. Deep learning can be used for object detection. So for example, there is a ready-made program for deep.py. So we cloud enabled, actually IIT students have done. So cloud enabled the deep learning program using a naked task model. So this way this program can run on the local facility, or it can run on the remote facility, or together. So these are the different cameras data coming in and results sent in here. And using deep learning classifier, we can identify what is the object of interest. So for example, this is the camera from the computer lab. The image goes here, video goes here. After processing, it is able to identify all the components that are there, including people. How many chairs are there? How many keyboards are there? How many mouse are there? How many people are there? How many are empty? How many is missing? Is there a digital mouse missing? Is there a real mouse coming in? Sometimes it is not maintained. Lab mouses also come. Some places snakes come. I heard I was at Iser in Trivandrum. It seems because it's in the forest area, sometimes even the snakes are coming. But you need to know whether snake is poisonous or good one. Correct? Poisonous one, you need to be careful. If it is a good one, if it only bites, maybe your health will improve. It will take away toxic from your body. So that is about such deep learning application. So next is last one, that is NLP. So when this COVID came into picture in March 2020, from 2020 March to say 2022 March, during the 2 years, more than 500,000 papers are written in the context of COVID. Everybody, computer science people, medical people, politicians, economics, everyone have written in the paper. Of course, any paper that has some COVID word in the title or in the abstract, in the body, so say it is a COVID related paper. Okay? So here there are already there is something called COVID-19, COVID Open Research Data Challenge, COVID-19 data set. This data set available. Suppose if you want to find out what is the best vaccine for the new variant of COVID, why COVID is not a dumb virus. This virus, as you keep on inventing new vaccine, is also changing structure. So we need to know what is the best vaccine. What can we do? Going through this 500 million paper, nobody has the time. So what we did was, we took this data set, then of course, using machine learning, the data set analyzed and pre-processed, then of course we kept a ready made one, where you can throw a query. So tell me, give me the top 2 papers relevant to this virus structure. Okay? So then you put an answer. Suppose you got 50,000 papers, it took something like 30 minutes to give you answer. Instead of that, you still have 50,000, but you provision maybe 10 servers, then you can answer in 2 minutes. So this way, based on user requirement, we should be able to serve the users. So this is an example of how we can do machine learning and NLP together for the COVID context. Okay. So Aneka software is available from Microsoft. The latest is Aneka 6. You can take from here and explore. So lots of people are doing interesting things. And of course, this Aneka also is deployed various places around the world, in Australia, in China, in Europe, and also in Nepal, in Malaysia. Various places Aneka is being used for teaching cloud computing. So these are the universities, many universities are teaching cloud computing. And here, this Aneka is deployed all the way from this Kanyakumari. So those who are from other countries abroad, Kanyakumari, if you walk from Kanyakumari to Kashmir, you can be sure that next planning state will be correct if you do properly. So anyway, this one person walked from Kanyakumari to Kashmir. He didn't get it, but anyway, maybe in future. But we have got Aneka deployed from here to all the way here, from Maharashtra to Meghalaya. Various places people are teaching to be hands-on application programming using Aneka. So this is a cloud computing concept can be learned. Okay. So next coming to the final part, which is quantum. Okay, so that's on cloud. So now coming to quantum. So quantum computing is also very hot today. How do I know it? Even the Modi is speaking about it. Okay, so therefore it's hot. So like this, there are national missions in Australia, here in India, in China, Europe, various places national missions are there in quantum computing. So India itself has allocated several thousands of crores for up to 2030. So lots of initiatives are there looking into, for example, real-time communication application, then precision clocks, then of course applications such as meteorological. There are lots of the theme research is fun for exploring the future of this quantum computing. So just how is this quantum computing different from classical? Classical we all know. So state representation at any point is either 0 or 1 within the hardware, correct? That's why we call digital computing, 2 digits. Now coming to quantum in high level, so state can be at the same time both 0 and 1. So that is just 2 bits. But if you have got in case of quantum, you can not only have these 2 bits, but you can also have multiple bits. That's called they are called quantum bits, qubits, not quantum bits. So you can have a quantum computer with say 8 qubits, say 12 qubits, something like 32 qubits, something like 256 qubits or 1000 qubits. So those many qubits, that means you can have so many states at the same time. The computation can be done so many computation concurrently within this quantum. But however, so with number of qubits, the power consumption can improve exponentially, very high. So that is why these quantums are placed in where? In the cloud environment, because it requires ultra cool environment. Okay, that is one of the reasons why today quantum is available through cloud. So as I said, several vendors are offering, so including Horizon and then Azure also. Now coming to programming, how do I program this quantum computers? This is a big problem. So the programming, say for example, let's say for 10 qubits quantum processor, qubits, Q0 to Q10. So now, so these are the qubits. So we need to manipulate the data. How do we manipulate? You apply gates. Those of you coming from electronic engineering earlier, the programming they used to give test bed, and then you take AND gate, OR gate, NOR gate arrangement. Then through the arrangement, you can create a lift controller. That is simple application you used to do. Or multiplier, adder, and so on. An interest rate calculator. correct? If you take a loan, then the input, then this processing, then tell you how much interest you have to pay, correct? Such simple application using the digital gates. Now in the quantum computing, today programming is just like that. We have quantum bits, this is called quantum circuitry, then there are more than 250 types of gates available, including simple things like AND gate, OR gate, NOR gate, HAMDAR gate. You put various types of gate arrangement, then you create that task, the application. So this is a simple gate circuitry for random generation. Like this, people have created quantum circuitry for FFT, quantum circuitry for small scale docking, quantum circuitry for small scale that financial analytics. Like that simple algorithms are created, optimization algorithm. But you can see programming is very difficult. On top of it, every vendor, every company that produces a quantum hardware, they have different ways of expressing this application. So this is for IBM Qiskit. So this is for Microsoft Excel. So you can see a very different way of programming. So this means the programming quantum computer today is very primitive. So what can we do? We can do some advancement. So that brings to our own effort. So one of them is called QFAS, that I talked about serverless computing. The same serverless model, which is realized through function service model, is used to create a quantum platform. Okay, this is called QFAS, quantum function service for deploying quantum application. But then of course we also have a simulator. So let me explain each of these in one slide. Now, the goal of this QFAS is to simplify creation of quantum application and the deployment. Okay, how do we provide? So here are the function templates. The same, the serverless computing model, function as service. So there are functions. You make your application made of a function. Some functions can be the classical code, that existing code, or some function can be quantum code. So given an application made of a function that is quantum function, classical function, you submit to this layer of the QFAS, and this looks into what type of function is this. If it is the classical, running on a classical computer. If it is quantum, running on a quantum computer. If it is hybrid, combination of them. So this way, at least the responsibility of creation of those applications, the deployment is taken care. So even when you are deploying, if I am deploying on a IBM quantum, I am deploying on a Microsoft quantum, the way you express is different. So what we have done is, given a circuitry explanation, then you don't worry about transforming that to each of these. You know, if you are building an application in C language, when you deploy the C language program on Intel, or deploy same C language program on IBM PowerPC, the code is different, correct? Below. Transform it to assembly language, down to machine language, correct? And the machine language of the Intel is different from machine language of that fellow, other fellow. And machine language of 85 is different from machine language of 86, microprocessor. Same here also, they are different. So therefore we have translation, so that we can just focus on at least high level circuitry, then the next job we do it for. Okay, this is what this system does. So this is the code available, you can download and explore. If you don't have quantum processor, don't worry, there are emulators. You can run the emulator, quantum emulator on different hardware, and you can run that whatever application you build. Also it takes more time, but at least you can learn how to do quantum application program. The last one, so this is iQuantum simulator. So I already mentioned about the CloudSIM, how it evolved over a period of time. So this CloudSIM further extended, we added this QPU, quantum processing unit, and this quantum task. When you say, so that means you can create a cloud data center made of having quantum. You can also create the edge using quantum. So this way you can do some research on edge to cloud if you like. Okay. Coming to this quantum, so quantum QPU, quantum processing unit, what does it contain? So you can think of the future. So IBM or everyone is saying that in 2027 we will have 1024 qubits quantum computer. This is a promise. This is a roadmap. Okay, but you don't have to wait for that. You can do it today. You can create a simulator within CloudSIM. You create a QPU that contains how many qubits you want. If you want maybe 10,000 qubits. Okay, then the volume. These are quantum properties. Then this clock operation, quantum operation. Then the topology. The topology is a result of all the quantum processor. So given and also error rate, by the way, the quantum hardware are noisy. So there are a lot of errors. So you also need to model that within your simulation. So given that, QPU. Now you can create any number of QPUs, make a server, this quantum server, or multiple of those So next, the task expression. As I told you, that's a qubit. So how many qubits are there? Then what is the gate set arrangement and how many layers? You define this. Given these two, now you can conduct a research on how to map such things to the problem one. And also, so let us say you build a quantum application, assuming you have got 1000 qubits. Now, you want to deploy the application, but your hardware is only 256. What do? You have to split, that is called circuit cutting. You have to cut the circuitry into multiple segments, then map that to that hardware, not the level hardware. So this is another open area of research. Because number of qubits in your applications are way more than number of qubits available in the hardware. How do you do it? So it can be done by software. You can cut into multiple segments, multiple circuits, then arrange, process them, then stitch the result together, then get the answer. Okay, then how to do this? Again, you need to explore. So this toolkit can be very helpful for doing such exploration. Okay, so let me conclude. So you can see there are several computing paradigms of promise how to make computing ready. Today, cloud computing is the one that has made reality, and we are all using it day to day. So there is a success of cloud computing. But as we move toward the future, new challenges are coming in, new class of applications, new class of hardware, new class of platforms. So that way we need to advance that field. Then I talked about Aneka, so one of the platforms. So here the focus is on minimizing the cost of software engineering. So the platform that can be used for exploring such things. Apart from that, can deploy with time optimization, cost optimization, and so on. And I gave just 2-3 examples of from engineering, healthcare, and of course that machine learning and deep learning. So then coming to quantum. So quantum is just in infancy. This is just like baby born. But you want baby to run Olympics, correct? So this research is about switching from the baby to the Olympics. So next 20 years. So very important time. Whether you are looking at machine learning, people are now looking into quantum machine learning. If you are writing a proposal in machine learning, right? Proposal for quantum machine learning get accepted. Very hot topic. So many areas. So you can come to quantum. So very right time, very infancy stage. So good time to do research. Okay, so I'll skip this part, and if you want to learn more, there is a book if you are new to cloud computing. So this book is $100. Don't worry. So we have India edition. The latest just came 2 months ago. Actually 3 months, right? 3 months, 4 months ago. This is available just for $8 only. Actually, that's in there. And if you go to China, don't carry book from here. It is available at lower cost there only for $3. You can learn in Chinese language there also. And if you don't know English, you don't know China, you don't know anything, but if you know Hindi, soon you will get this book in Hindi also. Okay? You don't know Hindi, but you know Marathi, you can learn Marathi also. Okay? These days people talk about Maharashtra, government formation, who is the chief minister, suspense was there, but solid suspense. But anyway, Marathi also available. Maybe soon we will bring in Telugu also. Telugu as well. Okay? With that, let me stop here. So thank you very much for hearing this.
Thank you very much, Ras. As usual, excellent keynote. Okay. Any questions? Yeah, as usual, excellent presentation. We have had you from a number of times. You mentioned about a concept called SPME. Is that used in Netflix and Amazon ride sharing?
Which one, P?
SPME, single program multiple solution.
Yes.
Is that used in Netflix and Amazon ride sharing?
So this SPME, single program multiple data, is useful for formulating the legacy application into cloud application. Yeah. So that is what we also support. That is as called the task mode. So this is very useful because there are already so many legacy applications are there, and you want to bring them to cloud environment very easily. Instead of transforming that application into message passing and converting, that takes too much of time. So this SPMD model that we support along with the graphical tool, so helps you to compose very quickly. So that is how we did for the channel investment.
So are they using it? Are they using this kind of concept?
Also for deep learning. Yeah.
Are they using this concept?
Yes.
Okay.
That's why the China rails are running very faster. If you go from Beijing to Shanghai, by airplane it takes 2 hours, 2.5 hours. And then of course that excludes time to go from home to the airport, then airport to home. But if you take a China train from the center of the city of Beijing to the center of city of Shanghai, it only takes 4.5 hours.
That's maglev, right?
We can go faster thanks to Anika. We are hoping to help Modi to build a better Vande Bharat in the future.
So you actually, one of the problem is power optimization, you already mentioned. So as a programmer, I got an algorithm. I want to optimize the program with respect to power. Where are the opportunities? Where are the opportunities for optimizing power? At the disk level or main memory level or network level? Can you just highlight that? So,
In terms
of optimizing the power.
Power. Energy optimization.
What are
For example, I got a sorting algorithm. I want to optimize energy on cloud.
Yeah.
Where we have to go to disk level or main memory level or bus level or network level,
Yeah.
or how, or what are the abstractions?
Okay. So first to understand, when we build cloud service, so we are offering the service to multiple different coded service. Some people want quick response time, some people want maybe in 10 minutes to 15 minutes. Now that is a high level requirement. And coming to the cloud, we want to reduce the energy consumption of those services. Okay? So within the hardware level, there is something called DVFS, dynamic voltage frequency scaling. So you can do that scaling at the hardware level, you can do at the level of memory, you can do level of disk, you can also do the network. Now, how do I decide what level I need to operate? So that depends upon the quality service that I am offering to my user. If some users are emergency, for them you might set it to the highest DVFS level, but the energy consumption is exponential. No problem, because the goal is to provide quick response time with the emergency, energy consumption is the least bothersome at that time. So you set at the higher level, then you can offer service. Now other users, that the many other users are coming in, and their expectation may be not that high. So maybe response time expectation maybe maybe 5 seconds request. So that's the high level. So now what we can do is we can set that DFS scaling from the top level to maybe in the middle. When you bring in the middle level, the energy consumption is not just half, maybe only 10%. So now, depending application type. If it has some compute operation, you set to the lowest level CPU. Then if it has some memory operation, bit lower. And if it is networking, data flow is very slow requirement, then you set it further down. So this way we don't have to operate everything at high level. Now whose responsibility is this? This is all responsibility of the software. The hardware vendor basically gives you all these knobs for you to operate. So you need to build the necessary future generation, whatever, those that can understand the user requirements and accordingly dynamically configure those parameters. Yeah. Yeah.
Yeah. For example, if I am developing a pattern mining algorithm, data mining algorithm, clustering algorithm, I have to consider all these options and develop all the things. That's what I'm saying. Otherwise, how can the Aneka will use it? You can't develop and go and clustering algorithm.
Yeah. So let's suppose you are an Aneka, but there are other things that we have done where the dynamic management of the configuration is one way. Other is even at the level of virtual machine management. Suppose a given demand, overall service demand on application is like this. So for that purpose, I provision say 50 servers. When number of that demand is very less, then I actually reduce, then cut down those, then another happening. So that is at the level of service delivery, high level. But when it comes to one application with lots of requests, so there you need to dynamically configure. It is not application job, it is a job of underlying platform on which this application is built. Correct? Otherwise, application user need to do many things. That is too much cumbersome. So shift it to the underlying platform. So this is called emerging array resource allocation techniques. Yeah. So this is what actually people do. That's the reality.
Thank you. Manas, for your information, we are also live streaming this one on YouTube. A question which is almost similar to this one, that is why I am just repeating it. Someone writes, like, is it not a better time, is it not better, the time and space compressed
energy efficient, is it automatically energy efficient? It depends. Okay, to certain level, yes, it is true. But if you want to do, the way data is traversed, you know that those who are looking at operating system, if I have matrix A, matrix B, then I want to say matrix C is equal to A multiplied by B. Okay, depending upon row traversal or a column traversal, and depending upon my hardware architecture, with the way data travels, it can change. How many phase faults occurs. If there are too many phase faults occurs, you consume a lot of energy. So therefore, if you are aware of this, you might do traversal in such a way that minimize the phase fault. So that means you are energy conscious, not only performance conscious. Okay. So these are not actually relevant, but one more energy is part is also important.
Perfect. Thank you. Any other question? One last question.
Hello, sir.
Yeah, until whatever 8 p.m. It's not clear.
So you were talking about, in the last you were talking about building the virtual machine for quantum computing.
Yes.
In QFAS, when you are showing the slide, is it actually a virtual machine you are trying to build for various quantum computing operating systems like that?
Yes. Okay. So QFAS is a working system. So we have explored on IBM quantum hardware. We have explored on Microsoft and Amazon and a few others also. So what we have done is, we took some of the simple application deployed. So right now, when you deploy a quantum task, let's say for example, you submit to the IBM quantum. So they are queued, then processed. So this is a real platform running real application. In addition, we also explore on our own macro cloud, wherein we deploy emulators. We deploy emulator, and then you run your quantum circuit as emulated hardware rather than the physical. But if you do an emulated hardware, it will be very slow. But for testing is hardware. But this is a software available for you to really download and explore as well. So a number of people are already doing it. But coming to, sometimes people confuse between this QFAS and the iQuantum. iQuantum is a discrete event simulator. They're not emulators, they're discrete event simulator. So you can create a QPU, you can create a quantum task. There is no real execution there. What we do is, say for example, this circuitry, suppose this operation, we know how many operations we will perform, we just jump a clock. Okay, so then it's called discrete event simulation. So please note that between simulation and operation. Okay.
So one last question, after to the presentation.
So what?
For typical operating system, we have POSIX standards for maintaining threads and all. So when it comes to quantum computing, do we have such standards in execution?
Yes.
Is the parallel also POSIX and all?
So the quantum hardware people, they provided the interfaces. There is no OS, but the interface is provided. So we need to build all those OS capability, compiler capability ourselves. So there are people who created even the translator, the translating this quantum circuitry to IBM, quantum circuitry to this one. So we use many of those tools put together and made a function platform. Yeah. So there is one something called Muni Quantum Toolkit. So these people have built these translation programs. Given a circuitry, they can generate it for different hardware. Yeah. Now, if the hardware is not standardized, the interface is not standardized, there's a problem. Yeah. So this is just in the beginning. So therefore, we don't worry too much about standardization at this moment, right? So we worry about advancing. So for example, one hot topic is how do we create a reliable service on the noisy hardware? Even in networking, if I'm transferring a data 8 bit, transferring from one server to another server. So the 7 bits are the data set, so data information. So the 8 bit is checksum. So if the data transfer from here to here, if there is a fault in the data transmission one of the bit, using checksum we can correct it. Similarly, we need to now think in terms of how do we build reliable quantum computing on top of unreliable hardware. So who can do it? Software. So there is a research project.
Yeah, interesting comment, Professor Krishna. Okay. In the interest of the time, let us close the session here. Thank you very much, Lars. Again, thank you. And I'll hold you as long as you want. Okay? So, for example, like
Read the FPA. Okay.
Okay. I'll take on the read.
You want. Then you
Okay.
So let's try to gather as soon as possible. Say for example, this is a 15 minutes, let us say 10 minutes break. Okay. So early in the morning, today it is a very long day. Okay, we have a program until 10 o'clock. Okay. And the 15 minutes delay already from the first session itself makes it that you will have to.
Let's start the session 4. Hello everyone. Welcome to the session 4 on big data analytics. Okay. I will be the session chair for this one. I am Professor Raghib Udaykiran from the University of Hyderabad, Japan. In this session, we have 3 full papers. Okay. I can find 3 authors are here. So each paper is a full paper. So each authors are requested to use 20 minutes of time for presenting their work and another 10 minutes for Q&A. Okay. Thank you very much. So let us start the session.
Thank you, sir. My name is Srinivas Meropalli. Currently, I'm doing PhD in School of Computers and Information Sciences from University of Hyderabad. Today, my topic is Dynamic Deployment of Serverless Data Pipelines and Problems. Today's presentation organized as follows. First, I will talk about what is the dynamic deployment and Tosca. Then I will move on to the introduction to what is the serverless data pipelines, and then we will see how to deploy the serverless data pipeline dynamically on problems. Then first thing, what is a dynamic deployment? When we see current IT industry nowadays, it is going through a lot of changes frequently, like service scaling, interoperability, new modules are coming, deployment, and data migration. All these tasks are expected to be performed quick enough to meet the business requirements. When we see IT engineering, as its role is to execute hundreds of commands daily in a sequential order to set up the IT infrastructure, like provisioning the service, provisioning the servers, virtual machines, hundreds of virtual machines, installing operating systems, and providing a runtime environment to run the services. All these operations are very critical and complex, some of them. When the software grows longer and longer, making all this in a manually is very hectic. So the solution is to make it all the tasks are in an automation way, then it will have to reduce the human effort and increase the reliability also. And moreover, it's provide the consistency across the different environments like testing environment, production, and development environments. So the dynamic deployment is a concept of deploying or undeploying the software component on the remote host on demand.
Let's see some of the deployment tools we have currently. When we see here, the below of circle representing some of the open source deployment tools like Puppet, Chef, Ansible, Terraform, CE Engine. All these deployment tools are supposed to allow the developers to deploy their code in all kind of public cloud platforms like Amazon, Google, and it allows to deploy the services in a private cloud also. In the figure, if you see the above circle, some of the cloud providers, they also have their own deployment tool like Google Cloud, DeployBot, AWS Code Pipeline. These are the proprietary deployment tools. Each and every cloud platform has their own CLIs to allow the developers to deploy their code on their IT infrastructure. But when we design any software by targeting a particular cloud platform, we can't shift the migrate those applications into another domain because there is a vendor lock-in existence. So we lost the lack of flexibility here. So basically here the problem is vendor lock-in nature, and when we want to design a complex software, like in the evolution of the microservices, we have seen a lot of applications composition of multiple sub-modules. These modules need to communicate with each other and they need to interact and they have to exchange the data among themselves to meet the required software application or required software services. So to design such applications, there is always a possibility of dependencies. Like for suppose if you want to install a serverless framework, we need underneath we need a Kubernetes platform or platform engines. So what's the solution? There is a vendor lock-in nature, and if we have a complex application, how are we going to deploy these things? So the solution is Tosca is a topology and orchestration specification for cloud application. It addresses the issue of the application portability among the cloud providers. Basically, Tosca allows us to developers to model their cloud services in the form of YAML file. This YAML file contains the different sessions. The main primary sessions are the node session and the relationship sessions. Node session contains the node properties, interfaces, and characteristics. And relationship sessions contain the relationship between among the different components and the relationship between the nodes, one node to another node. All this type of configuration you need to provide in the service YAML. This topology and orchestration works together, allows the automation, the entire life cycle like service creation, deployment, running. So once we set up with the service template, we pass this service templates to the Xopera. Xopera is a open source deployment tool which can be installed in all kind of operating systems like Unix, Apple, or Windows. And basically what is that is make a service template using a Tosca parser. It will perform some of the tasks like rendering, translation, and validation. Once the service template is perfectly valid, the Xopera starts executing the commands. It internally uses an Ansible deployments tool. So based on the design which we mentioned in the service template, it will deploy the service component on the particular cloud platform. Let's see some of the related work happening in this domain. Within the first paper, here the researchers designed a task framework which will identify the suitable cloud platform for a particular application coming with some specifications. They focused on there are done the two ways. One is a containerized way and one is a classical approach. When we see the second paper is a forget framework. Here this work the researchers extended the Tosca standard framework onto the fog layer level. So here they deploy the fog services on the fog node, and their main focus is the service interoperability and portability. So they tested a climate change application on this in this work. Next, when we see the Tosca data, modeling the data pipeline application in Tosca. Here, the researchers are deploying the software components on the two cloud platforms, and their main focus is to, by providing the required environment to run the pipeline tasks, that with the help of the Tosca, they deploy it dynamically and check how the workflows are going between the one cloud to another cloud. Let's see what is talk about some of the cloud edge cloud modeling. Now we are moving towards the serverless computing. Why we need a serverless computing? Here I will talk about. You can see this particular diagram. In the edge layer we have different IoT devices like camera, sensors, and mobile. All these devices are continuously or periodically produce the data. This data is to transfer to the cloud layer for the processing. So at the cloud layer, once the operations are done, it sends back the response to the actuators. So the problem with such type of edge cloud model is here we require a strong end-to-end connectivity between the IoT devices and the cloud. The cloud resources are existed very far from the edge devices, which incurs the latency. And moreover, edge devices are suffered with the they have very limited bandwidth, and you see the limited energy also. So for the real-time applications, this type of modeling is not good. So in 2012, Cisco comes with a new computing model like fog. Here, fog layer acts as an intermediary layer. Sorry, the fog layer acts as an intermediary layer between the edge and the cloud layer. And instead of sending all the data to the cloud layer, perform some of the operations at a middle layer and in the fog. Fog can consist of any tablet or router or servers, any kind of devices can be a fog node. So let's go to what's talking about the serverless data pipeline. When you see a data pipeline is the concept of injecting the data from various sources into the system and transferring the data from the source to the destination. In between, there are some of the operations are performed like pre-processing, analysis, transformation, encryption, decryption. There can be any operations. So here the output of the one task sending it as input to the next task. But like this, it goes in a chain way, and finally, whenever the information extraction, we will store it in the warehouse for the further analysis. So, what is the need of building such system on a serverless? If we build this system on a serverless infrastructure, we call it as a serverless data pipeline. The reason is the need of why we need to build such a system on a serverless infrastructure. The reason is serverless offers some of the advantages like this provide on-demand resources. So as a developer, we need not to configure all the servers. So and moreover, serverless is event-based, and it's also very auto-scaling. So like whenever our code is using resources, then only we will pay. Otherwise, we don't have to pay anything. So when we see here the serverless data flow, at the bottom layer, we have multiple IoT devices. Here we start the data acquisition at different nodes, and with the help of a gateway node, all the data is transferred to the gateway node. The gateway node acts as an intermediary device between the higher nodes, and it will transfer the data to the other node. We say that we can't perform all the tasks at one location. So some of the tasks may computationally intensive. For those type of tasks, we need higher computing resources. Further, we are going higher by higher. And like this, our gateway also interact with the cloud layer, and if we require any high computing power, we will transfer those, we will offload those type of tasks onto the cloud layer. Once processing is finished, we will store the data in a particular storage servers. So here we designed and developed one of the use case called a serverless use case. Here, this is a use case structure. Here we have a camera, serverless camera. With the help of this camera, we are periodically capturing the images. This camera is installed in a secure premises. And here we have performed different 5 types of tasks like image capturing and compression, image research, object extraction, and sending an alert. In any captured frame, if we find an object, human object, we will trigger a Gmail notification to the particular administration to make him alert. So when we see the model topology, here we have a system which have all our resources, and this is a Android topology. In this particular use case scenario, we have 3 Raspberry Pis and 1 camera. Camera is attached to one of the Raspberry Pi, and on the Raspberry Pi we are performing 3 tasks: image capturing, compression, and resize. For object extraction and sending an alert task, we are dedicated these 2 devices, desk 1 and desk 2. And finally, if we find any human in the particular frame, we will prepare a Gmail API and it sends a alert message to the user. So this is our Tosca template regarding the surveillance application. Here we see the inputs are, we have taken 5 nodes and the type is string. So this is regarding, we are defining. We are passing an input from a test file here. Then we have, this is a node template. Here we have tag is good Tosca node template. We have different node types like compute nodes, server nodes, and databases. Here we are considering as a compute nodes. Once we define all the 5 nodes, we are talking about start configuring. First, we will see about the Pi 2, setting up a Pi 2. At a particular location, we are keeping all our required scripts. Then, here we are installing the required random environmental track to run surveillance application. We require JDK and Mosquito broker and the clients. And Pi camera is the Python modules, we require some of the Python module. Once we have all the requirements, then we start executing our scripts. These are the order we are going to execute our scripts. And then here the requirement to deploy this one is the particular node has to be ready. So that's our requirement. And like this, we are setting up all the 5 nodes. So this is our hardware and software configuration. We use the Raspberry Pi model 4, and these are the installed technologies. Mosquito broker. I will talk about these things when we see the at a flow. Here we will see. So here we are capturing, and the captured images are pushed into a one of the topic of a mosquito broker. And here we are running a one QoE algorithm. This algorithm figure out what is the best possible node to perform the image compression. This is our particular next task. So once it selects a particular node, and at the particular node we are sending a one token. Once the token reaches to the selected node, it will start fetching the image from the topic, MQG broker. And here we are going to perform the compression of image 1. And at the parallel here we are running a QoE algorithm which is going to find out what is the best node to perform the next pipeline task, that is resize. Once then here we see the image is compressed. The compressed image is pushed back to the one of the topic. Once here in a particular way where we are running a QoE for a resize operation, it is going to select one of the node. That node going to fetch that compressed image and it will start executing the resize. And the same way, we are performing running the QoE application for image extraction also. Then this way the image here node 2, desktop 2 is selected to perform the extraction operation on image 1. If the image contains any human object, it's going to trigger a Gmail service and it will send a notification to the user. this is the entire software flow of this design application. And when we see the different templates, we are considered three Raspberry Pis and two desktops. Like MQTT broker is hosted on Pi 1, and publishers, MQTT publisher subscribers are hosted on all the nodes. And there is a dependency because this publisher has to push the data onto the broker and it has to retrieve the data. So there is a dependency, so we call it depends on. Here you see in the desktop, we are installing the mini cubes, and on the top of it we are deploying the OpenCast framework, and the publisher subscriber also need to connect, depends upon the OpenCast has to first start. So this is the service template. And when we see the deployment order, first we are starting up with the Pi 2, then Pi 3, desktop 1, 2, and Pi 1. We install it's running the broker and publisher, minikube, and then OpenCast panel is from the. This is the order. We need to execute the events. And then the deployment way, same, in the reverse way. So the deploying this entire application is took 100 seconds, for the deployment 600 seconds. So the conclusion is, here we designed a serverless data pipeline from the edge fog and cloud, and we deployed this serverless application with the help of a Tosca model language. With the help of Xopera, we deployed all the services on the fog nodes. These are the references. Thank you.
Any questions to the speaker?
Okay, that's a nice detailed presentation. So how it is currently saying dynamic deployment of the fork environment. How difficult would it be to extend this into the age environment? Because according to the hierarchy, okay, so according to the compression hierarchy, your age environment and your fork environment both are different, right? So how difficult would it be to extend the same to the or deploy the application to the edge environment? Do you need to do a lot of development work, or with the same development work we can also extend this one to the edge environment, the edge devices?
To extend this work onto the edge devices, we need edge devices need to be capable to execute the task we can able to deploy it. Because this Tosca allows us to deploy the services on all kind of layers. So some of the papers we have seen, they are extended to the fog nodes. Now as an edge layer, we are considering it as a device where the data is producing. So if the data is, the devices have a computational capacity, definitely edge also having computational capability, then we can deploy this one also. We can extend it. The difference is when we are running our services in isolated environments like containers, you don't see any difference. But as a developer, we have to figure out which task we need to run it on edge, which we need to run it on fog, which we go for cloud. Based on the computing requirement, we need to choose the platform.
So in terms of performance, when you are doing dynamically deploying this data pipeline, what performance gain or efficiency achieved? Can you please tell us about that?
Okay. Here, when we see in a timeline way, if we don't automate this process and
remotely connect to each and every device and setting up a runtime environment, this all takes a lot of time, right? Here we are remotely on demandedly we are deploying our services. In a complex way, if you talk it in terms of time, it will save a lot of time. Or if you think about complexity time in an algorithmic way, that depends upon the application, the task which you are running. So your question is regarding time, manual effort, or
Yeah, in terms of efficiency, maybe in terms of time, so for example, in your case, the application you chose, did you analyze that time in terms of time, for example, latency or whatever?
yeah, as I said, to deploy all these services, we took around 100 seconds. And the deployment is took 600 seconds.
So in terms of efficiency, how much do you have quantification? Like
Efficiency. Okay, when you talk about efficiency, like we have this Exo currently uses Ansible, right? This Ansible is agentless. So that means on the desk which we have a resource, we just install this Opera. No need of you install any other software on the remote host. Those remote hosts just need to allow the SSH connections anonymously. So we can able to parallelly deploy our all components. So it's agentless. So effort wise, reduces a lot of time.
any more questions? No? Okay, I have few questions. First one is, when you are in your results, there is no experimental results. Have you done experimentation?
Yes, sir. Yeah, we have an experimentation. That is another paper. That is yeah, the workflow you asked, right?
No, evaluation, like how many images you took, how you asked. There will be experimental setup and experimental setup.
Yeah,
Have
yeah.
you done it?
Yeah, we have done, but that is right now on the company. Here we are focusing on this deployment. The experiment usually talking about how many images we are capturing, the complexity, memory usage. That one, sir? That one, we run this one around 100 images.
Generally, anyway, deployment and experiment are collected in the work paper. You cannot separate.
Yeah, but yeah, yes.
Next one is, I am new to this topic. So can you go to slide 20? Yeah. So in this, which is fog and where is the computation happening? Because I don't see anything here.
Computation happens at these 5 images on this desktop.
So desktops are like servers at the
Yeah,
edge.
desktop.
And what are these files? They are also fog because fog will generally the computation happens in the switches, right?
No, we are testing all this is a form. This is all remotely somewhere else. From here, I am deploying these are the resources I have. I want to deploy my services, right? All the services in this mission. So these missions are somewhere else. So I am deploying my services on the demand over the fly on this topology. We are setting up the connection arrows and first which the help of a toaster. There I configure here. Here I configure what to run. The events, the sequence of events, here we mentioned it. So as per mentioning, once the code is deployed on the hardware topology, we start running the PyCap. This will start capturing the images and this object extraction performed with the help of communicating all these nodes.
So when this happens, there will be, because the communication is there, there will be increased time, computational time. Because we have to find the right piece, what we have to do.
Yeah.
So how much you are sacrificing the runtime?
So it's a trade-off actually, I agree with that one. Because it is a pipeline, right? If we design standard pipeline like task 1, task 2, task 3, each and every image goes to the same order. If any one of the device has a bottleneck regarding the resources, then it's a stuck. Images are in a queue here. But here I have few more available resources. These are useless. if it not going in a dynamic way. So that's why we are doing, figure out which is the best node to perform the operation. This is dynamically checking what is the CPU available, CPU, memory, what is the round trip time, and the access also. So based on these parameters, we are dynamically allocating the task.
Can you go to the computation? Last question. So here you are talking about X opera orchestration. Where are you using it? I know
X opera orchestrator. Actually, the X opera orchestrator should be on here.
that you never given told.
I here. Sorry.
No, it's not there, right?
Here not there, but see here. Once we deploy, once we design our service template with the help of X opera, we are deploying a particular any kind of topology. This is my topology here at the the remote host. This one.
Thank you. Any more questions to speak? Nice presentation. Thank you very much. So now we ask the second speaker to come.
Good morning, everyone. My name is Prashant Bhavna. I am here to present our local matrix factory scale data using our approach, block-based and BDA acceleration. So, quick snapshot of the topics for today. We introduce matrix factorization and we specifically discuss the challenge related with large matrices. We introduce some related work in this area. Then we will talk about our proposed approach, which is block-based matrix factorization. And we introduce the application of block-based approach for GPU acceleration. Some related works in this area, and will show the algorithm and the experimental. We'll conclude the session with visual work and development. So the goal of matrix factorization is to find two matrices such that the multiplication of these two matrices approximates to the original matrix. So for a given data matrix of X in real number space, we derive two latent feature matrices U and V again in real number space such that U and V transpose when multiplied gives X dash, which is very much equivalent to the original matrix. And again, the latent dimensions are less than or equivalent to the dimensions of the original data matrix. So the optimization problem for matrix factorization can be defined with equation number. First term is the minimization of error term. The second term is the regularization term. And in the recommended systems domain, given a matrix, data matrix of X, matrix factorization aims to extract user latent factors and item latent factors. So these latent factors are represented as vectors in the latent factor matrices. We can visualize these matrices as a k-dimensional point in a k-dimensional space, and the distance between cosine distance between the users and latent items will give us the predicted range. In the movies domain, we can visualize the latent features as the numerical representation of the preferences that the end user gives on a particular movie, let's say genre or actor, director, or producer, things like that. So here is an example of a telemetry matrix when factorized. The U has the latent feature vector vectors in a horizontally layout and we transpose as weighted feature vectors in a vertical layout. And for x11, the first row of the U weighted feature matrix and the first column of the V weighted feature matrix are multiplied using the dot product of the vector minus vectors gives us a predicted rating of 2.9, which is almost closer to the original rate. We are not interested in the numbers that are already there in the original data matrix. We are interested in the predicted ratings for the information that is not available in the original data matrix. So here is a typical SGD-based matrix factorization algorithm looks like. Input for the algorithm are data matrix and the k latent dimensions. We begin the algorithm with initialization of UV latent factors, factor matrices with random values. In line number 1, we iterate the entire algorithm for maximum number of iterations. Line number 2, 3, and 4 together are contributing to identifying the observations which are given in the data matrix. So there could be these matrices are sparse matrices, so not every rating is given. So there is no reason for computation of prediction for those areas at this point. In line number 7 and 8, we update the specific latent factor out of the k latent factors in the U and V latent matrices. So line number 6 is basically the k latent dimensions, looking through the k latent dimensions. This is a constant. Line number 1, max iterations is a constant. And 2, 3, and 4 contribute to the number of observations, which is present again. So the time complexity of the algorithm tends to be order of n. However, the time complexity doesn't matter because these matrices are significantly larger. The number of computations is what is the big challenge. So the computational time for matrix factorization can be arrived as k, which is the latent dimension, and then the number of iterations, and n, which is the number of observations, and then number of iterations. Multiplied by a computational constant for each step. To visualize for a 10 million kind of a movie data set, for a k of 10, and for about 100 algorithm runs for about 100 iterations, it would take around 10 to the power of 10 computations for the. So this is a big challenge, especially we were trying to design a temporal matrix factorization approach, where the computationally it is very intensive because we will look at the data from multiple temporal points. So we needed an algorithm which is faster so that we could experiment more often. So that is when we looked at some existing matrix implementations. And none of them are actually very efficient when it comes to large data sets. And for temporal, we needed a large data set. So we went ahead and designed an algorithm of our own. So our objective is to design a matrix factorization approach that can scale, that has parallelism, and that can be executed in a distributed environment, and it can take advantage of the GPUs. So related work in this area, Lester et al. And Duke et al. Have proposed divide and conquer approaches wherein they divided the data matrix into submatrices and considered the submatrix as a different problem altogether, like a subproblem. Factorize it fully, and then combine the results. It resulted in noisy factorization because when we consider the subdomain or a subproblem as a subproblem in itself and then factorize it fully, so the learnings are localized. So there will not be much of a transfer of the learnings from that subdomain to the other subdomain. So that is because of that the factorization resulted in noisy results. And Joan et al. Proposed shared memory based parallel approach. And similarly, Vladimir has proposed the fast matrix factorization approach for the gradient based approach. And Jung et al. Have proposed a multi-mission, basically a distributed algorithm, an asynchronous based approach. That and proposed a log-free based SDD approach. Gimula has proposed a matrix factorization technique for distributed systems. Wu et al. Has proposed a parallel SDD based approach. So we looked at at all these research works and then we designed an approach which combines the best of all these areas and also address all these papers basically address certain portion of the problem, not the entire problem. So we designed a block-based approach for matrix factorization. The central idea of block-based approach is to split the data matrix into blocks of equal size and consider each block as an individual matrix, factorize it for only one iteration, and then combine the results together and move on to the other blocks and complete for the maximum number of iterations. So if required, you can add zeros as a padding or as columns or rows to ensure that all the blocks are equal size. As a limiting condition, we can always see matrix factorization has always been a block matrix factorization. If you look at each element of the matrix as a block or the entire matrix as a block as well. So here is a visual representation of how the matrix factorization, block matrix factorization works. We divide the data matrix X as in a block matrix, and we take each of the block and we factorize it to derive the block latent feature matrices, and we combine these results. So the objective of our approach is to find UV, UI, VI latent block matrices for a given Xij block data matrix, so that the Xij is roughly equivalent to UI and Vj transpose. So here is a visual representation of it's an example with the 4x4 matrix on how the block matrix factorization works. We divide the data matrix into 4 different block matrices, each of which are 2, 2, and we factorize each of the data matrix, block data matrix into 2 different latent block matrices, UI and EI. So if we observe closely, each of these latent factor matrices have been updated during factorization of more than one data matrix. So the care has to be taken to ensure that the race conditions do not occur. That's the crux of the algorithm. So once these DG latent factor matrices have been factorized, we combine these to get the original latent factor matrix for the entire data matrix. And when we multiply these, we get the predicted data matrix. So the optimization problem for block matrix factorization can be represented with equation number 2, where the first term is again the minimization of error term, and the second term is the regularization term. So with the difference that this equation is very similar to the matrix factorization equation in equation 1. The difference that instead of element level computations, we have block matrices. So Xij, UI, and then Vj are block matrices, and LUI and NVj are the number of observations in this specific block. So the double basically denotes the triple norm for the matrix. So here is a quick view of the derivation for the block matrix factorization. In the interest of time, I will not be able to go over each and every equation, but essentially the derivations are very similar to the regular matrix factorization derivations. Instead of the element level computation, we have block level computation. So all these are blocks. Xij, UI, and Vj are blocks. So we differentiate the error using UI and Vj blocks. So equation number 6 and 7 are updated equations for the weak latent factor within the block matrices. Again, equation number 9 and 10 are the updated equations with regularization term included. So essentially the idea is that BMF does not alter the outcome. The results remain the same, RMS things remain the same. Just the underlying approach of computation is been altered. And the approach can be combined with any kernel, any matrix factorization variant, like non-negative matrix factorization or maximum matrix factorization or progressive matrix factorization or any other variant. You just have to change the kernel implementation and it works with all the variants. The ideal number of blocks can be arranged size of the data set. Let's say in the 100K data set, will not be able to spin off like, you know, 1,000 blocks or 1,000 parallel computations. And it's also on the number of parallel computations available to take advantage of this. So we took the block matrix factorization, which is the first contribution, and then we applied it onto the GPUs for acceleration purposes. How did we do that? We basically identified the set of blocks that can be computed in parallel without incurring race condition. So applied the block matrix factorization in each of those blocks, independent blocks, and then move on to the remaining blocks, and there on until one iteration is completed, and then repeated the procedure for the max number of iterations. So the synchronization of the native factor data after every iteration is the key to ensure that there is no learning loss from one iteration to the next iteration or one block factorization to the other block factorization. So there are some related works in this area where recently in 2018, TAN et al. Has proposed the GPU accelerated matrix factorization, but this is an approximate technique. And Lorik et al. Has proposed again a similar kind of approximate technique in 2021. But however, the big contribution is the optimization of memory within the GPU space. For our approach, we don't really require some memory management, especially because we're always identifying independent blocks which do not require or which avoid race condition. There is still a bit of memory management related challenge, which is to transfer the data CPU to GPU and GPU to CPU. So there is another work where Sven Kovita and his team on GPU accelerated non-negative matrix factorization back in 2016. They use CODA-based frameworks. So it is a visual representation of how the GPU-based block matrix factorization works. We split the data matrix into blocks, block matrices basically. We identify the set of blocks which are independent. So all the blocks which are the same color are considered as the blocks that can be computed at the same time. To the right bottom corner we have a number representing on which iteration they will be running. So all the blocks which are numbered 1 will be computed in parallel, and after that number 2, number 3, and similarly it goes on to complete all the blocks, ensure that all the blocks in the matrix are computed at least one iteration. Then move on to the next iteration. So while it is carefully noticed, while we are updating the latent factor matrices for X11, there is no other computational unit which is running or factorizing and updating the latent factor matrices for which are being updated by that particular thread. So that is how we avoid the race condition. So here is an algorithm for GPU accelerated matrix factorization. The inputs are very similar. We take X data matrix and then the number of pixels as input. We initialize the UV latent feature matrices with random values, and we represent the data matrix X and latent feature matrices as block matrices, Xij, Ui, Vz. So the learning rate, regularization, and minimum deviation of that between the iterations is based on required tuning for the algorithm. We initialize as constant. CPU constant, CPU steps and GPU steps are the difference in here. So we tune the CPU steps and GPU steps to ensure we get the optimal result. If we keep the GPU steps as 1 and CPU steps as the max number of iterations, it is pretty much similar to the result, very much similar to regular matrix factorization. But if we keep the GPU number of steps as slightly higher, the convergence is faster because each pattern convergence is local, little more local. So the result may not be optimal. So that's the key difference. So for we iterate the algorithm in step number 1, so line number 1, we iterate the algorithm for CPU number of steps. And in line number 2, 3, and 4, we identify which is the next block on which this computation has to be performed. And in line number 7, we spin off a GPU thread on that specific data block so that it can update the latent feature matrices for the specific data block. And this is the GPU and this is the GPU specific stack that we built. Yeah. So if you keep the GPU infrastructure as max iteration, that particular block is fully factorized and all the learnings are local, and so there will be a lot of noise in the overall outcome. So it is very good for prediction within that space, but not in general. So the expert results for this approach are given in this slide. We have taken 4 different data sets or different sizes from 100K to 20 million. We have implemented 3 different variations of the variation. One is the CPU MF or CMF, basically the regular matrix factorization which runs on CPU. And there is CPMF, which is the parallel CPU based algorithm, which is multivariate based approach. And there is BCMF that are contribution. So as you can see that the RMSE values of all 3 variants are very similar because underlying kernel is the same, and the alpha, beta, and delta are the same for all the values. So the CPMF, CMF to CPMF, the advantage in computational advantage or the time advantage is very minimal because both of them are running in CPUs. Even though the CPU multi-threaded, it is taking advantage of some additional computation. Because of the synchronization issues, it was constantly getting blocked and it was not able to give much result. This was not implementing the block matrix factorization approach. Whereas BCMF gave like more than 10-fold the result than the computational time. So the primary advantage that we get in using this approach is the computational time without changing the time complexity of the matrix factorization. So here is a visual representation of how the algorithms perform. So in the left we have the blue line basically is the CPU based matrix factorization with PMF kernel, and the red line is the BMF on a CPU based implementation. So the number of iterations in which both of the algorithms converge are the same, but the slightly better performance on the CPU itself. On the right, we have the GPU-based implementation. Again, the number of iterations it took to converge are very similar, but the computation at time is the only difference. Here, we are not able to actually plot the CPU implementation or CPU times on the same curve or same graph, especially because the time difference is tenfold. The GPU curve actually looks like a vertical line, whereas the CPU curve actually takes away the entire space in the curve. So here is another variation wherein we try to play around with the CPU steps and GPU steps. Fix the overall steps as 200, CPU cross GPU steps as 200, and we slowly incremented the GPU number of steps. This is for a test data set, I mean the implemented data set. So the results are slightly random when we increase the number of GPU iterations. So as long as the GPU iterations also is 1, the results are very much similar to the regular matrix factorization. And because of the localized learning and the loss of learning when we run the GPU iteration for more than 1, so the results are stuck in local minima most of the time. So to conclude, BCMF gives computational advantage with respect to time, and one key factor here is to ensure that the floating point prediction differences between CPU and GPU has to be taken care. So some of those GPUs actually run on 16-bit floating point precision, whereas the CPUs may be running at 64-bit floating point precision. So when we convert the data from CPU to GPU, there is some amount of loss of data, loss of valuable information. So we have to take care of that, and we have experimented on NVIDIA Tesla M40 GPUs with about 8 GB of RAM and 5,000 cores. We have developed an open source implementation using Bytecode and published it as an open source project. So the ideal number of blocks has to be decided based on the number of cores available if it is a single GPU, or number of computational units available if it is multi-GPU or multi-CPU GPU. The number of observations in each block are not equal. Right, because in some of the blocks the number of observations are probably higher, and some of the blocks the number of observations are low. So synchronization has to be taken care. All the threads have to be synchronized at either each step. So we will have to make some of the GPU cores wait until the rest of the threads are completed. Otherwise, there is a possibility of race condition and race suboptimal results because of the race condition. So that is, as a feature, there is a possibility of reordering data to make the number of observations in each of the blocks equal. However, this is an NP-hard problem. So it's basically a variant of subset sum problem. Subset being the block and the sum being the number of observations in the block. And this approach can be extended to multiple GPUs, multiple distributed systems, multiple CPUs and distributed systems as well. So with the synchronization of humiliated factors at the end of each step. And this approach can be applied to various domains like text mining and other variants of matrix factorization like NMF, MMF, and WMF on DMF. So here are the top references that we have used during our research. I quickly go over into this slide. Thank you. Yeah, I'm going to take it. Yeah.
Question. So, what is your novelty in terms of existing related works on matrix factorization? That's one question. Also, as compared to existing GPU-based algorithms, you have already shown some algorithms.
Yeah.
How you are not compared with any of those algorithms?
Okay, existing algorithms on GPU space are approximate algorithms. They are not giving the results as that of the regular matrix factor.
You have not shown the curve.
I have not shown the curve because they are not, because they are, in their paper itself, they have said that it is approximate. The results show that.
Also approximating. You are not approximating exactly.
No, I was getting exact. Okay, there's a slight difference. That is only because of floating point precision difference.
Okay.
But if we, it's almost equivalent to the original.
But all are approximate, or they use some of the efforts in this dimension?
There are only two relevant works, which is yeah, they actually came recently, and they themselves declared that they are approximate algorithm.
So another thing is that factorization wise is a simple factorization. Only GPU is the addition.
Factorization wise, we have changed the order or sequence of factorizing the elements.
Then in that case, you have to compare with the existing all the factorization algorithms.
Yes, we did. So the CMF, when we say CMF, is our experimental result. CMF is basically the regular matrix factorization, which is executed in CPU.
No, I want to say comparison with the existing algorithm.
Yeah. The existing algorithm is CMF. So the CMF is the time. This is basically an ALS based kernel.
This compared to GPU you are comparing, isn't it?
Yeah.
Then saying that what is the existing compared to literature? So where are those approaches? How they are performed?
Yeah, we have not really compared with existing literature in the GPU space because of the very business declared as the approximate.
So another thing is that what is the GPU algorithm? That's also not clear. So the question is that you are just doing the CPU and DPU just declaring what is the abstraction you are getting, how are you distributing, where are the conflicts occurring, where is the weighting occurring. Those programming wise it is not clear.
Programming wise details are actually there in the open source project which is published on GitHub.
Abstract level, so where is the significant weighting, why they able to weight, where is the matching happening, why somebody able to weight, all those things.
Any other questions?
Sir, so what exactly race conditions mean here when we are taking the blocks?
Okay. So the race conditions were like this. So if let's say for suppose we have two different sets are working or two different cores are running on two different blocks, but they are updating the same latent factor blocks. So when that happens, when the first thread executes, it takes the latent factor, previous latent factor value, and the second thread could be taking the same value, and the first thread completes the update, and then the second thread completes the update. But second thread's update is not accurate because it has read the value originally from the before the update of the first thread. So those are the learning losses basically. So the idea is to first thread has to complete its update, and until that the second thread should not start updating the same latent factor.
Okay, sir.
Because CPUs have huge memory, whereas GPUs have limited memory, right?
Yes.
So there is a concept of unified memory where GPUs can use the CPU's memory as if it is its own.
Yes.
Have you exploited that kind of unified memory to see the performance elevation?
In fact, if we use it, it is going to be even better.
Yes.
So some of the loss in our GPU implementation is the latency of data transfer between CPU to GPU. That's significant in comparison to the computational time taken by the GPU itself. So GPUs are really faster in computation, but the data transfer between CPU to GPU is significant enough.
No, but the RAM, when you are talking about unified memory,
Yes.
then RAM is very fast.
Yes.
So from base card something or some process is happening in the CPU only. Unified memory ensures that you are directly reading the address of the RAM, right?
Yes, yes. So that will definitely give much better advantage. We don't have the access to the kind of hardware at this point in time, so we have not explored that.
That is good. And next one is can you go to the algorithm?
Which algorithm?
GPU, yeah, here.
Yeah.
You are waiting when the thread is wait until thread is running on
The same row or same
column.
column.
So if your that row is okay, but if you are executing something on the column which has multiple rows, don't you think you will have a lot of deadlocks?
There will, so that's essentially when we are waiting itself is to avoid the race condition. So if we, I'll go with the example like that. If two blocks in this column are parallelly being computed, so those two blocks could be updating the same latent feature blocks. So at that point, there is a race condition possibility. That is the reason. So essentially, that is the reason we say all these blocks, number one, have to be computed in one go using multiple cores. And once it is done, then move on to the next set of blocks.
If that is the case, then go back. We can say column is enough now because row contains column. Row is a collection of columns. Then you can say wait until the columns are completed. Because then why to say same row or column?
The same thing will happen on the row side also. If two row blocks in here and here are computed, they will update the same set of latent factor blocks as well. So both on the row side and then the column side, we have to ensure there is only one block on that particular row that has to be computed, and one block in a particular column has to be computed. That is the reason why we designed it diagonally. So when we say row and column in here, it basically says row and column of the block matrix, not on the individual matrix rows and matrix columns.
Thank you. Let's couple of questions. Thank you. Now we are at the final presentation. So who is the final speaker? The title is Advanced HLS for Reconfigurable Image Processing in Big Data Systems. So you are Bhagira? Abhishek Tironi and
morning, everyone. Is my voice clear? Okay. So, I am Bhagirath, working as project engineer in Center for Development of Advanced Computing, at Noida, which is a research and development organization working under Ministry of Electronics and Information Technology, Government of India. So, I am accompanied by my co-author of this paper, Abhishek Tiwari, designated as Scientist E. So, our paper, I am here to present a paper titled Advanced HLS for Reconfigurable Image Processing for in Big Data Systems. So, this is the outline for this presentation. I will go through problem statement, objective, introduction, methodology flow, results, conclusion and future work, and references. So, for contextual understanding, I will start with introduction of where our work lies in respect to big data or edge systems. So, in industry, the big companies like Google, Microsoft, Meta, they are also into this work. They are developing hardware accelerators for them for efficiently run the compute-intensive task of AI/ML workloads. For example, Microsoft Azure is providing AI accelerator. If anyone is using, you can share with me. So I don't know whether they are providing it as a resource in Microsoft Azure, but they have one AI accelerator, and Google also has machine learning data center. Based on the data center's compute intensive task, we get our recommendations on Google Photos, Gmail, and all. And Meta is also into this work. So the hardware which is developed at a large scale will come in at this position, and if it is if the same hardware is developed for a lighter version, it will come into the edge systems. So I will start from our problem segment. So this is, you can see here, this is the hardware accelerator, and normally in systems where the systems which are developed for AI/ML workloads has a CPU and hardware accelerator embedded in it. So most of the times, these hardware accelerators are very efficient for AI/ML workloads like convolution, pooling, activation functions. But our neural networks also has architecture which are related to image processing and for best inference results. And we need to also train our data set using image processing functions. So this hardware which are developed by industry are lacking in image processing tasks. This hardware. So they are lacking in image processing tasks. So we came up with so the problem statement is, for example, if I run a neural network on this system, the convolution architecture from the neural network will run on this hardware, which is nice, compute intensive, and the pooling also will run here. What about pre-processing and image of image processing tasks? The neural network has pre-processing and post-processing image processing tasks as well. So for this, the architecture may run on CPU. So the workflow goes like, your comes is deployed on this system. The convolution will run here, and after again go to CPU, which due to this, the result of this data transfer is a pipeline delay of the neural network. Convolution is running here, and the full data is transferred to memory, and from memory to CPU, or directly from deep learning accelerator to CPU. So this introduces pipeline delays in our system, and due to this pipeline delay, we face high latency issues, and since CPU is very sequential, there is no parallelization taking place in the CPU. So, and another thing, due to the sequential nature of the CPU, we find reduced throughput and increased latency. And we cannot scale our architecture. So this is the problem statement which is faced by the industry at this present time. So industry is also working image processing trying to uh, trying to allocate the image processing hardware onto this hardware as well. So our objective in this paper was to directly, so in this system, in this SoC, this hardware accelerator is this one. This is the representation of the hardware accelerator present in the big data or edge system. So in this hardware, we directly integrated image processing algorithm as well. So the same hardware architecture, design hardware accelerator as convolution engine, activation engine, pooling engine, as well as image processing algorithm, which are required by neural network models, or we can also configure our own algorithms in the respective neural networks, and we can try training and inference on these hardwares. So the objective here is, since Verilog RTL takes so much time to develop and bring to the market, we use HLS here, and to address the inefficiencies here, we directly integrated the image processing block inside the hardware accelerator, and for good interface, we use axis interface, which will work with different sub-blocks of the designed proposed hardware accelerator. And this is compute intensive, and compute it is effective for image processing as well. Here in this, due to this proposed hardware accelerator, we have increased throughput and reduced latency as well. So moving on to the next slide, I want to give a brief overview of what high-level synthesis is. So high-level synthesis is nothing but, it is also nowadays it is becoming like a hardware description language like Verilog and System Verilog, but it will convert the C++ directly into hardware. And the tools available in the industry are Intel and AMD, which only generate code for their FPGAs. For example, AMD has their own FPGAs and Intel has their own FPGAs. Out of this tool, if you write any C code of the algorithm, it will generate the RTL, which will be applicable to those FPGAs only. So we cannot design our custom accelerator, and we cannot take out for fabrication. So the advanced HLS tools in the industry are Cadence, Stratus HLS, and Siemens Catapult HLS. So we use these tools to develop our high-level synthesis algorithm for image processing tasks. And this is where our work fits in. Our hardware comes into the picture, and it will run the neural networks, modified neural networks, or the already available neural networks, which are present open source, can run effectively on these hardwares. And if it is a small light version, it will come into edge systems. For example, FPGAs, and the same can be taken out and made as ASIC. And if it is produced for large scale, it will go into the data centers of big companies like Microsoft, Google, and Meta. Even Nvidia is also developing. But the hardware they are developing are efficient for only convolution and pooling tasks, and they also lack image processing algorithms as well. So, as an example, I have taken the resize function from image processing, which is nearest neighbor interpolation. The pseudocode is present here. So here you can see we are looping through. For example, if this is for a small example, I have taken input as 3x3 matrix and output as 9x9 matrix. We are looping through each and every pixel of the image, and we are allocating some temporary internal buffers. So, and we are also reading and writing from the variables. So in C++, this is just an assignment of a variable, but at hardware level, this is the reading of the memory, and here this becomes the writing of the memory. So for this intensive task, so in a nutshell, this algorithm just calculates which data should be placed, which data should be placed at a particular location. It is not processing any data. It will just find the location. For example, if it is iterating through will check whether A or B fits in here, and if A fits in here, it will take the A and directly copy it, reads into the output matrix. This example is for representation purpose. We have tested our approach on so many examples, which I will be showing you later in later slides. So our first approach was we need reconfigurability on hardware. So since for reconfigurability, we employed log function. This log function will go onto the hardware. This will be synthesized on the hardware. This is not a simple simplest algorithm. It will at the later stage it will go onto the FPGA and it will run on the hardware. It will take the inputs from the given network and run on hardware. So this is successfully synthesized on FPGA. This will take the dimensions of the image and it will count whether how many bits are needed to store the dimensions in a particular variable. That is called as buffer in hardware implementation. So why this is needed? This is needed because, for example, if we are not employing this reconfigurability feature using the log function, we will face issues like we need to take the variable from external memory or external any function on hardware. Because of that, our hardware algorithm doesn't know what is the dimension, what is the exact metric of the variable required to store the resolution of the image. For example, image can be 4K and as well as image can be 100 also. So since there is very so much difference in resolution, it will allocate number of bits, exact number of bits for the particular resolution. So due to this, if we are not using this, it will at the later stages of functional verification, it will give us as a hardware at functional and code coverage level, it will give us a code coverage loophole kind of thing, which will be not suitable for a tape-out. And due to after employing this reconfigurability feature, we are able to configure our algorithm based on the image resolution at comparator. And next approach was memory efficiency. We need to achieve memory efficiency because in a design like image processing algorithm, we need to constantly read data from the memory and we need to write it onto the memory. And for effective representation of memory on hardware, we need to read memory for every cycle on the hardware. So for that we have selected dual board memory, but the one dual board memory lacks one feature, which is it is very cost effective. It is not cost effective. This dual board memory, it consumes so much area when it is taped out for silicon. So it is not even suitable for manufacturability if any company wants to manufacture their product at low memory. And significantly it increases the manufacturing cost of the fabrication also, because since area is increasing, the silicon will also increase. So fabrication will charge higher amount. So what we have done is we have functionally we have we need dual board memory, but we don't need negative effects which it is bringing into our hardware. So we have taken a single board memory and we made the single board memory to act as dual board memory by adding different interfaces. At last, the interfaces are all same. The four interfaces here will work for this single board memory as well, and this helps us in giving our design the scalability feature. It is quite scalable and it will reduce our manufacturing cost. It is cost effective and area effective as well. So this also works right for our algorithm, set of image processing algorithms. And the next feature was power efficiency method, which for a traditional data processing mechanisms on hardware, there will be the input interface and there will be output interface, and in between there will be register. For example, for 100 cross 100 image resolution, this register can be of 100 cross 100. Again, the same issue. it will take our area, and it is not reconfigurable, not scalable, and all those negative effects which it is bringing on. So we try to convert this data movement between the memories into line buffer. So the data comes, the pixel data of image comes as an input here, and it will continuously, the continuous data movement happens from this line buffer, and again it goes to the line buffer. Can be imagined as a multiple buffers. So the data from this buffer will go into the output. But here also it has negative effects. Like for continuous data movement across multiple buffers, we are having a write access. For write access, we need to switch the circuit again and again. During the switching of the circuit, it is consuming the power. So this is not power efficient, this design. So to tackle this issue, we have developed this circular buffer. This architecture is for representation purpose. This will modeling directly this on hardware will not work as intended. So in this design, the data will go in a circular manner. The data movement happens in a circular fashion, and there is no repeated switching of data here. And our design can also access the data, reuse the data from multiple buffers at a given time. So this was the power efficiency method, and this also worked well for our design. After employing all these methods on our nearest neighbor interpolation and combining it with placing it in our deep learning accelerator at this position, and after this deep learning accelerator is see, we got these resource utilization data. So this is the data of algorithm, and this is the data of the integrated accelerator, which I was showing you by passing through different slides. So this is the integrated accelerators resource breakdown, and this is the particular algorithms resource breakdown. So here even the resource utilization also worked like as intended. It did not take much area after employing these methods, and we have compared it with different research works people has done on their deep learning accelerators. The effect was quite impressive, and this is again the resource utilization on different FPGAs at different clock speed. And say the works here and here both are same. And after checking this with one particular algorithm, we have added all these novelty kind of cases in all these algorithms. Version 1 is without employing those features, and version 2 is with employing those features. Here we have taken one image, and the resolution is displayed here. And we can see the data here, latency and throughput and total area as well. Even area also decreased much. The area is in micrometer square, and this time is in nanoseconds, since it is 1 gigahertz. And the PDK we use is 3 PDK 45 nanometer, and the tool we have used is catapult HLS. So conclusion and future work. So after employing all our objectives, we have seen improved performance and efficient design. So even it is flexible as well, and it is power efficient as well. So for future work, we have taken dynamic reconfigurability as a task, and further optimizations in whatever way we can optimize design. And these are the references we have taken. These are the data libraries of data types we have used, which works for ASIC as well. This will work for ASIC. This Xilinx data type will not work for ASIC. This will work only for their FPGA. So thanks, and any questions? And I want to thank BDA team. I want to thank University of Hyderabad, and I want to specially thank the registration team of University of Hyderabad. Thank you. And I'm open for questions. You can ask me any application related questions, and we'll try to answer big data related questions as well.
So I was a good talk. Not very well known about I mean, I'm not so sure about how FPGAs work. So your the deep learning accelerator you said, right? Is it something like a GPU?
Yeah, it is. It is optimal hardware which comes in between of CPU and GPU.
Very tightly coupled to this CPU in terms of culture, address generation data. So as you can see, this accelerated CPU is not having the capability to generate address and data. Okay. That capability is with that conventional CPU, but it is very tightly coupled. So that CPU is offloading compute intensive kind of task to this accelerated engine. It because it is specialized for this, it used to do that and execute that.
So, edge-related task, some companies are modifying the neural network already present in the market, and they are trying to add their configuration of different image processing techniques for best training and inference purpose. Because at edge processing, we will reduce the data bit weight, and the design will be heavily quantized. At that time, we need best algorithms which are working on the image.
Here and there, you should make it proper. It's very, very tough to follow. That is my advice. Hope you will use my advice.
Yeah, sure. Yeah,
you are moving from all the way last to the first slides.
Yeah.
Okay? That should not happen. Okay? You should follow like a storyline. So that is fine. And second one is the concept of this integrating image or any other process into FGPS. Several others have already done it in the literature. How is your work different from them? I will say that literature part and others, because even my colleagues in my university are doing that part. Image processing, they are putting it in FGPS. Okay? Then how is your work? Where are the results?
For cover, I did not include. I can get back to you if you want the results. Yeah.
What is the consumption, the main so how much that is taking, that is shown here. And apart from that, this engine is totally reconfigurable for low and high computing intensive tasks also. So reconfigurability is in any way a behavior of FPGAs. But apart from that, we are trying to make it more reconfigurable at algorithm set also. That it can be used for edge compute applications for some errors, and it can be used as a PCI Express card in case of some processing. So that is also part is also included in this. He was not able to show it separately, so we will do that.
And this our HLS can be carried out to ASIC as well.
Okay, but generally, make the claim that our algorithm or our framework is power efficient. Okay? There are power meters. Okay, so technically we have to connect to a CPU to those power meters. Power efficient. Okay, so try to use power meters that are available. This is tested on Xilinx, which is now AMD chip.
Yes, the FPGA name is ZCU104. Xilinx even under 96 also PCK 190 also.
Thank you very much for your presentation. Let us thank all the speakers who have given the excellent work. And with this, we end the session 4. So let's go on to the
There is one more session. That's what we are already 40 minutes behind.
so let's start the other session.
Okay, thank you, sir.
So for all your information, okay, the next session will continue. In the next session, there are also 2 papers which are online, okay. And after this session, we will have lunch.
Shifted to middle of the year. Because bits Pilani, Hamid well presented, he is going to organize bits Goa, bits Goa. Next year. Next year. Became the stadium, part of became to they removed about 2-3 days for this university. They are still protesting.
Hello, Kazi. Yeah, next paper is explainable detection and analysis of cauliflower leaf diseases. Yeah, the presentation time is only 20 minutes, so please present within 20 minutes, and question answering session is for 10 minutes. Yeah, you please share your PPT.
Yes. Yes. Is my screen visible?
Yes. Yeah, please start. Yes, it is visible. Please start. It is visible. Please start.
Okay, thank you. Student, and welcome all and all to my presentation. I would like to appreciate University of Hyderabad for giving me the chance to present at such an esteemed conference, and I would like to apologize first for my physical absence in this conference due to some unavoidable reasons. So the title of our work is Explainable Detection and Analysis of Cauliflower Leaf Diseases. Myself, Kazi Tanvir, I am from the Department of Mathematics from the Institute of Technology. And my co-authors are Sharia Afrin Kani, Rupabamin Rahman, MD Saif Kabir, Tasnim Santhia, and Dr. Saifullah Mia, and they all are affiliated with American International University, Bangladesh, Dhaka. So, the outline of our paper is we will start with a brief overview of the whole project in the abstract, followed by introduction, literature review, methodology, proposed work, result and discussion, conclusion, and showing some of the references that we have used. So, as we all know, cauliflower is a very common staple in the South Asian cuisine, mostly in India, Bangladesh, and Pakistan, as it is having various health benefits and it is enriched in iron, magnesium, and vitamins. It is also a great socio-economic contributor as as it helps in farming economy as well as giving employment to the people. But diseases has always been a challenge in agriculture, and the diagnosis is often hindered due to the lack of experience or like the new farmers they face problems in this. So in that scenario, the deep learning based approaches can be a great help. So in this study, we are proposing a parallel CNN based deep learning architecture which is based on National Mobile and Reception V3 and which has achieved an accuracy of testing accuracy of 99.15% on our data set. And we have also used explainable AI techniques to verify the classification ability of the model. So, cauliflower is a very common fruit, as I have told, and it is good in nutrition. And it is cultivated in many regions all over the world. And the diseases that it get most affected by are black rot disease, black spot disease, bacterial spot disease, and downy mildew disease, and which is leading to reduced yield, poor quality of the yield, and economic losses. So the post-harvest losses of cauliflower is also very high. As you can see, it accounts for around 40 to 60% of the total production. And for this type of things, in this type of scenarios, deep learning-based models can be a good tool for detecting those diseases and for both the consumer as well as the new farmers. And yeah, so these are some of the literatures that we have referred while working on our papers. And so moving on to the methodology, this is the flow of the methodology that we have done. First we did the data collection, then pre-processing, feature mapping, feature extracting, and then classification. So about the data set, so the data set was collected from a paper which is titled as ResNet and organized data set for cauliflower disease for a sustainable agriculture automation system. and they collected the data from Shingar, Manikganj, Dhaka. Shingar is one of the agricultural hotzone in Bangladesh, and the data set contained around had contained 4 classes in which the bacterial spot had 100 classes, the downy mildew had 177 images, and the black rot had 173 images, and there were healthy 206 images. So for the pre-processing phase, we did image resizing as the images that were present in the dataset, they were varying in dimensions. So we resized it to 224 into 224 dimension. Then we applied color inversion. Then we did data augmentation using the parameters like white shift, height shift, brightness change, horizontal and vertical flips, and variable zoom range. And after that, we did outline analysis to remove the images which were having unwanted values or unwanted like pixel values or unwanted occurrences. So after that, we split the dataset into 80-10-10 ratio. And now talking about the models, the highlight of our research is 2 models, which is Inception V3 and Neural Architecture SearchNet Mobile. So Inception V3 has 48 layers and utilizes Inception modules to optimize the performance by combining multiple filters in parallel and improving the computational efficiency. It employs factorized convolutions such as 7 cross 7 or 5 cross 5 filters, reducing the number of parameters or enhancing the feature extraction capabilities. And for NASNet mobile, the design it is for design for mobile or embedded devices with low computational power. And it is a very lightweight model with fewer parameters, and it balances high accuracy with enhanced computational cost, making it ideal for quick and real-time as I have we have used parallel scaling architecture. So parallel scaling architecture, we have parallel branches that captured refers the features simultaneously. After that, we did feature integration. That means the features that we collected from the branches of Inception V3 and National Mobile, we concatenated them, which helped us in this adaptability and enhance the generalization of the dataset, which help us reduce both overfitting and help us improve the performance. And these are the hyperparameters that we use to train P50 folks with Adams optimizer and categorical cross entropy loss function with layer activation functions rel and the output layer activation function as softmax. We use the batch size of 30, and for our like use image sizes to 128.3, which was found optimal for our model. And the callbacks that we use were learning rate scheduler and early stalker with the given values. So this is a brief overview of our whole proposed model architecture, where we are taking the weights from concatenated weights from the national and inception, and then we are putting it through that global average pooling, and then we are normalizing the weights using batch normalization. Then we are passing it through one test layer, and then finally we are giving that out to giving the output. So these are the training and validation and accuracy and loss curves, and this was the confusion matrix, and what we can see it is doing good prediction with less misclassifications over data. And this was the matrices for the model, the accuracy for training, validation, and test, and the precision for recall and F1 score. And we also compared our pre-processed data set on these models as well, and this was the accuracies that we got, test accuracies that we got across the models for our pre-processed data set. And finally, this was the explainable AI laser, where you can see the model is highlighting the key points of the images and getting extracted from the key points as the red uh, color indicates the most highlighted points and the blue indicates the least highlighted points, and we can see it is extracting feature from all the right regions and it is not getting any hallucination effects. And for the conclusion, we would like to say that our focus model is offers a reliable and cost-effective system for the real-time detection of the diseases. And like we would like for the future one, what we would like to do is we would like to make this model into a mobile application. So, and these are few of the references that we have utilized in this PPT. And thank you. That's it. I am open to questions.
Thank you, Kazi.
Thank you, sir.
Any questions from audience?
What is the use case you are targeting?
Sir, we are planning to convert into a mobile application so that the farmers and the consumers who are like buying the cauliflowers or who are farming the cauliflowers, they can detect the diseases like the cauliflower is affected by which cauliflower.
Very good. And use case is interesting. Thank you.
Yes, sir.
Any questions from audience? So I have a few questions.
Yes, sir.
So your paper title is explainable detection.
Yes, sir.
What is the explainable model? Where is the explainable model?
Sir, we use this explainable AI techniques like line and gradient to see if the model is extracting feature from the right places and not from the places that it shouldn't extract feature.
At least you should put some model diagram for explainability.
Okay, sir, I am taking that into point and I will keep that in mind, sir.
Okay, have you used any frequent transformation? How can you consider your model maybe overfitting?
Actually, sir, we didn't do the careful cross validation, but what we did, based on the precision recall score and as well as the training and validation curve, we came to the conclusion that it is not overfitting, sir.
Okay. Have you used any hyperparameter tuning mechanism to send those hyperparameters?
Sir, we didn't use any explicit mechanism, but we did a hard code, sir. So we tested it across various hyperparameters, and we found out those hyperparameters to be most optimal. That's why we used in our final model.
Because you hard coded the values, so better go for any hyperparameter mechanism.
Okay, sir. Thank you.
The solutions are in the arithmetic there are no page numbers.
Yes,
And model diagram also not clear. Please make sure that.
okay, sir. Thank you.
Okay, thank you very much.
Thank you, sir.
Join.
Thank you. Is there any more questions from your side, sir?
No, thank you.
Thank you, sir. Thank you for giving me the opportunity to present, and I will take my leave, sir.
Hello everybody, my name is Sahan.
Hello, next paper is Marine, a computer vision model for detecting predator prey interactions in animal medias. So the author is not here. He shared a PPT along with the audio. Yeah, we are presenting.
Hello everybody, my name is Sahan. So I'm happy here finally to present our paper. Due to some issues of the distance timing, I couldn't join the conference venue, unfortunately, but due to some facilities that we have currently after COVID, with things like and everything with recording, I'm here to present our paper that is titled Marine, a computer vision model for detecting rare predator prey interaction in animal videos. So that was written by Sophia, me, and Fatima from University of Hyderabad. I'm currently at the SUNY Empire State University, so that was written before when I was at the University of Amsterdam. So the Marine, that's what is called we will start with some introduction, some curious words, and we will go to methodology, evaluation, and finally conclusion. Some short description of what the Marine is. Basically, those who are working in computer vision, it is the combination of motion-based frame selection and diagonal version 2 feature extraction that caused that led us to achieve the so let's talk about predator prey interactions. Why can better and why they are so tricky to study? These interactions are like the gears of an ecosystem that I was mentioning that this study has been done in the Ecology Biodiversity Institute at the University of Amsterdam. Predators control prey populations that helps maintain balance and supports biodiversity. To tackle these challenges, we developed a new AI model called Mary. To tackle these challenges, we developed a new AI model called Mary. The idea is simple. Mary is designed to spot those rare important predator prey interactions in wildlife videos. Here's actually you can see how it works. First it looks for movement patterns to identify the most important parts of the video. Then it uses a powerful pre-trained AI model to extract key features from those moments. And finally it has a lightweight classification tools that adapts to different types of data sets. So we tested Marine in 2 ways. One way was a very specific case, coral-based predator attacks, which involves fast movement in a small data set. The other was its broader diverse set of fish prediction videos from the animal kingdom collection. If you have to read that data set. Marine did really well with the smaller focused data sets, showing that it can handle specific tasks, but scaling it up to bigger dataset with generalization with lots of species and environmental differences is still a challenge. So the big question we are asking is how far can AI go in helping us detect these rare ecological events like fish datasets? apparently clear for us, and what's next in making this technology scalable and effective across different habitats. So challenges in the recognize the very ecological events as a previous study, what has been done already. So let's start with the challenge. This research focuses on a gap in automatic action recognition, specifically detecting rare ecological events like predator attacks on fish. Action recognition, or AR, means identifying specific actions in a video, while action detection is the studies focus on humans using large datasets and advanced models like vision transformer or foundation models like Dino version 2. These techniques are powerful, apparently, but are rarely applied to animals. We were almost about 5 years that we were trying to implement it on the fish datasets. So in the animal domain, research often focuses on large mammals like elephants or deer, and uses clusters, narrow datasets that are hard to generalize. As I mentioned, we were almost the first people trying to use that in fish datasets. This means fish and other water ecosystems, specifically areas like predator attacks, are left out. Our work basically aims to address this. Now let's talk about the tools and methods available in AR and AD. The ability to process both space and time is key. Older methods like 2D or 3D convolutional networks started to field, but now we have transformer-based models like MVids, that's multi-component vision transformers, or video and AE, which consistently outperform those 2D or 3D convolutional networks. One exciting development in Dino version 2 was that a large vision model trained on millions of images, even though it's trained on still images, performs surprisingly well on video tasks by analyzing even the space frames. This makes it efficient, which is crucial because AR and AD tasks are computationally expensive for animals, though things get tricky. Research is limited, data sets are small, and methods often rely on identifying the actor, like spotting a specific deer or an elephant. But what happens when you're dealing with a school of fish? These approaches don't work well, and that's where our research stands out. We leverage state-of-the-art methods, but adapt them for challenging environments like underwater ecosystems. What is marine is designed to detect rare predator-prey interactions in underwater videos. It has 3 main parts, as you can see over here. Motion-based frame selection, which is the most important frames, feature extraction using the Dino version 2 model, which analyzes visual data efficiently, and a shallow classifier that identifies predator attacks. These setups basically allows us to both recognize attacks and pinpoint their location in longer videos. As you can see here, action detection pipeline is shown. So the untrained video is separated into shorter clips, which are passed to the action recognition model, combining the predictions of this model and the timestamps which locate the clip. In the original video, the temporal location of the predator attack can be predicted in the original footage. Here's as you can see, the data set that we have used. It shows these the figure. You can see that that is processing the original pyramid data set, which of the 10-second long videos are separated into 5 clips, with the middle mode containing predator attack. They result in a 2-second long clip, so that was 220 in total. We compromised the process coral leaf dataset where clips originally situated at the center of the uncut videos received a positive label. All other negative negative labels. So, this one that has the FFP capturings. So you can see that how many figures and how many figures in the data set. Some results. So basically, Marie's results show promise for detecting predator attacks, especially on data set like AK fish, as you can understand here. Ready to achieve almost 95% accuracy, however, the coral leaf data set posed unique challenge due to the imbalance nature and rare events described this marine G14 still outperformed the WME, that was mentioned. That emphasized the potential for these specific tasks. In the paper also we have shown the hours recurrence. I haven't brought it here because it took a lot of space there. That also demonstrates Marie's ability to balance recall and precision better on simpler dataset, but the coral leaf dataset remains a tougher problem. So again, at the data at the table, you can see the model performance of the action recognition test using motion-based frame selection with each model and diagonal version 2 backbones without registers in the marine models. That has almost 1.56 standard deviation to indicate a 95 confidence intervals. The other result for the animation study, that was motion-based frame selection, tested also whether the motion-based frame selection improved Marie's performance not, and the coral reef dataset accuracy jumped significantly, as we can see. Accuracy jumped significantly, showing the importance of focusing on key moments in the video. However, this wasn't as beneficial for AK fish, suggesting that the approach may need further refinement for more balanced datasets. So in total, in general, the motion-based selection helps manage precision recall trade-offs in challenging datasets. So Marie's action detection results were strongest on the coral leaf datasets when using a lower PIOU threshold, showing it can handle specific tasks better than the OMAE. However, stricter thresholds reveal the limitations of the dataset and model complexity. In multi-label classification, Marie performed relatively well, but couldn't match state-of-the-art models like MSQNet. That suggests that Marie is well suited for primary tasks that is required for diverse multi-label datasets. Performance and visual and future directions. So Marie shows a strong potential, especially on specific tasks like action recognition, where it outperforms benchmarks from the coral reef and AK fish datasets. However, challenges remain particularly in multi-label task and action detection and strict thresholds, largely due to the small imbalanced datasets that has been used. looking ahead to find frames selection, leveraging advanced models and testing on a broad range of datasets will make memory a powerful tool for ecological studies. The research is a step forward, actually, in applying AI to understand rare animal behaviors and ecosystems. So the structures and you can see for the future architecture. Yeah, that was it for my presentation. I think it took 17 minutes, and that is time for questions. Unfortunately, I'm not here, so if you have any questions, please let me know by email. I'm available totally. My University of Hyderabad email is currently working, so you can either reach out to me, but even if you have any other question, you can search, it's easily pop up my Gmail or Empire State University's email. So reach out to me if you have any questions. I will be happy to answer your question. Thanks for your attention. And yeah, that's it. Thank you.
Yeah. Next paper is paper ID 121, a novel multitask learning framework for correcting traffic congestion. Arjun.
We have created a novel algorithm to predict the traffic congestion, but this is a different one compared to what we have previously. But before going deeper into this algorithm, we just discuss about the traffic. Once we say traffic, in India, Bengaluru is the most traffic, like, we can call it traffic crisis. In fact, many of tourists or the professionals working there always complain about once we get into the traffic, we find the traffic moves very slow, and the traffic moves very slow. Compared to Hyderabad, Bengaluru literally is a crisis. And this is what happens. If you are stuck in traffic jams, fuel consumption, time loss, and most importantly, air pollution, all these things are. But we are not addressing all those things. We are addressing something different. We have created an algorithm where instead of performing single task learning, most of the algorithms that work there in the traffic congestion, they have performed STL models, single task learning. Give you a data set of any one particular road, and it will be able to predict what will happen in the future. If you have given a data of 1 year for, let's say, Nehru Road, it will predict what will happen for the next 10 days. But what we have done is we have created something like this. So our model consists shared layers. So this shared layers, what they do is we give, let's say, an entire city's data set, entire Bengaluru's or entire Hyderabad's data set, where it contains the traffic congestion data of all the roads in the city. There might be n number of roads. Let's take for a count of 10,000 roads. So for a period of 1 year, 10,000 roads, all this data we are going to give it as an input to this algorithm. And what this algorithm does is, it tries to identify, not actually tries, it identifies the common patterns. The common patterns that are actually reasons for where and all this traffic is happening. If you take only one singular road, maybe some kind of, let's say, accident might have caused this traffic congestion on one particular road A. But that will not be able to decide what happens because of this traffic congestion, what happens on the road B. Because once one road is blocked, obviously the connecting roads are definitely blocked. That is a real-time situation. So this is one advantage compared to STL models. STL models is STL is the normal models, GRU, these kind of BioSTM, these kind of models. They suffer like they don't adapt with the real-time traffic congestion data. If you are given with general impractical traffic congestion data, it will be able to handle. But when you provide real-time traffic congestion data, it won't be able to adapt to it, and the accuracy results are not very good. But here, we were able to solve this problem. What we have done is we have created two shared layers. Okay, this one. So here it is. So we have two shared layers. Each shared layer contains one linear transformation function and value activation. So what happens is, while the data is being processed through these layers will identify the common patterns. And these patterns will be later processed towards the task-specific layer, where the task-specific particularly speaks about each road. Each task is nothing but in each road, and what are the different patterns in entire city's data set that are affecting each road's data, or else each road's traffic congestion. So in the task-specific layer, it will be able to identify based on all the data that is previously ahead of cities, will be useful and it will be able to identify how will be the traffic congestion for the future. So and here we have used the Adam optimizer to adjust this learning rate and to get the better accuracy and better results. So this is how we process the data. So once we take the road data, this is temporal data because road data is completely based on time domains, and whatever data we have taken is a 5-minute interval for 1 year road data. Around from 2019 to 2020, every 5 minutes, what is the traffic congestion on each road? So we have taken, and the total data set might be around 1 million values, and these are all having normalized based on min-max normalization, and these values are given as input to the proposed algorithm. So after this task-specific layer and after all the optimization using Adam optimizer, we get a set of data in a normalized format, and later when we try to know the traffic congestions in the future, these will be converted into the actual data format based on denormalization. So this is our system specifications where we use the, next you'll be seeing the results how we have achieved it, and for that these are the specifications. AMD Express processor 5000 GPU and 300 GPU of RAM and Ubuntu server. And the data set, it is an anonymous company from the Japan we have got it, which is a 5 interval traffic congestion for a period of 1 year. And 10 road segments we have taken. We did not take entire city's data, but instead we take a more prefecture data. In Japan we call them as prefecture, more of the kind like a particular colony or street. So there were around 10 roads in that prefecture, and these things we have taken, and data split was 70-30. So here we have taken the accuracy using RMSE and MAE. So as you can see, compared to the remaining all models, the STL models here they are mentioned. All STL models, DTR, GRU, everything, CNN, all this, compared to all of this, the proposed MTL algorithm was able to achieve the better accuracy, literally 0.0001 to 0.0002. That is far more like compared to any other. And MA values are also literally same. Reason is the accuracy is very close to 0 because all the processing that has been done in the shared layers, they are reducing they are reducing all this unwanted data. It is only taking the common patterns and it is only focusing on the required information. It is not taking all these things. And all the training is also happening in the parallel simultaneously, for not particularly for any single road. For all the 10 roads, it is happening simultaneously. If you observe that one, here it is, time consumption, memory consumption. You can observe right here, we have, for remaining all the models, if you observe somewhere in 200 seconds, 600 seconds time it is taking to format the same data for single road, while this proposed algorithm for 10 roads, it is able to take 6 seconds and very tiny memory consumption. Because all of these are happening simultaneously, all 10 roads are being processed in a simultaneous manner. So So that is how we were able to achieve this efficient results. And also this, we use particularly neural networks instead of going for other models. There are other models based on MGM model. Where around 5 or 6 papers have been published by different algorithms. Because the particular reason we use neural networks is this temporal data is very non-linear when you compare to traffic. So when you get traffic congestion data, you can't uh, expect it to be in a linear manner. You can't expect the traffic congestions to be happening particularly in linear manner. These are non-linear data, and neural networks will be able to handle this non-linear data in an efficient manner. So we have gone for the MPL-based neural networks. So those are the results. And going to the conclusion, that is what, so comparing with other models, all in SQL models, so we would say that we have achieved far better results compared to the SQL models, and this model would work efficiently when you're considering entire cities or entire streets data with more number of roads. Yes. And I think any questions if you have?
Yeah, thank you for the presentation. Questions from audience?
So you have explained that you are using MTL models instead of STL, right? So while you are using STL, do you have any relationship with the road segments which you are considering for training? I mean, if at all you use the entire road segments which are present in the data, it doesn't make sense because it takes lots of effort in training.
Yes, that is the thing. I understand what you're asking. Or you're asking about like, are you using single road data or entire road data even for SQL models?
Yeah,
right. That is what we want to make it like equal rate. So we are taking, since we are taking 10 roads data in MTL model, we have also taken 10 roads data in SQL model, but each of the node has been trained separately. That is why most of them have huge time consumption.
But what I'm asking is, you have to consider all the 10 road segments data in order to predict a particular road segment data, right?
Yes.
But if I consider this is Hyderabad is a large city, traffic at Gachibowli, are you considering the traffic at Uppal as well? That's what I was asking.
In MTL we are considering.
But it doesn't make sense, right? If at all you are considering such far road segments, anyhow its dependency would be less.
That we are also considering based on the distance, right? If the roads are connected, that's why we have taken a limited data set, 10 roads that are connected in the one particular prefecture or in one particular area. But when you take entire cities data, we are about to do some required, like you have to calculate the distance. If one road is of like 10 kilometers away from road A, road Z is 10 kilometers away from road A, there is no point in calculating that. So we have to calculate this distance, road A, B and C. So we have to see only these three. But when you take road B, you have to see C and D. And when you take road Z, you have to see maybe X, Y, Z or W, X, Y, Z, 4 or 5 roads that are connecting with that road.
I think what you are saying is you are keeping a certain threshold in such a way that it prunes lot of
Yes, pruning, yes. Yes.
My question is that what are the tasks that the model is observing?
Road data, that is the task specific layer we have mentioned. The task specific layer we have mentioned. The task is nothing but predicting the road traffic congestion of particular road. So here if you see task 1, task 2 are nothing but road 1, road 2 and road n.
So this is a regression problem, right?
Pardon?
This is a regression problem, right?
Yes, kind of.
And I don't understand, like, this is an LSTM only, right? Whatever we are taking. What is the model architecture? Like, yeah, this is a spatial temporal data, as far as I understand.
Yes, so not exact. Okay, somewhere it is, in one manner it is spatial temporal.
Okay, so like, we are trying to find temporal aspects. So let's say the current condition is this much, and we are trying to find the future condition.
Yes.
Then basically the middle architecture, what you are saying, the shared network architecture, that is nothing but LSTM, single LSTM, right? Even though weights are shared,
it is still a single LSTM.
No.
How is it different from single? Can you explain that?
That actually first order can be able to explain. I'll ask him to write a mail to you regarding this. But the shared layers particularly consist of linear transformations.
Yeah, I understand.
But either LSTM is involved or not, only he will be able to explain.
I mean, I understand linear transformation is just a
yes.
icing over the cake.
That's what long-term memory is involved or not. Because here in this case, the algorithm is very fast because it ignores all the unnecessary information. So, if it is ignoring all the unnecessary information, I am not sure whether it is taking all the data, I mean, it is taking only the weights or all the data that has been processed before.
Okay, I understand. But if you could explain the architecture a bit more, then it would make more sense.
Okay, I'll ask the first author to send a detailed answer about this.
And also, I would also recommend to use any attention mechanism. I feel like using attention mechanism might increase the accuracy because basically it's a graph kind of network, right?
Yes.
So,
yes.
As you said previously, A to B and B to C.
Yes.
Let's say A to B is connected to B to C, and we are trying to predict B to C traffic. Then directly point A can affect the traffic of B to C
yes.
in some ways. So this can directly be mapped using the attention mechanism.
Yeah. Okay. Yeah. I'll take that into consideration.
Any more questions from audience?
Okay, you have gone through the road network. So if you assume that A to B, the road is there. So what are the parameters you are considering?
Size of the road and then the number of vehicles for more parameters like for the data set or for the prediction.
While getting the outputs, just like
While
if
getting
obstacles
the
are
outputs, yes, that is an information.
obstacles are there, some obstacles are there, other environments, so many parameters will be there, but depend upon that one, your output is going to be varied.
Yes.
Let us assume that if it is the reliability is like 100%, then the results, what are the things you are going to get?
But here we have taken only one parameter, the number of vehicles on the road, block or moving. And the data set we have taken also contains the same thing. Road 1 at particular time slot, these many number of vehicles.
But I think congestion will depend upon the road conditions also. If some
that is far more number of features or attributes, right?
That's why I am asking.
When you take STL models, that is easy, right? You can consider as number of possible. Because there are few papers that based on environmental factors also they have derived some.
But whenever it comes to the real world,
yes,
real world applications, everything, such kind of things that matter. So then the time you have to go and check, like you have to check the reliability of that road also.
Yes.
So
But
how much?
that will be in the future work actually. This is the beginning of this work, right? So when next level comes in, those all will be added. Yes. Machine learning, sir, but more of a kind like adding pattern mining. Patterns or identifying the common patterns.
You put in the machine learning, that the single attribute, if you have multi-dimensional attribute, several hundred attributes, then you can apply machine learning. We need this architecture to solve simple problems. That is my question.
We tried.
Hi. So can you give a snapshot of the data that you're using? So I think it's a spatio-temporal data on congestion. So the value here is congestion measured in number of vehicles per region of a route.
So you are asking the parameters, right?
What is the kind of data? How is this? So it's not just temporal because the road is a
time slots, time slots, that particular road. How many number of vehicles?
The road is a sequence of steps, right? So the road, so question
you can take, that is what, this data is recorded based on cameras. So cameras is placed at one point.
Okay.
So point A to point B, there is simultaneous cameras placed at four and
multiple cameras.
yes. So roads are nothing but the cameras placed at particular points in the road.
So in that this architecture here, it says that R1, R2, Rn, right? So
Yes.
R1 is what?
Road 1, where the camera is.
How is the data? Is it
zero line or vector? What is R1?
Single value with the time. Single value where the time with the time stamp at what time it is recorded.
But then road 1 has multiple cameras. So where is the multiple cameras thing coming?
Road 1 has multiple cameras.
Does that?
Road 1 will have multiple cameras, but R1 denotes the position of camera on the road. Let's say there is road A, and which is of around 10 kilometers.
Right.
So maybe at kilometer 5 there is one camera, and kilometer 8 there is one camera.
On the same road.
Yes, yes.
So here R1 would be, so it should be M1, I mean C1.
It should be C1, yes.
C1.
But based on the data provided, we name it as road 1. If we have collected the data from a company, so their data was saying it was road 1. But actually, that is a camera on the road. If you may name it like that, no road names anywhere, right? It's based on the street names.
So, that's not really what I'm asking. Same thing, a simple MLP.
Yes.
MLP, right?
Simple MLP, but here the goal is to train for entire all 10 roads or entire the data set or n number of roads that have. So we have tested it.
So the MLP, the entire, it's like the entire MLP gets the input values coming from all the cameras and plants.
Yes.
So as a follow-up question, what happens if there are multiple cameras exactly at the same spot? Let's say on the road, there is a big pathole, and all the vehicles are trying to avoid the pathole. So from one camera's angle, you will see a lot of vehicles. With one camera angle, you will not see anything.
We haven't considered that kind of concept actually. Like at one particular point, if there are multiple cameras, we will taking one value.
Most of it will be one camera.
But when you say it becomes multi-dimensional, some of the kind
So
like.
if you take one camera in this case, right, that's the case that I gave you. So one camera which is avoiding the view of the platform and all the vehicles that navigating through, you will actually see a lot of traffic from that camera.
Yes, yes, but we haven't considered that.
Yeah, it is a regression problem, you said. And accuracy also. The model is a little confusion actually. Please make sure. So you talked about accuracy, right?
Yes, yes.
How you calculated that?
RMS, and you mean root means per hour and you mean based on.
Yeah, that is not accuracy. Okay, we covered that.
Okay.
Yeah, thank you. Please move on for lunch.
One small announcement. We are requesting paper ID 30 and paper ID 66. Please share your presentations. Paper ID 30, paper ID 66. Praveen Singh, Apur, Vinod John.
As one of the panelists is still to be expected in the talk, which is from Dr. Ashok Talukdar, and he is a co-founder and CSO of RI Solutions Bangalore, and he is going to be speaking to us about AI, 6D, and cognitive graphs in the autonomous smart world. And the abstract is anyway there on the website, and in the program you can look up that. But what is very interesting to me is his life path and how he has sort of ventured out into so many interesting areas. Okay, so since I am from, I have the interest in IEEE, so I find that his first paper is in the IEEE Systems Math Cybernetic Society, which he has given in 1980. Okay, so from that you can guess that how such a long innings which he has had, and where he has worked for a number of companies like ICIL, Fujitsu, ICM, Microsoft, Oracle Electronics, what have you, all the rather well-known names in the industry. More than that, he is kept up in the academics part, and he has authored or edited 6 books, and they are also translated into Chinese, 2 of them, and about 80 plus peer-reviewed research papers. So he's not slacking in that department either. Alright, so then he has engineered the world's first 64-bit multilingual database. It's asynchronous I/O and economics for digital. And he has he was one of the pioneers in the blockchain consensus protocol, proof of disease for healthcare, amongst many things. Then, from the computer networks point of view, he is the first one to set up the X.25 network for the DOT. Okay, so many such firsts, like Java Competency Center in India, and he has co-founded CellNext that shaped the mobile computing in India. Interpretomics, pioneer in computational genomics and system biology, like that, and co-founded Precision Genomics, companies which are making use of explainable AI, actionable insights in medicine, and also he has been associated with very good set of educational institutions, the Daimler Chrysler professor at IIT Bangalore, adjunct professor at BIT Bangalore, IIT Gwalior, NIT Warangal, NIT Surathkal, and if you want to know more, please looking up in the who's who in science and engineering, who's who in the world in outstanding science of the 21st century. So we are very privileged to have you here, and we all look forward to your insights on this topic.
Thank you. First of all, I'd like to thank the BDA, which I am associated for quite some time, and for an opportunity to talk about a subject which may not be very familiar with many. So I'm going to talk about the cognitive part of computing, or rather, cognitive smart world. I will be going into detail. However, this will cover some of the things which we talked about yesterday and today. So let me first start with what is smart world? The goal of smart world is to reduce wastage, reduce resource consumption, foster innovation, ensure sustainability, and most important is that achieve more for less. I mean, this morning, Professor Guya talked about energy efficiency, or many of those, and he mentioned that some of the cloud vendors, they use electricity which is more than consumed in all of Hyderabad. So, cognitive world, or cognitive smart world, is going to be something which is written on the wall, that is, achieve more for less. And in smart world, technology will be seamlessly integrated into our daily lives. The panel discussion after my talk is going to talk about how things are going to be embedded in our daily lives. So I'm not going into much of detail. Now, if you see, smart world is going to be a combination of smart X object. And that X could be anything. Like almost everybody has a smartphone in their pocket, or smart web. Slowly we are moving to a world where web is going to be not only user interface, but the complete client on the web. And smart web is going to offer you WebRTC, which is real-time communication, with ultra low latency, then secure socket, HTML5, peer-to-peer, and many other things. Smart card, we have heard about it, smart hospital, smart healthcare, so on and so forth. I will take a use case of smart healthcare and show how cognitive healthcare is going to play a role in our daily lives. And I talked about cognitive smart apps. What are the properties of cognitive science? That is, it will have continuous learning, knowledge acquisition. Now, if you see our brain, what our brain can do just with 1 watt of energy, If we have to do the same thing in artificial intelligence, I'm talking about natural intelligence, 1 watt is equivalent to 200 kilowatts in artificial intelligence. What is the key? The key is, for years and decades of learning, we have the knowledge, where that knowledge is the part of our mission we are talking about. Then we need to have adaptability, and it will help decision making finally. And when I'm talking about decision making, there are 2 types of decision making, and cognitive would be using either of them, which is, one is autonomous, another is assisted. In autonomous, there is no human being. The cognitive itself, using some kind of autonomous system, makes a decision, like in autonomous car, or even 16 network, which is supposed to be the autonomous network, whereas in the assisted system, there is a human in the loop. AI, or cognitive smart world or cognitive smart X, will make the decision with the help of a human being. So it will be primarily helping and assisting in the decision making. Artificial intelligence, all of us know about it. However, I would like to qualify it or divide it into 5 different major categories. First one is symbolic AI. I don't know how many of you have worked on symbolic AI. However, if you look at smart or expert systems, which we had about 40, 50 years ago, Lisp, Prolog, and many of those languages were primarily designed for expert systems, which today is known as symbolic AI. Where we have different symbols or concepts, and there are relationships or conditions on which the state move from one state to another state, or one concept to another concept, or one node to another node. And even today, that is used quite frequently. I don't know how many of you have used ontologies. Anybody use ontologies? Okay. Ontologies are practically built by experts, where we have various concepts and their relationship. However, there is a difference between a taxonomy, ontology, versus a network. When we talk about ontology, primarily they deal with one single domain. Similarly, taxonomy. Whereas, if we go for a network, there are various ontologies and knowledge where we have, like for example, for cancer, one of the best, or rather I would say the best ontology is HCI Pessimist, where thousands of man-years of PhD quality scientists have gone in, but unfortunately, they are not known in the open domain. People do not know about the existence of some massive knowledge body. It is only used by the researchers. Then is sub-symbolic AI. Sub-symbolic AI is primarily all those AI where we use the data and then train the system on predicting. So whether you call it deep learning or neural network or even transformers, all of them will fall in sub-symbolic AI. I have taken part of it out and defined it as temporal AI. Temporal AI primarily are time series data, which could be very complex. I mean, the last speaker this afternoon, in the previous session, talked about the traffic congestion. I mean, there he gave an example of cameras. I've seen in Bangalore, in one junction, he talked about he used one single camera data. Even in Bangalore, in any cross-section, there are 4 cameras. One is just before the intersection and one just after the intersection, to take the picture of the violators or traffic violations. And there are 2 lanes. So every junction has 4 cameras, and they're not linear. Sometimes the traffic is very high, sometimes there is no traffic. So this will be falling primarily in temporal AI. Next is causal AI. Now, causal AI, where I will give an example to help you understand, is that where we have cause-and-effect relationship. We can predict, and based upon that, we can do planning in a company. For example, my company is making laws. Why? I don't know. I need to know. And then what are those components which I should be changing or manipulating so that my companies run in profit? So I need to know cause and effect. And then generative AI, I don't want to at all go into that, but primarily where the contents are generated, like ChatGPT, Gemini, and few more, where you can have picture, video, and text all generated from some input. Now let me introduce 6G, which I just said. 6G, which is emerging, right now we are talking of 5G. 6G, which is the autonomous cognitive network. One, it will have the self-healing properties. It will find out where is the fault, and then based upon that, it will try to repair itself, or find the alternate route, or even inform the concerned support people to fix it. In 6G, it is going to be AI native. Everything is going to be based on machine learning, AI, and it is going to be adaptive. Software-defined network, Professor Guya just mentioned about it. Yes, it is going to be in 6G. And then network slicing, which he talked about, which is virtualization of the bandwidth and the services in the network. So network virtualization is going to be there in 6G. 6G is an experimental step, they are in laboratories, and people are expecting by 2025, 2026, we will see some kind of trial network or deployment of 6G. Massive IoT support and ultra-low latency. For that, I just talked about that smart web is already there for last few years, where it offers ultra-low latency, that is WebRTC. So this is how the cognitive smart world, smart X, going to look like. We have cloud and many other edge devices and edge systems being accessed in a very productive way. Now, let me bring you to one of the main topics, and the innovative areas or innovations we are working on. But this is not a sales talk about my company and my work. This is more of the concept, what we are working on. Digital twin, I'm sure all of you have come across it. What is it? It's a virtual replica of a physical system, or we can say it's an avatar of the physical system. What are the basic foundations? That we need to have digital transformation, which could be of a manual system or some other systems, and it will be using big data, AI, and some of those technologies, and it will be also using IoT and many of those sensors to sense what is happening in the environment. Okay? Here is a picture, and this is a digital twin of a CT scan. What is there somewhere of somebody on the chest above the abdomen. And then I'm talking about digital chiplet. Digital chiplet, in my definition, or in our definition, is the semantic representation of the physical object. I talked about digital twin. Digital twin is the physical representation of the physical object, whereas digital chiplet is the semantic representation of the same physical object. If you see here, I just showed you the digital twin of a CT scan, and this is the digital chiplet, which people will understand, or a doctor will go through more of this rather than trying to understand the picture. That is domain specific. A radiologist goes through those CT scans and images, and then they annotate and make a semantic out of that twin. So digital triplet in our definition is the semantic representation of a physical object in the virtual world. How do you achieve it? Most of the time we use embedding. Using embedding, we try to get a semantic meaning of the physical object, which will then be used for further processing of in the cognitive smart world. So here is an example which I suppose everybody is aware of it. So I'm not going to talk about what embedding. What I'm going to talk about is that how in embedding we convert the cognition from a conceptual concept to an algebra. So here one of the pioneering work was what to make, where we could arrive at this equation using algebra. Somebody talked about it yesterday, I don't remember the speaker. However, what we are trying to do is that we are trying to convert the meaning into algebra. And once we convert it into algebra, it is easy for us to do arithmetic or computational algorithm, use on it to arrive at something which will then convert the data or the information into knowledge. And once we have the knowledge, like for example, today whatever I'm talking about is decades of learning. But once it is the knowledge, then you are using the energy in a much proficient and effective way. Here is a unique example of association and correlation. Let me give you an example. In US, when the sale of ice cream increases, death by drowning also increases. Does it make sense? No? But it's a fact. If you give me in US the number of consumption of ice cream, I'll be able to tell you that how many people this year or this month is likely to die by drowning. Doesn't make sense. No? Look at this. Then you'll be able to understand. It's a correlation. However, ML will work fantastically well and we'll be able to predict. Why? Look at this. The peak is in June, July, which is summer. So there is no causal relationship between sale of ice cream and death by drowning. There is an independent variable which is summer. When it is summer, people buy more ice cream, they consume more ice cream. When it is summer, people go for more swimming. More people go for swimming. And if more people go for swimming, the death by drowning also increases. And here I'm not talking about swimming in a swimming pool. I'm talking about swimming in Atlantic Ocean or Pacific Ocean, where in the US people go for swimming during summer. So this is an association or correlation. ML will work fantastically well. However, as some of you pointed out, sale of ice cream is not the cause of death by drowning. So there is another AI which I just talked about, causal AI, where I can find out the cause and effect. Any of you have come across it? Okay, let me tell you. Bayesian machine learning. Bayesian machine learning, if you give the data, spatial data, or even temporal data, or spatial temporal data, it will be able to arrive at cause and effect. What is the cause? So cause and effect is required in many domains, many verticals, many industry segments. And if I now want to convert it into the cognitive part of the machine, then I will say that association or correlation gives me an undirected graph, whereas causal AI gives me a directed graph. From node A to node B, I draw a direction or an arrow which says this is the cause, this is the effect. This is prior and this is posterior. Many of those. Now let me introduce a word which has been coined by Julia Carr. Have any of you come across this word, counterfactual? Oh, yes. So you can see counterfactual, which is just the opposite side of the fact. So he introduced, and he has a classic book, The Book of Why, asking the question, why? So from causal AI, he extended it to counterfactual. That means, I know this is a fact, but If I would have done it differently, then how did that happen? For example, I did masters in physics. I did engineering. So if I would have, those days computer science was not there when I graduated. If I would have taken electrical engineering, what would have happened? A lot of time my wife asked me, why did you not do this? I tell her, please accept where I am. However, mathematically, conceptually, using counterfactual, we should be able to do some of those. And you can see that on this chart. What we call, and here it is, C. And he has, this is figure 1 from that book, where he has put robots next to owl. What's the similarity? In his definition, what he says, owls can see, they fly in miles above the surface. From kilometers of distance, they can see what is there on Earth. Where is the prey? Where is the food? However, owl did never invent a glass or a microscope, whereas we human beings do. And that is where he defined is the intelligence. And then he defined human being or a baby, they can do, which is primarily the intervention. So when we know cause and effect, we can do it different. We can intervene. When you go to a doctor, it is called the intervention. The doctor intervenes. I will just come to one of the slides. And the last level of maturity, he has talked about imagination or imagine. That's where we innovate things. And he has put Einstein's picture and people think and they innovate, which is practically in his mind is counterfactual because they think otherwise, differently. I talked about cognitive science or cognitive smart world or cognitive network, and also I talked about knowledge. How do we define knowledge? I'm not going to define it myself. I'm going to just present here what Plato has said thousands of years ago. He said that knowledge is justified through belief. That way, put a boundary between faith and non-faith. Look at those words, 3 words. Justified through belief. If I go back, even thousands of years ago, Buddha said that don't do what I'm telling you. You use that in your own life. And then, if you find it is useful, accept that as a knowledge. So, all the philosophers, over centuries of years, they said that it has to be true, it has to be justifiable, or what we call provenance, we should be able to prove. Unless you prove something in a court of law, any allegation is not accepted. They always ask, where is the proof? So that proof is justified. And then I'm talking about belief. Finally, we believe. What is that? How should I use it? So justified through belief is, or belief is, that is what we call knowledge. Now, we can put this knowledge into graphs. And today there are quite a few knowledge graphs. I mean, knowledge graph was first used in the Netherlands. However, Google made this word popular and people call about Google Knowledge Graph. However, that was much before Google published or coined the word knowledge graph. What is it? This is the knowledge exactly like in our mind or in our brain. We have various concepts. Those concepts are connected with relationship. And I can tell you, after my talk, there will be some questions, I assume. If you have to answer that question, some of the concepts which I'm going to talk about will have a different meaning. When I teach in the class, then when students ask me a question, to answer that question, I start thinking, and that gives a different meaning to the same proposition or the same idea which I have never thought about. So knowledge graph is a semantic network that represents knowledge exactly the way it is in the human brain. We have nerves, synapses, where knowledge is stored. And more knowledge means not my neural nerves are increasing. Practically, the connection between them are increasing. So more connections, more synapses means more knowledge. It's a network of concepts and their relationship. In knowledge graph, node represents entities, for example, people, place, things, and age represents the relationship between the nodes. There are quite a few knowledge graphs, knowledge databases available today. I don't remember the paper. Yesterday or today, somebody talked about Neo4j. Neo4j is one of the leading graph databases in the world, and generally I use Neo4j because it's a properties graph. I talk in ontology primarily there with a single type of nodes, of which generally we call, monopartite graph, where the nodes are of same type. Yesterday, one speaker was talking about homogeneous and heterogeneous networks. So ontologies are primarily, in that definition, a homogeneous network. Whereas properties graph is a heterogeneous network, where the relationship, each and every relationship could be different from the next relationship, or each and every node can have completely different attributes. In knowledge graph or properties graph, the characteristics are associated with nodes and edges. But in the previous slide, in counterfactual, I talked about the last level is thinking. What does thinking help us? Thinking, a contradiction of thoughts, generates new ideas. And in fact, in knowledge graph, you can discover hidden knowledge and quote-unquote unknown knowledge. It doesn't make sense, right? But in fact, it does. How it does? If you have a knowledge graph with nodes and relationship, you can run embedding. For example, node to wake. If you run node to wake, it will tell you some of the missing relationship. It will also help you to identify missing nodes. And we found out quite a few, 2 years ago, is it 2 years, 3 years ago, in 2021, we had a paper in supercomputing conference where we discovered from NCI thesaurus quite a few diseases and diagnoses in cancer which was not known at that point in time when we submitted that paper. Why? We did graph embedding. That time GNN was not there, by the way. Today you have graph neural network where you can do graph embedding and many things very quickly. But in 2021, the work was done in 2020 during the COVID time where all those technologies were not available. However, by doing embedding on graph, we are able to discover many of the unknown knowledge which was not known to the world at that point in time. But it has the potential to do or discover hidden and unknown knowledge which we generally do as part of human thinking. Now, let me introduce to you another couple of terms which was first introduced in 1929 by Bonnet. He introduced the word latent learning. latent learning is something we learn, but we don't remember. It is like unconscious competence. You don't know what you know. For example, you are driving. Suddenly a small kid, he was playing the ball came in front of your vehicle. It came. What do? You immediately apply your brake. You don't look for where is the brake. I mean, I know somebody was telling me, my wife's friend, I was asking her, why don't you drive? She says, you know, you engineers are bad. I said, why? In car, why don't you put a light next to your brake so that I can find out which one to press? I said, you better don't drive. This example tells us that we don't know what we know. In case of emergency, in case of severity, we apply our knowledge, but we are not aware of that knowledge. That's what we call latent learning, which we introduced in 1929. Then, in 1940, Edward Tolman, he introduced the word cognitive math. That means the math has the cognitive power embedded in it. And he did experiment, live experiment with rats, and found that rats, what we generally call is, reinforcement learning. Without any reinforcement, they can find out path in a maze. And amazing. And then he said that his paper says that you may not believe what I'm concluding, but you cannot challenge the experiment results, and that is true. How? Those animals, or you take the example of animal migration in Serengeti. Within 2 weeks, more than 1 million zebra and wildebeest babies are born. They know when to start the migration, when to reach, when the baby will be born, and once the baby is born, they will get the best nutrients available in that part of the world. Same is true with humpback whales, which travels 8,000 kilometers from Antarctic region to Australia to give birth to their babies. Like that, there are many other examples in the animal kingdom which uses cognitive math. What is that? Spatial temporal knowledge is there in their mind, in their brain. So mental representation of space and time, that is the cognitive math. However, let me tell you this. Any human being who are creative, they also have a cognitive mind. And let me explain to you why. Unlike a Western music, when unfortunately a couple of days ago we lost Zaki Hoshen, one of the tabla maestros, unlike English symphony, they don't look at a script. They immediately, sitting there, they innovate and they do, or even Hindustani music, different ragas. They play with various notations, and they create during the performance how they will present that music. Now, any creative individual has a cognitive math. One, they can visualize unseen solutions, as I said, for any of those musicians or masters. They can connect disparate ideas. Unless you do that, you cannot be creative. They can anticipate challenges. They can communicate effectively. Those are the properties of cognitive math. And all of us have it. I'm not just talking about creative individuals, because it doesn't take much for any of us to become creative. I was just talking to Professor during lunch that, unfortunately, all of us decide a comfort zone or comfort factor. And in India, unfortunately, it happens once you graduate from your college and you get campus placement. Finish. I don't need to do anything rest in my life. And I always say, if India has to progress, excuse me for this statement, professors. I always say, if India has to progress, the first thing we have to do, remove this training and placement department from all universities. Because any student, after they get admission, they take it granted, it is not my problem. It is the problem of that training and placement department to get a job for me. I don't need to study, I don't need to do it. Absolutely true. Now, so, coming back to cognitive graph. Now, I talked about knowledge, knowledge graph. Knowledge graph is the structured presentation of our knowledge into a machine in a graph database. So what is cognitive graph? Cognitive graph is the amalgamation or the emergence or convergence of cognitive map and knowledge graph. So if I combine the cognitive graph and the, cognitive map and the cognitive graph, knowledge graph, excuse me. If I combine those two, then I get cognitive graph. That means I have knowledge on one side and then I have the reasoning on the other side. How to use it? Which cognitive map gives me, which is spatio-temporal, when to use it. When I'm ready to use it, I just go to the knowledge graph. And as I said, that this is a directed spatio-temporal graph, whereas the other one is an undirected knowledge graph. Oh, I'm beating my head down, okay? So, sorry, I'll just finish it in 5 minutes, okay? Now, let me take an example of use case of cognitive smart work. Now, let me ask you a question. Do you think healthcare is luxury or right? What do you think? It's a right? It's a luxury? Doesn't matter. But I'm going to say that today, say it is right. In India, it is a 2060 report. Currently, 60% of hospitals, 75% of dispensaries, and 80% of the doctors are located in urban, that is cities, offering only 20% of the population, servicing 25% of the population. And this, in 1971, 53 years ago, Julian Judah Hart defined it as inverse dialogue. The population which needs medical service more, they get the least service. And those population which does not need healthcare, practically, healthcare is located there. And they get the best healthcare with less need for that. I'm not going into it. These are some of the challenges. But this is an important thing. In 1966, if I'm right, okay, W.J. Ford defined health as an attractor. So he said, human being has been two steps. One is a healthy state, another is a fatal state. Fatal state leads to death. Whereas health state doesn't matter what happens. Even if you don't go to the doctor, don't take any pill, most probably you will run within a short period of time to the healthy state. And if you look at this picture, A and B, this is the health state. There are thousands of states. It's a state machine. Now I'm converting it into a machine. Let me finish first. Okay? I'll show you how it is. So this is from a hospital in Hyderabad. If you can read it, is that from a hospital, CARE. It's a leading hospital chain in Hyderabad and in Andhra and Telangana state. So here is a post-catheterization flow chart. And this is the instruction for the nurse. And here is a flow chart. So if you say this is practically a state machine. where we have different steps, which we can map into a map, a graph, different nodes, and there are different functions. And when will they migrate from one state to another state? It's a flowchart, but it is used by the hospital to make sure that nurses don't treat the patient wrongly. This is a flowchart for that hospital. So what I did here, we call it Bayesian Network Design Studio. It has two components, design part and then formal system part. So the same flowchart has been defined here. And here it is, there is a spatial temporal, and you can see here, this is a cyclic graph. It says that if SCT is less than 160, then you need to give this particular injection. All the graph theory we teach and study are a cyclic graph. Here it is a cyclic graph. And then we take this from the machine, convert it to a formal method, and here it is executed in a mobile form. So the nurse, which is a H device, which is a cognitive device or a AI agent, is now able to see here, okay, we check ACT after 2 hours, and then it says if it is less than this, then give this injection, give injection capability. Knowledge is the knowledge which we know what we know. So we can transmit that knowledge, like all professors here. In the class, most of the time, they share the explicit knowledge because they know what they know. However, there is another knowledge which comes from experience, which we cannot quantify, we cannot always pass it on. However, during the class, a lot of time professors give examples. Not necessarily, they came up with this example before the lecture. So that's a tacit knowledge. They are not aware of what they know. So how the cognitive map, cognitive graph, and cognitive thing is done. Here, it is a probabilistic graph, as I said, that when you convert in health, you cannot say 1 or 0, whether it's a binary relationship. There is a probabilistic case as well. And today, about 6-7 years ago, this technology started. What we talk about process mining. Through process mining, you can have probabilistic graph. And here are 2 examples of cognitive graph in medicine. Here, for a particular type of disease, the doctor is prescribing a particular type of procedure and a drug. It says it is appropriate, inappropriate. What we do in the cognitive graph, mathematically, we look at the path. Optimal path is correct. When it is having more than a threshold, then we know that this particular line of treatment is incorrect. So we say appropriate or inappropriate. And this is going to be used to stop over-prescription. Doesn't matter what you have. If you have fever, go to a doctor. First he will give you few antibiotics and tell you, go and do the blood test. And then, if you have time, do the MRI, these, that, blah, blah, blah. Before you take any drug, you are well, and already you have spent 40,000 rupees on starting from blood tests to different other tests, which are not necessary. And practically, in fact, they are abuse of the medical system. Here it is, cybersecurity cognitive graph, and you can see that these are the various knowledge graphs which has been integrated into this. And I ask a question, where is log4j? There was a serious vulnerability on log4j. Within a fraction of a second, you get an answer. Like, when you ask a question to a pandit or a professor, you will immediately give the answer. And that, to give that answer, they have decades of learning. So I'll just, okay, sorry, I thought that was my last slide. We are also working on something what we call is, now I talked about state machine knowledge. Now everything is on the machine. So what we do is that we transport or export a workflow or a state machine from a hospital to a remote care, to a non-MD healthcare worker to empower and democratize healthcare. He doesn't have the knowledge of an MD. Doesn't matter. Here is an example in India. A workflow has been transferred to a remote place where somebody had a heart attack. How to conduct CPR. And then you also have a video. So it's a complete workflow in an automated fashion. It will work. So this is the architecture of the cooperative smart world. You have knowledge, which is undirected graph. Here you have reasoning, which is a directed graph. And then you have various AI, and you have various edge devices, including sensors, to get sense the environment, sense the state of that, and finally you make a decision. With that, I would like to say thank you very much for this opportunity to share this knowledge, and to BDA. If there is any question and if there is a time, I'll be more than happy to take it.
Sir, in the AI ML applications to medical diagnosis, like tumor cancer detection, there are already platforms built and are available, both radiological and pathological, for identifying or grading the cancer status. So such tools also have to be integrated with this kind of
yes, yes, yes. That's what I said is the knowledge. Yes.
In one of the slides you mentioned cognitive map, cognitive graph as a automata word.
Yeah.
Marriage between cognitive map and knowledge graph. I thought that is kind of hair splitting. Cognitive map and cognitive graph are one and the same to me, in my opinion. I have worked in the past in fuzzy cognitive maps and all that, to give causal inference. Knowing very well that the basic belief networks are other kind of competitor from the probabilistic perspective. So that is one remark. But the next question is, did you work with fuzzy cognitive maps? In this particular case, in medicine domain, not everything is 0-1. There is some kind of fuzziness. So I believe fuzzy cognitive map is the best bet there, rather than
I don't disagree here. What I would like to say is that cognitive map, when it was, the word has been coined and introduced, it was for a particular type of use case. Even they did not include all those migratory animals and all those things. So from that perspective, when I'm also looking at human being, where the system is much more complex, than to answer your question, this most probably will be answering that here. So here it is not binary, it's a probabilistic map. Yes. So depending upon the use case, like in a nursing case, where I showed a flow chart, where the doctor says, okay, if this, do this, otherwise you do that, there it is more or less a cyclic graph, and it can be weighted. The moment it is weighted, here are all those lines which you cannot see maybe here. If you see there are numbers, those numbers are frequencies. So you can then decide, okay, if it is beyond that, like even we do in machine learning.
Yeah.
So level and all those things. Yeah.
In these numbers for the weights, we could choose fuzzy numbers. That's what.
Yes. Yes.
Because fuzzy cognitive map.
Yes. Yes. Yes.
Thank you.
Thank
Very
you.
good presentation.
With this one, in respect to the time, okay, so we'll close it, okay. So the presentation will be around, okay.
Thank you. Thank you. Thank you.
So now we have panel discussion. Yeah. Yeah, please.
So good afternoon. So we have the panel discussion now on, of course, the topic for it is the merger of big data and AI, and what for this panel discussion, I'm the moderator, Chakravarti Bhagwati. I'm a professor in the University of Hyderabad. And panel members, I'll ask them to take the stage one by one. So we have, let's start with the second. We have Srinivas Jenzala. So he's a person who's had more than 35 years of experience in IT industry. He was at IBM for a very long time, working on various IBM technologies and getting to know pretty much majority of things that IBM does. And then later, in the recent past, he moved away from IBM and started his own venture called Visage Global Technologies. And he's looking at several things in there, including cloud computing, responsive UI, and things like that. So we look at him to provide us with some industry perspective on big data and AI and what these will have, what impact these will have. Then I invite Dr. JVR Sagar. He's from DRDL. He's also a scientist with more than 30 years of experience at DRDL, working with a variety of technologies related to defense, missile development, and also high-performance computing. He's an outstanding scientist and an associate leader, manager, what do you call it? Associate director of technologies at DRDL. Then he also worked as for 2 years as the director of Anurag, and right now he is heading a group that's looking into AI and multi-petaflop computing for defense purposes. So it's a wonderful thing for us to have him here to provide a slightly different kind of industry perspective on big data and AI. Then we have Professor Vadlamani Ravi from IDRBT. We know him fairly well. He's been with us for a long time, and his area of specialization, as many of us know, things related to soft computing and everything related to soft computing. And one of the things I should tell you is that again, he has a vast experience, more than 30 years, and various positions and at IDRBT. And one of the interesting things about him is that he does think out of the box. And we are looking at him to provide the out-of-the-box perspective, thinking perspective on big data and AI. Then I have Professor Upendranath Sharma Chakravarti, who is also a professor with more than 35 years of experience. He is from University of Texas at Arlington, from the Department of Computer Science and Engineering there. Now, it was of course very interesting for me to read his biography because it kept saying Dr. Chakravarti, and my name also is Chakravarti, so it was kind of funny to read that. But I should tell you that he's been working in areas like stream data mining, then also graph mining, and he's very much interested in providing his perspectives on big data, cloud computing, and big data analytics, especially with respect to AI. So it's very nice to welcome you four onto the stage for this panel discussion. And I sort of structured the panel discussion in a certain way so that it helps us to get the best out of this in the given time constraints. So there are three stages in this. The first stage, I'll ask each of the panel members to talk briefly, I said about 4 minutes maximum, about their own broad perspectives on this topic, and especially based on their experience. So these are individual broad experiences that they give us. After this stage, we will go to stage 2, where I'll be asking certain questions to them and promoting some kind of a discussion, as is the right thing to do for a panel discussion. And then at the end, we'll have interaction with the audience. All the audience can interact with the panel members based on all the various opinions, perspectives, and experience that they have with the topic. So let's proceed with this. We also have a fifth member who is unfortunately stuck in traffic, and the last I know is that he's somewhere near Medipatnam. Okay, so if that person can make it, he'll join in the middle of this discussion. Otherwise, we'll proceed with the 4 people. And I request Mr. Srinivas Janjala to give us his perspective on the topic, which is big data, AI, and the impact, how their merger can impact our everyday lives.
Good afternoon, everyone. My name is I really thank Mr. Chakravarti for having me here. For having me on the panel here, and this esteemed panel that we are thankful. And at the outset, I would like to give some kind of insight into what we have done over the years at IBM in big data and AI, and what kind of challenges we are facing. As you probably are aware, nowadays the generative AI models have become commonplace, and one of the things that IBM has been encountering is when catering to its clients, we want to go through the various sections of data, analyze legal documents, contract documents, and contract documents really run into several pages and several megabytes of data. So we don't want to go through, we don't want to spend time in going through the documents. So we'll allow this model to run through and then come up with the dates. Okay, when this particular contract is going to expire. And you ask a question, like then immediately some kind of what will be created. You ask the question when this particular contract is going to expire, when it is going to start. So these are the areas where we have been using, and we found a lot of times they are not, they do a pretty good job in coming up with the answers to this. We still have gaps. Some of the customers are coming up saying we can't rely on this particular model alone in terms of giving accurate results. And secondly, the another thing that we are facing is that the bias. Bias is one big challenge, especially when you have a loan application. IBM has been in the banking industry. We have developed loan application. And when you do loan application, the person who applies for a loan will try to do some kind of automated credibility rating, etc. So the credibility goes down based on the background of the person. Right? Sometimes if the person belongs to a particular demography, then it will bring down the credibility of the person. So those things are not really good for inclusion. Financial inclusion is one of the things that we want to ensure, but these models are so biased, and the kind of data that they have been fed in is so biased that they are not really correct. So that's something huge challenge for us for the industry. And second thing is the third thing I'd like to give an example is that if you go and simply Google cat on the wall, okay? Cat on the wall, just say it will give you cat on the wall meaning, etc. Google. But at the same time it will do images also. Just click images. You will see 99% of the images are in Western setting, a cat in a Western setting, a wall setting, around the environment
will not find very few of them. You find any other alien Indian, you have cats in India as well, and cat is sitting in Indian walls, but you won't find those images at all. So almost 99%. So the kind of data that, so there are drawbacks, huge drawbacks, I would say. 2v6 maybe. Even some of the Google architects we work with, they say the models are only up to 60% of the time they work. So my interest is how we can remove the bias, what kind of algorithmic changes we have to make. That's a very big challenge. And to remove the demographic related errors that have already gone in, and the huge challenge. So those are the areas. And I'm interested also in the area of logistics. Currently, I'm in a company in the warehousing area, warehousing domain, where we provide services for e-commerce clients and quick commerce clients and various clients who are maintaining warehouses, warehousing efficiency. There are a lot of challenges. I'm trying to look for solutions in AI and data area. How we can efficiently manage the warehouse and then cost-effective way, and then reduce the cost for the end user. Right. Second thing is we have perishable goods, we have expiry date goods, we have make sure that delivery happens quickly, and how we can packing material, not to waste packing material, efficiently pack the things, and not that so that it will not put impact on the environment. People will get what they do. Once they receive goods, they just throw in the package, and that's going to be a huge impact on the environment. So how can we reduce that? How can we use less plastic? So these are the areas we want to really work on and ensure that the logistics efficiency is achieved. So these are the areas that I am interested in and I am looking into insights. Thank you, sir.
Thank you, Srinivas. So I now ask and I'll ask Sagar to give us his perspectives on big data and AI in defense.
Good afternoon, everybody. First of all, I'd like to thank the organizers of BDA for having given me this opportunity to participate in this panel discussion. I come from DRDO, so I would like to share my views and experiences with AI first of all. As AI as a technology has been a great enabler for us. In recent times, we have found that AI has done excellently well in object detection, object classification, target identification. These are all very important areas in a battlefield. And this is where the commander in the battlefield is going to get a big advantage if he uses AI technologies. Coming to other areas, drone-based technologies have come up very well in recent times, and we have heard in the recent battles in Ukraine as well as Israel that drones are playing a very big role. Here again, AI is found to be very effective in various battlefield tactics and how to use drones. It gives a very cost-effective solution to in a war, and that is what makes so important for us. So, as I told, object detection, object identification, object tracking troops in forward areas. These are all very interesting applications of AI in a battlefield. Then other applications are in the battlefield. Typically, you will have sensors from multiple sensors. Various sources of data will be there. Like you will have a radar. You could have satellite-based data, you could have human intelligence, you could have communication intelligence, electronic intelligence. All this data becomes structured and unstructured data, and this data goes into the AI-based system to give a decision capability to the commander. It's a question of life and death for the commander who is sitting in the battlefield, and he has to take a split-second decision, and that is not possible with a human brain. And this is exactly where AI is able to ingest enormous amount of data and give a decision quickly, whether to use his weapon to attack an adversary or save his weapon for a more threatening target in future. So coming to human troop management and logistics also, AI is going to play a very big role. AI will decide when to deploy a weapon where, because after all these weapons are very costly and we have to use them very sparingly and in an effective manner. So what I foresee in the future, this will become a computational war. It is a war of algorithms between us and our adversaries, and the one who has got a better algorithm is going to win the war. So AI is going to make a big mark in the future wars, and we are already seeing in the existing wars also. Secondly, coming to big data, also we find that big data has a very big potential in designing more superior weapons for our armed forces. Today, we have wealth of information available based on the last 30-40 years of design experience. Data generated as a part of design, development and testing. Enormous data comes from any test which you do at the field level, and all this data can be used probably by a generative AI model, and it can give a design solution which will be much faster. So the cycle times are going to get reduced drastically. See, what was earlier taken as 10 years for development of a weapon system, now it is coming down to 1 or 2 years because we are able to take advantage of these kind of AI models, these generative models. The other thing is cyber security. Today what is happening, war is becoming a non-combat network-centric war, wherein the adversaries will typically try to do damage to your cyber network and it will cripple the whole nation. So this is exactly where AI can be very useful. Big data with AI definitely can find out what are the anomalies and what are the trends which are there on the digital network. It quickly point out that there could be a calamity and it can act fast even before that calamity takes shape. So this is also another area. And in addition to this, AI has found a lot of applications in quality control, supply chain management also. A typical example is welding defect using AI is found to be very effective. The accuracies are very good. If any weapon system or hardware, there is a weld defect somewhere, it is going to be catastrophic. So such cases we have to be very careful. We should not use those weapons, but the time is too less to detect manually. And this is where AI can quickly, and simple CNN is able to give a very good solution with a very high accuracy of detecting the weld defect. So these are other areas. Then similarly, as I told, supply chain management also, it is now becoming very useful to use AI, because sometimes some systems or components are not readily available. Sometimes the design of the system gets delayed because of non-availability of a particular component. These are other areas, and we are exploring a number of areas in AI as well as big data, and we have found them very effective for the military requirements. Thank you.
Thank you, Dr. Sagar. Now I'll ask Ravi to talk about his experiences.
Thank you very much. First of all, I thank the organizers of BDA for giving me this opportunity to be part of this panel. So I belong to the era where the backpropagation network just erupted on the scene, 1986. I was in my second year of masters at that time at IIT Bombay doing my statistics and masters. Then there was a lot of buzz in the computer science department. Fortunately, computer science department and our department were very close, and there was a lot of interaction going on. And everybody was talking about this, and we were kind of kids, did not know what was happening around us. And professors will not normally tell everything that is happening because they are also waiting for the kind of thing what was happening, etc. Then we kind of patiently waited to figure out what was happening. By the end of the year, we could know why that was kind of important thing at a very superficial level, let me tell you honestly. But then, the moment I took my first job as a scientist in CSR laboratories, my journey started there. Okay, into you can say entire continuum of, I'd say, starting with statistics and operations research and then ending with data science. And I'll just describe briefly. So basically, at that time, the previous speaker, Professor Samadar said, they are talking about symbolic AI. So when you talk about developing something, a system in AI that has necessarily to be an expert system, with maybe case-based reasoning here and there, spiritual, but then the narrow-mindedness was so much at that time, you will be surprised that a person working in your network cannot be considered as an AI person. And see that extreme of the so-called spectrum. Now see the other way around. People are developing a logistic regression model that is considered AI. I have seen the other end also. The pendulum is swinging back and forth like this. I am a curious watcher. Okay, then I see a dent on this. And definitely I thought I have to make some kind of pedagogical contribution just to remove some confusion and kind of demystify this concept, jog and wise. Sometimes no malice intended to any vendors. Vendors create a lot of confusion, and academicians kind of get taken away, get carried away by this, and I'll let you know that. So basically, when the first kind of amalgamation or I would say unification started in the community, somewhere in mid-90s or late 90s, the umbrella discipline, I use this word umbrella just to get the kind of unification much explained very clearly. So umbrella discipline in the form of first umbrella discipline in the form of data mining started, and that was a consortium of statistics, operations research, machine learning, and databases. And this actually taken the entire world by surprise, and people started getting enabled by this concept, started using this concept left, right, and center almost every project, wherever data was there. That is the primary requirement. Then suddenly some mid-2000s, another kind of jargon was coined by the name of analytics. And in between, a lot of the things were happening in the ML, quietly unnoticed by the so-called AI guys. Okay, I will not talk about that. All of us know that. Then suddenly in mid-2000s, analytics word was coined, and they said at the broad level there are only three kinds of analytics. One is descriptive, predictive, and then prescriptive. At the same time, they said descriptive analytics constitutes your descriptive statistics on one hand, and if the query becomes multidimensional, then you have to OLAP, online analytical processing, which is an industry term they call it business intelligence. Doesn't matter. Okay, let them call that right. So now that was the part of descriptive analytics where you operate on the raw data, you are getting only information. But when you know knowledge out of this so-called raw data, then you have to apply algorithmic approach, and that is where the predictive analytics came into being. And at the same time, predictive analytics constitutes your data mining, text mining, and web mining. So what is the new thing now? Suddenly the source of data started ceasing to be structured anymore. It started, assuming other different manifestations or avatars, you can say. Suddenly the data definition has become elasticized, in the sense that it has got three different connotations: structured data, semi-structured data, and unstructured data. So if you are doing this mining on structured data, it becomes data mining. If it is on unstructured data, it becomes text mining or unstructured data mining. And then semi-structured data was also became prevalent, and that is called semi-structured web mining. And these three things became part and parcel of predictive analytics. And then finally, then the so-called service industry woke up from deep slumber. They said, no, we have to take care of this cognizance of the situation, and then start applying these methods in our kind of business problems and operational problems. Then suddenly the prescriptive analytics came into being. There we said, if you tell us what is the information available in the raw data, I am not happy. Or maybe it is so useful for the top executives. If you can make predictions in the future, yes, that is definitely useful, because that will ramp up the business and then give me the profit and improve the bottom line. But if you want to tell me what I should do, that is where the prescriptions come into picture, or business insights. If you apply scientific disciplines, scientific insights. And that is where the entire gamut of optimization, coming from calculus-based optimization and evolution computation, everything became part and parcel of prescriptive analytics, where people could optimize something and then give recommendation to the organization wherever it is applied. Now, if you could carefully observe, the so-called data mining one first umbrella discipline what we started with became a subset of predictive analytics. That means another unification started happening quietly without anybody noticing it. And then, as it is not sufficient, suddenly big data erupted. As our other co-panelist, Dr. Sagar said, he gets data from defects and other industries at various sources and various sensors. It could be multimedia data, audio data, video data, various varieties, and then suddenly they come and disappear before they take cognizance of that. That means a lot of decision making has to be very fast there, and that is when streaming analytics becomes very important. When it says streaming analytics, all the three things will happen, all the three flavors. So that is where big data analytics as characterized by analyzing the volume, variety, and velocity. These are the most critical things of big data characterization. You have to have mechanisms and wherewithal to analyze all these things. And that is where, fortunately by the time, plethora of algorithms have already emerged in the scene, where people are actually competing or collaborating. In that point in time, there was no collaboration. Even at the advent of data mining, people were not collaborating with one another, but they started collaborating thanks to the umbrella discipline called data mining. Now, at this juncture, suddenly the so-called Web 2.0 happened. So people started sharing anything, uploading. In that time, only downloading was possible. Uploading of any content. You call it, business data, scientific data, academic data, private data, public data, personal data, financial data, everything getting uploaded. What is the use of asking? They don't even know. Because the feature is there, I'm uploading. That is a simple answer, very naive answer they give. Right? But in the process, the explosion of data happened. Therefore, people started making the killing out of this for business purposes. So that is how social media analytics came into being. So social media analytics as a norm of big data analytics, and suddenly this deep learning phenomenon took everybody by surprise. That's the fourth generation of neural networks. Then everything took a total different turn. For example, a field like image processing took the total beating because of the CNN architecture and all that, and varieties of its variants. Because of that, its relevance to actual advancement of reinforcement learning. Driverless car, if you talk about now, it's the emphasis behind that is deep reinforcement learning, and balance between deep learning and the reinforcement learning. So all these things are happening at the same time. I'm curious, watch, I've seen everything, but trying to learn everything where it can apply within whichever field I've been there. Last 20 years I've been working in financial engineering, computational finance, as applied to banking, finance and insurance. So we could actually learn many of these things and make some modest contributions to them while being able to apply to them to take the benefit out of that entire thing. So what I will tell is that our AI now, including Gen AI, became a subset of data science. That is my take on that. And then, not only me, before me, even IBM recognized this, Amazon recognized this, but nobody gave this kind of continued kind of argument. I thought, let me put it this way, for pedagogical purpose as well as for demystification purpose. So now, if somebody says big data and AI, I can only kind of smile at that because AI is already part of big data analytics. Only one word is missing there. If you call it big data analytics, already AI is subsumed them over there. So that is where I kind of, yes. Yeah, thank you. So this is where I stop and tell a lot of this unification actually brings a lot of unity amongst that different thing. People should not resort to drawing borders within the water, boundaries within the water, and hate splitting. That's the only kind of message to everybody, whoever is not accustomed to this or maybe not familiar with this kind of concept. But otherwise, there is a lot of opportunities existing in this field of the science element, I would say. Thank you very much.
Sure, but keep it short. I had actually sent you some format. I actually sent you a couple of emails on how the organization, but that's no problem. But I'll ask you to keep it. I'll ask you to keep it short.
I don't need to read this, but that's okay. I think so. This is the topic that was given to us. I'm sorry you faced me. I'm not able to see that. Sit there. Come on. Come on. Yeah. So the topic that was given to us was the impact on our everyday lives of the society as big data and AI come together. So maybe I took it too seriously. Moreover, I'm an academic. I'm not used to that kind of free talk. So I have underlined a few things that are useful. So what is the impact on both society and our lives? So that is what I'm trying to answer first. This is a broader view of what analysts about not my personal experience. I've been doing it in this area for a long time. I think some are very beneficial. For example, natural language and image translation. I was in China for 6 weeks teaching 2 courses. Without this image translation and natural language, I couldn't have managed there at all. So this is just one example of that. There are a lot of things that are being enabled for a disadvantaged group with the help of AI and deep learning and other technologies that are very useful. I think personally it's much more powerful than search, which itself revolutionized the way we use information. So I'm talking about in general AI and big data analytics. On the other hand, it is not the same story every way. So you can also look at it as leveling the playing field. Further, cloud computing was supposed to level the playing field for businesses. This is hopefully to level the playing field for the common man. And I think that's very important. On the other hand, there are some very serious adverse effects of this one, which we need to be cognizant of. We can work in our own domain and use it for whatever purpose that is fine, but I'm looking at more generally. So I will make some bold statements, you may be surprised with that, so bear with me. As with this, with any technology, this will also play a dual role. So the question is, it is more dangerous than technologies such as nuclear, guns, and war machinery. Okay, so in my opinion, yes, because in our experience, controlling software is much more difficult than any other thing. We are not being able to do it. The examples are malware, ransomware, social media, etc. So we have seen that how much havoc they can create if we don't know how to deal with it, manage with it, or come up with laws or control it. So this is the real problem. So now let me go back to the topic and just give one slide introduction to what I think are the things. So what is big data? We are talking about big data. At least we need to understand the basic. What is AI on its theory? What do we mean by coming together? And why or whether we should be concerned. So these are my personal opinions based upon research and other things. So this is everyone knows big data is 4 weeks. That's right, it's not just 4 weeks, it is the holistic analysis of these 4 weeks. That a lot of people miss out. It's not just we know how to do volume individually, we know how to do velocity individually, we know how to do variety individually, but we don't know how to do all of them together. So here is my take on the difference between mining and big data analysis. So mining is very specific, very specialized. You take the data and apply and come up apply a specific technique. Whereas big data analysis is a life cycle thing. It's more an iterative process where you take any general data and you have a general model. Here I use some multi-layer, but don't worry about it. I do, so don't worry about it. But the process is the same. Going from data to a model, expressing your objectives and finding constraints, computing them, and then visualizing them. Visualization is very important because we are doing other things. A web dashboard for these things, and I have a paper tomorrow presenting on flow. So there is a big difference between the mining mindset and the big data mindset. So here is my view on what it takes to go from individual analysis we are doing versus holistic analysis. So this is very important for us. We know how to do structured, we know how to do unstructured, we know how to do multimodal, some of the things that were definitions, points, video, technology, but we don't know how to do them together. If all of them come together, so here is where big data and AI, in my opinion, come together because the approaches that you are going to use are neither mining approaches nor deep learning. It's a combination of them. You can use whatever you want. There's no restriction on what we should and what we should not use. But the key is transforming multiple data types holistically, not individually, into knowledge and decisions. Whether it's in the practice field, whether it's for business, whether it's for teaching, it's the same problem. So here is my big picture on what we do, whether you do big data analysis or you are doing AI, you are doing generative AI. So this is the general picture, right? Our problem is to take very large amounts of data of different types, take different objectives that you want to analyze out of it, and whether we can do that using whatever techniques you want to use. And the key is to reduce the knowledge, reduce the data to a knowledge which can be used. That's why we call it transforming knowledge and decisions. So you should be able to make decisions, you should be able to derive knowledge that can be used. Doesn't matter what area you are working in which arena you are working in. I think this is the basic problem everyone created. Now, let me give my view on AI and its progress. Fortunately, I have had the friendship and have watched AI through the roller coaster ride from the 70s onwards, from the expert system to all the way to other issues. So I have been fortunate, and I will just also ups and downs. There was a time when nobody cared about it, there was a time when millions of dollars were poured into it. The thing is, there have been convergence on several levels, ideas, topics, algorithms, and they have matured into products for end users. I think this is the big difference I see. Earlier, they were used in very specific situations, very specific times. Today, it is becoming a general purpose sort of a commodity product that everyone can use. The robot is a good example of that, that can serve you whatever you want and talk to you in an assisted living environment. So the use of mining, machine learning, and combining with large amounts of data is not new and has been going on for a while. That answers one of the questions. Our ability to generate LLMs, large models, and very large amount of data, diverse and disparate, something produce something that is new, is an evolution in the AI, combining all the things that have been happened before. However, I have a warning, the black box nature combined with the inability to explain the results and the non-deterministic nature is to be concerned. So here are the details of it. So what does it mean? Makes it difficult to understand the data used with governance, biases, somebody mentioned, of all kinds. There is not just one kind of bias. In the data used, biases in algorithms, how data is updated, privacy issues. So these things are brushed under the rug many times and we don't understand it. Quantifying bias and privacy in a global manner for universal data is a huge challenge. We still don't know how to deal with it. That we done in specific domains like healthcare, but to go from there to a inability to explain. This has been a problem with neural networks from the beginning. Experimental AI is a vigorously research area today because people want to know how you are deriving your conclusions. Without that, how do you trust that? So Plato's word will not be useful if you do not believe in that. Scale and complexity of neural networks pose big problems for this. Essentially, they are saying, trust me and do not ask for how we get the results. This works until something goes basically wrong. Second part, non-deterministic output. This is something to worry about. As the underlying data, parameters, and models can change, the result may be different for the same input. And also the correctness. How does an end user at large, not familiar with AI and big data, how does he trust this one? Because you don't know whether the answer. So accuracy of results and correctness over time is also an issue. Contrast this with such a freshness where this kind of ambiguity is not there. As you are not guaranteed to get correct answers always, how will the end user rely on the results? So in fact, on the very future workforce, we deal with it as a university because we are now to decide whether we should allow students to use ChatGPT or not ChatGPT to their homework or their project. This is a huge question because if they just learn to use ChatGPT, they will go out as robots. They cannot think. Is that what we want for the workforce? So ethical issues of using it in industry and ownership of code and outcomes generated. So last slide, interesting experience. So this is another thing nobody talked about. Human thinking and problem solving includes experience in an intrinsic way. How will these systems bring in experience into the equation? Knowledge graphs are fine, and cognitive graphs are fine, but they are not substitutes for experience in any meaningful way. I think we will have to go a long way about this one. Context. This is another very, very useful, important thing. When a human being answers a question, there is a context around it. When I ask a question, there is an implicit context, or you can ask an explanation. If that is lacking, then the answer may not be meaningful at all. Just I'll give you one example. If you ask a question before and after the 2024 election, the answer will be very different. Now, the fact can be
board that election has happened, somebody has come, but the context is not possible to replicate in the same way, because any economical question, even the issue question, cannot be answered in the same way that was being answered 2 months ago. But how do we change the context based upon past experience? So that's my experience.
So now I'll just we'll have a couple of more pointed questions with some of the basis of these questions has already come in the different things we have presented and talked about. So the first one I want to ask you is, see, we're talking about big data and AI in this as well as in the conference. The idea of an umbrella has already been outed by the channel network. If I look at AI today, it's data driven. There are large training sets, LLMs use billions of tokens. So already there is big data in there. So what is the additional thing that you see coming up with this big data plus AI coming together? Because already I think of AI as big data being subsumed by this AI. So, just any opinions on that?
Yeah,
all four of it.
Okay. My view is, when you talk about AI, you are essentially talking about underlying algorithms in whether they are deep learning algorithms, whether CNN algorithms, whether there are other kinds of algorithms. So AI is a basket of algorithms that are based upon statistics, that are based upon various things. So big data essentially uses all of them in its belly. So it is not that you can cleanly separate these two, in my opinion. They are not, they are intertwined in many ways, and I think it's perhaps useless try to separate it. Because one is needed for the other. AI, these algorithms need large data. Large data analytics need these algorithms. So how can you really try to separate them?
This better place, what the professor said. Basically, when you said AI is using billions of tokens, right? But then it's also taking a lot of data as well, right? And then if you look at the predecessor of ChatGPT, the GPT-3, it has 175 billion parameters. The thing people are talking about parameterization. Right. So every kind of thing, whatever gospel that people learn in statistics come for a task already. So once you go for implementation of ChatGPT or its competitors or its inferencing mechanism, is already part of big data. You are already doing big data, I will say. So once you are doing ChatGPT, you are doing big data analytics. I put it that way. Okay, and then depending on, of course, compared to other domains of application of big data analytics, ChatGPT, I have got some comparing news. I don't know if some may not like it, but basically the thing is the advent of so-called ChatGPT and then the furtherance of LLMs has got a lot of societal and environmental impacts, which people are conveniently forgetting. Talk about an education setting like this. Professor gives an assignment. So where it runs the boundaries, can you say that no students should not go to ChatGPT? If I were there, I would say don't go. But how do you detect it? Fortunately, there are tools. Just like these tools, AI tools also have come. So it's like, it's like a double-edged sword, and that's what we need actually. Therefore, that is one part of it. That means students are abdicating their responsibility, and then professors are kind of colluding with them in some sense. But the second thing is environmental. We will come to that. Environmentally, lot of carbon footprint is released. Who is caring about that? So GPT-3, they have an estimate. If you run only one inference, not a training part, then it is equivalent to one fully loaded aeroplane of 300 passengers flying from New York to San Francisco coming back. So much of CO2 is built in the atmosphere. And who is responsible for that? Another estimate says that if you do perform one search in Google versus one search in ChatGPT, ChatGPT consumes 100 times more energy. Many people are not worried about it. And I'm worried, I wish, as a citizen, as an academician. So these are all the other things that we have to be worried about. On top of that, it brings a lot of baggage like hallucinations. So what are we doing about this entire exercise? then unfortunately people that say Gen AI, they are equating with LLMs. That is not correct in my opinion, because Gen AI has got a lot of other things. Broadway, you got GAN, you got BDA based auto encoder, variation auto encoder, diffusion models. You don't have to call this business. While they deal with structured data as well as unstructured data. So they don't have this kind of environmental concerns and all that. So these were I don't know how many people I promote, but thank you.
I think there's a fine difference between LLMs and big data with AI for the reason that LLMs are more linked to natural language processing, as I see from my domain, whereas big data with AI they find a very good application or a good use case when I am getting data from diverse sources, especially IoT based devices and other kind of sensors. Big data will prove very well, I feel. So the problems in LLMs like bias and hallucinations are less likely to be there in big data, where you have a variety of data, the volume is more, and the variety, all the 5 V's or 6 V's, whatever we are telling, all this come into picture in big data. That kind of problems are less likely to be found in big data. So what I feel is LLM could be considered as a part of a bigger ecosystem in which big data is there. That is my opinion based on what which I have done. For example, I'll give an example like if I can use an LLM to suggest how to troubleshoot a problem, but to give a decision in the field in real time, I would like to use a big data AI, which will give a more correct solution. LLM could be very good for giving language-based solutions most of the time. Though it is taking millions of parameters, I feel that the hard real-time system, a big data-based solution is going to be a better one than an LLM-based system, which will most likely be a suitable solution for natural language or those kind of text-based summarization and those kind of situations. That is my opinion.
So let me give an example from the real world industry experience. Like for example, a customer bought a washing machine, okay, and so the customer sent an email to the support saying I bought this washing machine and I've been using it for the past 10 days. I ran into this problem with washing it doesn't wash the clothes properly or whatever it is, consumes so much of water. So you have explained your experience of washing machine. You say the last 1 month you explained. Okay. Now the machine behind what's happening now in the industry, the guys are putting machines behind customer support. Okay, and they go through this text and then they come with a saying some kind of is it a complaint, a compliment, a question, what is it? So in this case where I have written the email, based on the email, it will complain if it says complaint. The reason though you nowhere I use the word complaint, but it will go ahead and figure that out as a complaint that is reviewing about the washing machine and recording it as a ticket to the respective team, etc. So in this case, what has happened and then for the customer to answer your question, sir, you have used data science to go through this data and inferred it to artificial intelligence mechanism that something is a complaint. Okay? So basically it is a subset, the inference is intelligence, and then if the process of going through the content of the mail and then coming out with some kind of a 60% probability that this is the complaint or question or some kind of a compliment. This inference is nothing but what our understanding of the industry is. So basically, at a high level it is data science and AI is basically inference. When you come up with some inference, then we consider it as intelligence.
So I want the audience to keep track of some of the interesting points these people are making. So another 10 minutes or so we'll have an interaction with the audience. At that time I would like you to grill. So the other thing I want, this is another thing that's been bothering a lot of us, is that the AI has gone through a roller coaster. There have been many versions of AI, so to speak. And the previous versions are largely been academics driven. They came out of big universities, MIT, CMU, Stanford, and such places. But now this AI is largely driven by the industry, the big 4, big 5. These are the people who are driving the AI today. So I want to know what you think is the focus of the AI today. Is it different from the earlier versions of AI, or is what is between AI in this current avatar versus the AI behind the scenes in the previous avatars and this industry-driven focus? What is it doing? So that industry-driven, I want to ask the two of you. Academics-driven focus, I want to ask the two of you.
Yeah, in the earlier avatar, it was more of academics. Like it was on, the research-driven AI data science has been going on. Now, industry is making use of these, especially with these high-end machines that are available to tokenize the data. These machines are not there, such a high-end machine are not there. And with GPU processing coming into the picture, and then they are able to generate these cognitive graphs, knowledge graphs so well, so quickly, and you can come up with some kind of a conversational bot from the data. You have like terabytes of data fed to these systems, and you can quickly come up with some kind of conversation. You can start conversing with it. Once the model is created, you can start conversing. Because that is what the current state is all about. So they want that. Nobody wants to spend hours and days in analyzing these terabytes of data. Whereas this model can do to the ability, it can, even if it is being 80%, 90% accuracy, that's okay. They just want to refine their thoughts. Okay, how my model is going to do the next. Okay, basically, based on data, do you think I will be running the losses or I will run the profits, or my product was successful or my product failed? These kind of things, the executives are very nervous. So to overcome the nervous, they will try to give the data and then get some kind of thought. Okay, my thoughts are somewhat similar to what this machine is also thinking. That gives them some kind of confidence. So that is where they, even if it is 60%, 80% accuracy, that's okay. But the confidence level gives them the ability to take proper decisions. Right? So we are now in a phase where this particular way of use the kind of computing power that is available. So the AI has come out of PhD for the industry. So that is where they are.
Yeah. So I just interject here before you take over. Just in as a joke, it is said often that Valentine's Day is an occasion that's created by Hallmark to sell more cars. Right? So there is also a running joke that the current AI has been invented by NVIDIA so that it can sell more GPUs. So I'm just trying to sort of soften. Yeah, I will definitely do it. Yeah. So that's a fun thing about this industry-driven AI.
The mic problem is here.
Already lost what?
Second part is of course
Yeah, I'll repeat once again. The difference is between innovation and implementation. The big four are they are actually concentrating on the implementation, whereas the academic institutes they are concentrating on the innovation. They are trying to bring out better and better algorithms. And the other part is regarding the way it is being done. See, the industry is trying to quickly bring about solutions, bring new models quickly using the existing models by tuning them. And another part is, as far as the data sets are concerned, the industry has got access to a much bigger data set, whereas the academy doesn't have data set. That's a limitation. I think that also makes a difference. So to that extent, maybe because the industry has got a bigger data set available, the problems of bias and hallucination may not be there in the industry-based models. And as far as data protection is concerned, I think this data which is generated by the industry is all private to the customers for whom they work. Whereas the data sets for the academic institutions, they are all public data sets. I think that is where the difference lies. But I still strongly feel that the academic institutes are going to drive further innovation, and this will lead to better models by the industry in future.
So, maybe the academic perspective.
Well, I may not give the academic perspective. I want to give a kind of combined perspective, but you made a fantastic observation. What is that is spot on. So basically, if you look at the kind of change that happened, it is not restricted to AI alone. If we take ourselves back to the big data, that also was started by Yahoo, Google, and all those things. So primarily because at the time there were service industries at that time, but they ceased to be service industry alone. They also became big IT behemoths. And in the process, why they became like that? Because of the convergence of three important dimensions, I would say: data, compute, and then fantastic, powerful algorithms, which can crunch any kind of data, be it structured, semi-structured, or unstructured. Because of this wherewithal that these kind of companies were possessing, they wanted to lure these professors from various places, right? Includes your, Jan LeCun, Subscriber, and all those guys. Okay, and then Andrew Ng as well. So then it is not that, the universities actually given up on them. It's go back. So it's not that the top universities have given up on the professors, but they said let this synergy take place. And here we have to look at the complementarity aspect. So as Dr. Sagar said, innovation is coming from the professors, but then the other part which is required for the ecosystem is all provided, including data and compute, is provided by these NVIDIAs and all those guys. So this kind of unique holy marriage we never saw before. And that answers your question. Thank you.
Yeah, so I should just say that I also worked in the industry for 5 years in Boston before I went to academia. So I have some insight into that. So my take is, somewhat similar to one of the comments made. So if you look back into how AI was being used, I don't know how many people remember a system called ELIZA. If you remember that, it did not go anywhere because of too many, this was for the doctors. It did not go anywhere, and also you might have remembered the Turing test and all those things. So why is this sudden shift? I think the time is right. The technology has matured to a point where you can bring out products and monetize it. Companies are interested in making money, not doing research. It's very simple, hard truth, whether they like it or not. So, and the other thing is they are sitting on huge amounts of data, as somebody said, that is proprietary, which they can monetize very easily by generating billions of parameter LLMs. So people think it is very good. So my take is, it's a journey. If something comes out too early in the game, it will not survive very much. There are some examples along the way. So here for AI, it has gone through so many ups and downs. For those who are familiar with know that. But today, it has reached a point where you can monetize it. You can produce products that are widely used like commodity products, and I think that is the big attraction.
Okay. So that's a very nice thing that's come out. So I have no. We'll do that at the end maybe, or do you want to keep it short? Yeah. Yeah. So short. There are a couple more questions.
So I have one pointed question, Professor Sharma, that how many H100 GPUs does the university have? Okay, but okay, I'm not interested to look at the exact number. Is it one? Can you count it on 10 fingers, or is it in the hundreds, or like what is that? Okay. Okay.
The university is different from the research labs.
The research labs. So H100 GPUs you have your hands on 100. Okay. Okay. Now, in India, I don't know whether any education institute has its hands on any of them has a hands on the even one H100. I am not aware of that. So it is something like I want to say that with respect to our the educational situation. Okay, you have 100, but Elon Musk has 100,000 of them. 11,000 of H100 GPUs. No, no. The point I'm trying to prove is to reinforce whatever has been said, which is that the academia are getting wiped out because of this very huge difference between the equipments and all that. Okay, so
We have something called Texas Academic Computing Center, which has the largest amount of megaflops in the country or maybe in the world. So I don't know about the Indian situation very much, but there are NSF provided centers that I use for my research. I don't have to buy all the equipment, but it would be nice to buy if I had the money to buy. But that is only one aspect of it. See, you need certain things, but there are different ways in which you can manage, if not as much. So computing is certainly essential, but Google just announced a few weeks ago they are building 500 megawatt nuclear reactors supporting AI. And yeah, universities cannot do that. I agree with you. Money, that's what I said. These industries were not existent before 2000, except Microsoft and IBM. But now there are very deep pockets and they can invest, Meta and Google and Yahoo and Microsoft and IBM. So they can invest and so academia certainly can provide support and brain capacity, but not monetary capacity.
So just in the interest of time, I'll ask one more question and then we'll open it completely to the audience. So this question really, I think a lot of younger people will be interested. What's the impact that you see in industry on, say, the recruitments, freshers, the skill sets and others you're looking for from people, the impact of big data and AI? The skill sets, the recruitment policies, and so on, especially the freshers, and so on, coming into industry. That's one perspective for industry. From the academic side, it's the same thing, but it's with respect to the students, the curricula, and the evaluations, and those kinds of things that we see for the students, and also the impact on the teachers and the teaching methods and practices.
Yeah, coming from...
This is the last question before we'll open to the...
I mean, typically, we, at least the industry I have worked with, we don't generally come into universities to do recruitment, just particular, skill of AI, etc. Generally, people should have the latest, knowledge. It's just that, people have to have a strong problem solving skills. Okay, that is where the crux of the problem lies. You have to have the fundamental problem solving skills and your analytical skills and your programming. Programming, if you are an excellent programmer, whether it is Java, C, Python, doesn't. But you should have a good programming skill, and those are critical. Even today we look at, and then once that person is recruited, based on the requirements, the way roles will be allocated. And coming to that, skill gap, still I find the gap is that a lot of students are still not up to the mark in terms of problem solving skills or their programming skills. I mean, it's across the board. I would say 90% of them are not up to the mark. Only 10% of the university students, and it is really a big challenge. So forget about seriously. Students focus on problem solving skills, and you have a lot of tools available that you have code chef, hackathons, various things, and I request people to students to take those competitive things and then come up your, improve your skills in the core areas. And it doesn't matter, you don't have to, pro don't worry about the artificial intelligence, etc. And that's really something that once you get into industry, they will decide whether you will be putting in which role, etc. That's where I would like to say most of the recruitment is happening today with fundamental skill sets only. Yeah, sure.
So to answer to your question, as my previous speaker has told, definitely programming and analytical skills are going to be very important. There's no doubt on that. Another aspect is, students who would like to work in the area of AI need to have a lot of patience also. This is one area which is dependent heavily on availability of good quality data, and we quite often suffer. We have the algorithms, but we are not able to test because we don't have the data, proper training data. So, I mean, people quite often we find, they lose their patience in a project which lasts, say, for 3 or 4 years. Just because of want of data, they find that their work is not coming to a logical end. They find it very difficult, and they say, no, we would like to switch over to some other domain. I think your patience and perseverance matters a lot once you enter this domain. And another area is, see, your patience will also be important because ultimately it boils down to giving a good accuracy for any AI-based solution. And see, you may struggle and get 90% accuracy, but to bring it to 91 or 92 or 93, you will have to really, struggle very, very hard by working with various optimization techniques. So you should be very clear about all those technologies and techniques which will actually help you to tune your AI-based solutions. And that is where the difference comes between a person who is passionate about AI and a person who is just entering the domain for the hype of it. And that distinction should be very clear for students who are interested to work in this domain.
One example I just want to mention here. Last year, sometime back, we came with some of my colleagues. Like he's electrical engineering student. Okay, has background in electrical engineering, but he has excellent problem solving. Lab, and we set up. They have GPUs, and we set up a cluster. That electrical engineering guy has done a fantastic job of setting up the cluster. Whereas the computer science background guy with a MTech degree, he has not been able to, figure out Linux commands. And so, I mean, I found it so appalling. And a person with no able to solve the problems. Now he is usually intuition, So intuitive problem solving skills is very, very, and he is very well versed in how to make use of Google and ChatGPT. He will immediately go and find out on the mobile, he will find and then try to solve the problem. So problem solving is critical. You need not have to be a really pro at the particular area, but that intuitively problem solving is very, very important. I just want to emphasize that again.
Yeah. Sure. When we actually talk about recruiting students, maybe at master's level or undergrad level or even PhD level, I consciously do not use the word programming, Python programming. I call it Python skills. Because the thing is, I mean, all of us know very clearly that with the advent of Python, the tribe called programmers is dead. And who encouraged this, we don't know. So, for example, C to C++, if you see that Java and all those things, the advent of Visual C++ killed the programs to some extent compared to Borland C and C++. There you are asked to write each and every code very disciplined way. That is to some extent removed from the programmer side, from the Visual C++. It has become much worse when it comes to Python. Now, this open source phenomenon is a double-edged sword, in my opinion. While it gives a lot of plethora of opportunity for students and faculty members, but then a lot of unanswered questions are there. So I flag the problem and also give the solution. Problem is, I give two instances. When we started working with the CAN package, that is our package, there are about 77,000 packages. I'm talking about 2016 timeline. Now that has exploded to 35,000. So it's mind-boggling number, and any Tom, Dick, and Harry walking the street can write a code in Python and can just upload it. So, and in a gullible manner, they kind of download it and then start getting the solutions to you, and then you have to ask a question from where you picked up. People are clueless. Then I ask the next second question: who validated this? They are no answer at all. Then if nobody validated, it's not coming from a trusted third party, it is not open, it is not commercial, reliable or time tested, how the hell we can believe in this? You give some numbers, it gives some numbers output. How can you believe in this? Then just to support my argument, that we saw that in our package, that CRAN, 7 different packages were there for GLM, General Linear Model. And each one is giving different answer for the same data set. Then I said, this is the danger. Students are convinced. Then I started giving solutions. Solution is as follows. There are some dedicated journals, fortunately for us right now, Journal of Statistical Software from American Statistical Association. This publishes only software and code. And they do no testing. Reviewers' job is to test the code, test it in multiple scenarios. Once they're convinced, then only they publish it. So third-party evaluation is somebody else is doing, sitting in the USA. Then blindly you can take it. So such kind of filters you have to adopt. And fortunately for Python, again, we have JMLR and a kind of journal, Software X from Elsevier. Springer had a similar kind of offering. So these kind of journals, if you look at it, then definitely they are evaluating these codes, validating, and then putting it to the public domain or wherever it is. Such codes only we have to trust, otherwise trust becomes a very important issue. Talking about data sets, sir, again, that is another phenomenon. Fortunately, we have now IEEE data port. And Google has a separate database search engine. And as if that is not sufficient, we have got Kaggle. And grand old daddy UCML repository is already there, becoming bigger. So there is no dearth of data, in my opinion, in any domain. Only thing is you have to be vigilant. You have to keep your eyes and ears very wide open. Definitely we can get data. So these are, my viewpoints.
Military data is a problem.
That nobody discloses. We have to generate. That is where synthetic data comes, of GAN and other things you have to generate.
Hi. So on the first day of classes, I teach graduate courses. I tell my students, do you know that you are an endangered species? So that the first thing I tell them, do you want to be replaced by AI and robot? And if you don't want to be replaced by AI and robot, think what you need to do. So these students have to worry about, because they come with that, I want to be a good coder. Nobody needs a coder anymore. IDEs are there and they do a lot of things, and codes can be generated very easily. There are millions of Gits from which you can get the code. I tell them what you need to do is to think and analyze. Not learn just coding as your savior, because you are going to be I am going to retire in 5 years. You are going to be there for the next 40 years. You need to be more worried about it than I am. We also have an industrial advisory board for the CSE department and the College of Engineering. We do take their advice periodically as to what the industry needs. And we try to include that in our curriculum, whether it's a change in the now, the craze is about Python, right? It used to be something else. Today it's Python. Tomorrow, who knows what it is. But another thing I want to put out is regarding the industry and the skill set. I think we really need to understand that if you take 100% of the industry workers, only 10% need very high skill sets, not the rest of the 90%, right? Because only those 10% will end up in Google and Microsoft and IBM and other places. They need to be. I jokingly call the rest as IT secretarial jobs, not to put down anybody. So there are hundreds of millions of jobs taking care of the web, updating the web, uploading things. So a lot of students end up in those jobs, not at Google, not at Microsoft, doing ChatGPT. So there is a big divide in the skill set that is needed in the industry, because this has become a monster. Everybody has to maintain a website. Everybody has to have people behind this providing the support, labor support for that.
Okay. So now I request the audience.
One more example
Okay.
I have. If
maybe
you
in the interest of time.
less than half a minute.
Okay.
If you implement, the decision tree in scikit-learn, the same problem surfaces. Because if you look at glance through entire decision trees, starting from ID3, then going to CART, and then CHAID, etc. So you do recursive partitioning with respect to one dimension, and you will not come back to that dimension again. But scikit-learn implementation says that you come back to the same dimension again and again, do multiple recursive partitionings. That defies the logic of decision tree building. And they don't even tell in so many words why they are doing this. This is a problematic thing in scikit-learn's DT implementation.
Yeah. So I'll. So whoever has questions, just raise a hand.
Yeah, I mean,
you can
thank all the panelists for a beautiful discussion. I don't have any question per se, but I have a few comments. Let me take the last one. I also tell my students and employees, because I have one foot on industry, other foot on academics, I always tell them, don't focus on the tools, focus on the problem. Don't be a plumber, be an engineer. I'm not at all, discrediting anybody, but that's one of the things I would like to tell anybody, that if you're a Python program today, after 2 years, you become a good programmer. 4 years, very good programmer. Then very, very good programmer. After that, you don't have your job. But if you know how to write an algorithm, it doesn't matter whether it is C, Python, or anything, you will have your job. Number one. Number two is that, this is in continuation to Professor Sharma, is that people talk about hallucination in many of those LLMs and other things. The point is that if you ask a right question, there is no guarantee you will have a right answer. However, if you ask a wrong question, answer will always be wrong. Doesn't matter whether it is ChatGPT or your professor or anybody. My last comment is about big data and AI. In big data, in my understanding, I would like to say there is an underlying understanding of the data, primarily the statistics or the distribution. That's why it works on large data, small data, and you have the explainability. Whereas in AI, if it is one of those neural networks, you need to give tons of data to make sure that the randomized property is there. Otherwise, there will be a bias. So it is more onto the data and the quality of the data, whereas in big data, it is primarily the statistics and the distribution of the data. Thank you.
I have multiple mics, I realize.
I beg to differ with that view of when you talk about big data, you got statistics and probability distributions. The very fact that you are dealing with voluminous data and a variety and velocity of data, people have done away with computing the age-old paradigm of taking a sample from population and then computing the sample statistics and then extrapolating them to population, and the entire dictum has gone away without anybody's notice. Even if you look at the industry standards like SAP HANA, they said entire data warehouse can be kept in the RAM. So when I have the capacity and wherewithal to keep even terabytes of data into the RAM, why do I care about sampling and then about probability distributions? These are kind of disruptive technology all of us have to take with a pinch of salt. So statistics has some meaning to a certain extent, but when you talk in the regime of big data with respect to volume, at least, the statistical measures do not play any sense.
This is one question for the faculty. In terms of curricula, how are we making changes? Changes you are making.
You're doing the inverse
Number two is that as I'm seeing people problems have problem solving. It doesn't matter. The program I'm talking. Give them a problem. Do you have any such then it is have any such thing? I request.
So that's very nice that there are some questions asked here. So instead of me answering it, we have, I'll give it. We have one more member here, Professor Somayajulu, who could not make it on time for the panel. So I'll ask him to answer these questions.
Okay, good. See, in fact, see, a lot of changes are happening even in the curriculum and pedagogical approaches in teaching learning. As one of the panelists mentioned, do you have any course on problem solving skills? Yes, every undergraduate student and every student will study one programming course compulsorily, highlighting more on programming skills, not highlighting more on problem solving skills rather than programming. As Talukdar mentioned, different people, once they get an algorithmic approach, anybody student can do the program, whatever the language evolve. This is my experience as far as this teaching learning is concerned, because I also worked in NIT Warangal for more than 30 years. But of course, right now, I'm not in the teaching, I'm in administration. Now I'm director at NIT Manipur. Prior to that, I served as director at AADM Karnool. So I have seen a lot of changes in the curriculum. And in my opinion, AI and big data integration definitely will change in access to knowledge, data-driven policies in the administration, also personalized experience for learners. So, but it takes time. As one of the panelists mentioned, data is not available. In fact, changing the mindset of the faculty and learners is also important. Then automation of all the systems in the education sectors is important. Once you do that, maybe different learning styles for based on the interest of the student, different learning styles can be evolved using these AI and big data. That's what I feel. But of course, challenges are there. Privacy issues is a big challenge. But many researchers are doing good work in this domain. But I also organized this big data conference in 2 times, one at Hyderabad and one at Warangal. And Professor Sharmaji has also visited once, I remember correctly. I think he gave a tutorial also. I am a student of Professor S.K. Gupta. So it's good that University of Hyderabad has organized this wonderful conference. Even though the only interested audience, normally they come for big data analytics conference. That's what I noticed right from the beginning of the conference. Instead of pumping 300, 400 participants without any interest, interested people attending the conference is the success of this big data conference. Thank you, Vananda.
That day also, I also exactly felt like, okay, say for example, my daughters are there. If I have to teach her mathematics, I will not give her the calculator to basically say like what is 6 times 9. I will not teach her. I will basically make her learn the mathematics, learn the table, step by step, be ready for it. Eventually there will be a age when her maturity is at a level when she can actually use it. There is a process and procedure for it. You actually learn it and use it. I think we are getting carried away with all these latest technologies. Yeah. Okay. And then like if we fall prey for this stuff, eventually like complete community will suffer. Okay.
I think. Yeah. So actually, one of the panelists commented that. Yeah.
I think. No, wait. I think there is one other person who wants to make a comment. No, I think there's one other person.
Yeah. So one of the panelists mentioned that data science is good for decision support. For example, if you want to know how to repair a car, LLM is better. I think means that we are liking the search. If LLM provides the search equivalent answers, we are liking it. But prediction, we don't like it actually. It tries to predict it, we don't trust actually. So how to divide the border actually? So LLM, certain kind of answers we are liking, and certain kind of answers we are doubting actually. So who should be?
Guidance. I mean, people are misconception is that they use ChatGPT for everything. ChatGPT only give a guidance. That's it. And people should understand that. They don't.
No, guidance.
They are not universal problems.
Guidance.
They give wrong answers also. Please.
No.
Exactly. It's only a retrieval system. It's just retrieval, and then it tries to come up with some kind of inference based on the data it has.
No. So I know. What ChatGPT does. What I'm saying is that.
One more thing here. If you talk about ChatGPT, plagiarism is a very important issue. I do not know how many of you actually read this news item. Taylor & Francis, a famous publishing house, has sold its archival journal entire database to OpenAI for $26 billion. So most likely all of our publications are plagiarized many times without our knowledge. So all these are ethical questions which nobody wants to answer. I don't know how people are actually happy with all this phenomenon.
No, I think, if LLM says that it is guidance, it's only for the liability issue. Actually, it is supposed to give you answers. So you ask a question, any answer, you say, I'm in Hyderabad, I have 2 days in Hyderabad, give me the list of sightseeing in the order, it will give you a complete itinerary. Okay, it is not, so the question is, when will it give you the correct answer for what kind of questions? Will it give you a good answer, and what kind of questions? It may not give you a good answer, nobody knows yet, because nobody has experimented with thousands and millions of questions. So as the time goes by, we've already seen some horror cases, right? ChatGPT suggested somebody to kill somebody. So we have seen that. So these things are happening. So nobody can explain why this is happening, based upon what this is happening. I think this is one of the things that is going to come back and haunt and refine this system in the years to come, in my opinion.
Okay. I would like to thank the panel members for very lively comments, opinions, and their perspectives on this topic. And in the interest of time, let's stop it at this point and proceed to the next things. Otherwise, I don't know if ChatGPT can make good tea or give you anything like that. So we'll put a stop to the panel discussion. I thank the panel members for their very nice initiation of discussions, and also I know that the audience can ask them questions and interact with them outside if there is time for that. I don't know if there is time for that. There is one more session after this one, but then that's what. So I will leave it now to Satish to take over and continue the conference. Yes.
Okay, all of that, both of us. At the end, like as a moderator, like or shall we start with you first? No, let us start with them.
Yeah. Thank you. Thank you. It was very nice. Yeah.
Thank you, sir.
Thank you.
Very interesting.
Thank you very much. It is very nice to. Okay.
You open and you give the data. You say like we are missing data.
Thank you.
Thank you.
As usual, you are very nice, exciting.
Thank you.
Oh, some action replay. We'll go that side, maybe. Okay. Oh. Yeah. Okay. Thank you. Soumya, please. Please. Come, come. Oh, yeah, another. Yeah, I'm very happy that you are able to make it. So thank you. Okay, thank you very much. Okay, thank you very much for your active participation in the session. Let's have a 15 minutes.
We keep check out items, check in items inside the class that is item, and we can keep the display catalog or sort catalog inside the catalog classes. So by doing this, we can remove the code smell. So as we can see that there, if we use the programming practice like shown in figure A, so there is a no error. So during the compilation, we cannot get the error. And similarly in the B, there is a no error, but this is the good practice to keep the relative method inside the same class and trying to make sort the particular class. So this is our motivation is the detection of the software code smell is very crucial, because due to the code smells, software may become faulty in the future. And main issue is during the detection of software code smell is how can we represent the particular source code in form of the numerical, so machine learning or deep learning methods can learn more properly about the software code smell. So this is the main motivation. Many of researchers have employed various ML or deep learning techniques. For the ML techniques, they use the code metrics to represent the software code smell. In the code metric, they use like how many number of lines are there, what is the complexity of the software code smell, how many methods are inside that particular class, total number of parameters are there, total number of formal parameters are there inside the methods or not. So these are the basic code metrics that previous authors used to represent that particular code in a tabular form. Some of the authors use deep learning techniques to convert the complete source code directly in form of the numerical form by using the embedding techniques. So in that they use the various deep learning techniques like CNN or RNN to learn the context of the code to generate the embeddings. So our objective is to evaluate various source code embedding techniques and ML techniques for effectively code smell detection, which gives our future guidance. So this is our proposed methodology where we use the data set produced by the Medowski et al. And this is the simple collection of the source code, and after the gathering the data set, we use the different embedding techniques like QBERT, CodeBERT, and code-to-back techniques, which convert the source code in form of the embedding techniques. And after getting the embedding or vector, we use these vectors to train the ML models, and after that we get the classifications. So we here in this methodology we use three code embedding techniques: CodeBERT, QBERT, and Code2Bag. So basically, CodeBERT learn the structure of the code by including the programming language and natural language. It includes the description of the code. If programmer write any comments inside the code, so then it segregates the comments of the code, and based on that it generates the embedding. However, QBERT did not segregate the comments of the code. It includes that code inside during the processing of code, during the processing of source code, and during that it tokenized the whole source code by considering, okay, this is the textual data, and based on that it generates the embedding. Both CodeBERT and QBERT use the BERT embedding techniques, which learn the context of the previous context of the word, and based on that generate the embedding. The Code2Bag is something different from that. Basically, Code2Bag use the deep learning model where it used the AST tree to represent the particular source code, and by calculating the paths between the leaf node, it converts the AST tree in form of the textual form, and then these paths produce inside the CNN models, and then Code2Bag generates the embedding with respect to that. It generates the 384 dimensional embedding vectors with respect to each source code. So we use the 4 data sets produced by the Medowski, and each data set represents the specific type of code smell, like data class, God class, feature env, and log method. In previous slide we see the example of the God class. So the experiment, the first experiment basically dedicated to see what is the performance of these techniques with respect to the each ML technique, and we can see that with respect to the all 4 data set, the NB or and RF classifier produce the more improved result as compared to the other for the CodeBERT embedding. Similarly, if we talk about the QBERT embedding, then for the QBERT we did not get the specific type of ML techniques for all the data set. We get the techniques for each data set differently. So for data set 1 we get the LR, for data set 2 we get DT, and then NV, and in the last for data set 4 we get the random forest, which produce the more improved F1 score with respect to the data sets. And after that we use the Code2Bag embedding techniques. So for the Code2Bag embedding techniques, random forest is the most improving ML technique, which are able to detect the code, able to detect the smelly and non-smelly items in a software code smell. So based on the observation, we can say that Code2Bag is one of the emerging techniques which produce the more improved result with respect to the RF classifier for dataset 1, 3, and 4. CodeBERT also produced the more improved result with respect to random forest for dataset 2, 3, and 4. In the experiment 2, we compare all 3 algorithms with their most improving ML techniques. And in that we can see that for 3 data sets, Code2Bag produced the more improved result. However, for data set 4, there is a CodeBERT techniques which produce the more improved result as compared to the others. So based on these observations, we can say that Code2Bag is a latest technique, and it has produced the more improved result as compared to the others. However, Code2BERT produced the more improved result only for the dataset 4 only. However, Code2Bag produced for the dataset 1, 2, and 3 as more improved result. So based on that, we can conclude that the whole experiments are tested on the MLSQ dataset that is produced by the Medowski, and the Code2Bag achieved the highest F1 score between the 0.69 to 0.72. And the CodeBERT outperformed the Code2Bag for the 4th data set, that is 0.774 for F1 score. So these are the differences. Thank you.
Hello. There are few queries related to the content, like code smell detection. Correct. This is the statement of the problem. What is the motivation of this particular problem which you selected?
Actually, code smell basically can cause the software failure in the future. Because of that, the maintenance of the software and the readability of software become more complex. So if we detect the code smell during the development of software, then it become more easily to maintain or readable in future.
So it's a part of a software development
Yes, sir. It is the part of
phase
software.
where the code what it is means written by the particular source code writer, it is to be documented properly. So it is talking about document evaluation. Correct?
Yes, sir.
So in this case, like you would like to evaluate whether this code is valid or invalid. Correct. And
Yes.
you would like to classify using by various type of algorithms. So in this regard, so these are all pre-trained trained models. Correct. So any sort of the model which you observed performing better and why? Like your conclusion is that finally you stated that CodeBird
Code
is
Code
perform
to
better.
back, yes, sir. Code to back performing better.
So how and why?
Actually, code to back include the AST AST tree representation concept, where for the basic idea is if the embedding techniques represent specific code as uniquely, then ML models can learn more about the more accurate about the code smell or non-code smell data. So code to back basically use the AST tree, which uniquely generate for each source code. So there is no ambiguity between two AST tree if the code smell or non-code smells are very near when we represent on the graph. So if both items are very near to each other, then there is also a code to back is a technique that can generate embedding very uniquely for both types of code data.
Practically for this type of classifier, input is a string.
Yes,
string is a source code.
Yes.
Correct. And what is the logic behind that? How it does the validation of the code or detection of the code to say that it is of type category that is of maybe having any errors or bugs?
Yes, sir. There is actually a code to back and CodeBird and QBird basically used to summarize the code, but we change their application and include in detecting code smells, and we see that the CodeBird and QBird basically treat the code as a textual data, so it cannot learn proper structure of the code, or there is a loop or there is a if-else statements. But code to back basically use the AST tree representation. So in that it can learn the inside the structure of the code, or there is a if-else or loops. That's why code to back produce the more improved result.
Any sort of the parsing technique or any sort of the NLP approaches are used by these?
Inside the code to back or inside or QBird.
What type method they are using? How they can able to classify?
BERT. They use the BERT technique to generate the embedding with respect to code. But in code to back, there is no use of BERT. They simply use the CNN model and their own CNN model to train, and based on that generate the embedding.
So to analyze the performance of pre-trained model, okay, you took a 4 set of data set, different databases. Okay.
Actually, publicly there are only 4 data sets available in a source form, and which are provided by Medowski. So we have only that 4 data sets. So we use only that 4.
Thank you. Any questions from audience? You please welcome. If you have any queries, you can ask.
Thank you. Next presentator, paper ID 66.
Good evening, everyone. My name is Binu John. Today I am presenting a paper based on federated learning, and the title is FedNorm, Optimized Federated Learning Strategy Using Hybrid Regularization Norm. So these are the contents through which I will be taking you. So what is federated learning? So the concept of federated learning comes in the scenario where you will be using your local data without sharing it to a global model, means a decentralized machine learning training. So it is actually a decentralized machine learning approach which help you to preserve the privacy of your local data. So how it works is the local training is done in your device, and the model updates is sent back to the global server periodically, and the global server will be taking an average of those updates, and it will be updating the global model, and this global model will be sent back to the local devices. And this training goes on until a convergence occurs. So what are the different challenges in federated learning? One is the non-ID nature of data, that is data is not independent or identical. And another drawback is that there is a communication overhead, that is if you are sending the whole data set to the global server, it will take much of your bandwidth. And another thing is a model drift. A model drift occurs when your local data or the updates that you provide to the global model, there is a it deviates from the global objective. And there are a lot of existing methods that are used to solve these issues. One is federated averaging, in which you will be taking an average of the updates given by the local models by the global server. And another one is Fed stochastic gradient descent algorithm, that is that uses instead of model parameters, they send the gradients. Instead of parameters, they will be sending gradients to the global server. And there is FedNova, in which instead of taking an average, there will be normalizing the model updates, and then it will be updated in the global model. So the algorithm that I am proposing is FedNorm, which help you to enhance the accuracy, stability, and generalization across heterogeneous data distributions. So these are some of the related works. So the first one is one of the classic algorithms, that is federated averaging, and it is the simplest global model aggregation. That is, they just take a simple average of the model updates given by the local devices. And a limitation is that it doesn't it fails when it comes across the non-IID data, and there are privacy issues, and real world scalability is not addressed in federated averaging. And another one is robust communication efficient federated learning from non-IID data. So the objective that is being addressed in this paper is that they have tried to improve the stability of federated learning on non-IID data by adapting model aggregation strategies. But the challenge that has been pointed in this paper is that they have increased computational complexity and limited scalability and lack of real-world testing and privacy issues. Another related work that is being studied by me was federated optimization in heterogeneous networks. And the objective met in this paper is they have tackled this model heterogeneity by adding the proximal term, proximal function to the loss function. And the challenges or the drawbacks of this paper is that they have reliance on parameter tuning, that is hyperparametric tuning, help them to achieve the accuracy. And there is, they haven't tested much on the real world scenarios, and there is robustness, lack of robustness on adversarial attacks and absence of personalization. Another work is, it is based on the convergence issue, and they have used this stochastic aggregation, and the challenges here were it is not being correctly tested on non-IID data, and scalability, computational demands, privacy, everything is lacking in this algorithm. And the next paper they have the objective they have met is they have tried to handle the time series forecasting by using a bias aware parameter weighting, and the drawback of the paper is they have struggled to adapt to non-stationary and highly dynamic time series data, and the scalability issue and communication overhead is also present. And another paper is regarding the reduction. They have tried to reduce the communication overhead that happens in the federated learning by using the top K compression with voting. And the main issue found in this paper is that they have scalability issue because the managing of this voting processes across the different local devices is not manageable, and also the communication overhead is another issue. So the problem addressed in this FETNOM is one is data heterogeneity, that is across the different non-IID scenario, which causes this model drift. Model drift is the deviation between the local updates and the global objective, and slow convergence. And the second one is hyperparameter tuning, that is try to optimize the learning rates, batch sizes and regularization term in order to achieve this accuracy. And in order to improve the efficiency, the latency, communication overhead and training time has been reduced. So the main contribution of this paper is I have added a hybrid regularization term, that is L1 and L2 taken together, which helps to reduce the overfitting, general overfitting of the model, and to also help you to select only the primary features that contribute to the achieving the major labels. And it has enhanced the model generalization using the personalized updates, because each local device is training their model and the update is being sent to the global server. And also comparison is done against the different existing classic federated learning algorithms. So this is the algorithm, and here I have added a regularization term, that is the sum of L1 and L2 is being added to the loss function, and this loss function, using this revised loss function, I have updated the model parameters, and this model parameter is sent back to the global server, and at the server side you will be calculating the average of the model updates obtained, and the global model is being trained and updates are sent back to the local clients. So the key idea is that the hybrid regularization, why combining L1 and L2 is that L1 will help you to enhance the sparsity of the model, and L2 help you to avoid the overfitting of the model to the local updates. And it also help you to reduce the model drift and overfitting, and help you to balance between the local and global model objectives. And the experimental setup that I have used is, I have trained the model using the MNIST dataset, which contain around 60,000 training samples of handwritten digits, and it contains 60K training sets and 10K testing samples. And I had used 2 hidden layers for the IID scenario and 3 hidden layers for non-IID scenario. And the parameters, learning parameters have been tuned, hyperparameters have been tuned in order to achieve the accuracy. So these were the results obtained on IID scenario. So in the first graph, it is on test accuracy. So it shows that FETNOM has achieved an accuracy, means it is converging within a round of 20, it is converging to an accuracy of 0.98, that is 98%. And regarding the test loss, that is the second graph, the test loss in the case of FETNOM is very low when compared with the other existing classic FL algorithms. And in graph 3, you have, we discussed about the training time. It shows that the training time of FETNOM is slightly above when compared with FETNOVA and FET-SDD. And the last graph is regarding the latency. So the latency of FETNOM is very low compared to all the existing FL algorithms. So this shows the communication overhead and the accuracy when train the data with 10 number of clients, 15 clients and 20 clients. Across all these scenarios, FETNOM shows an accuracy of 98%. So to summarize the results on IID data, FETNOM achieves a higher accuracy, that is 98% by a round of 20, and it has a minimal test loss compared to other algorithms, and also latency and communication overhead with Fed average. And it is also having a moderate training time. So this is the results on non-IID data, and it shows a similar scenario when compared with the IID. The test accuracy is 98%. Test loss is also less for FETNOM. Training time is higher for FETNOM when compared with FED SGD. And latency is also higher for, lower for FETNOM when compared with all the classic FL algorithms. And for non-IID scenario also, I've compared for 10 clients, 15 clients and 20 clients, and in all these scenarios, FETNOM is maintaining an accuracy of 98%. So to summarize the results on non-IID data, FETNOM, it maintains a consistent accuracy compared to others, and it is having the lowest test loss and stable performance, efficient communication overhead and scalability. So to conclude, FETNOM, it excels in handling non-IID data, which all other classic algorithms fail to achieve in a non-IID scenario. It ensures high accuracy and low loss, and it also balances the training time and communication efficiency. And in future, we are planning to extend the scalability to complex FL contexts, and also to explore the results when dynamic regularization is being considered. So these are my references.
Any questions? Hello, any questions from audience? How this is different from FedProx? That is also works on non-IID and heterogeneous kind of setup.
In FedProx, they are adding a proximal term, but in FETNOM, we are adding a hybrid regularization term. That is, sum of L1 and L2 is being added to the loss function in order to penalize the loss function.
So this L1, L2 regularization that you are using, this is while training.
Yeah.
Not on the server aggregation. So
no, at the client side.
The client side while training.
Yes.
So I was thinking, so you are not doing on the server side, right? So server side
I am just taking, yes.
Standard,
averaging, yeah.
So while training, you are training with regularization. That's what you are saying.
Any other questions?
No, regarding the scalability, what are the way you are handling the scalability of issues here? Scalability, that is a very important concern.
Means scalability, we are planning for the future works. Right now, we are concentrating on accuracy. We have increased the accuracy using this regularization term.
Okay. So other than that, like you have introduced the loss functions at L1 and L2, correct?
Yes, sir.
And that is simply like a normalization approach.
Yes, sir.
What is the motivation to showcase that with average and other parameters also?
Sir, when we are handling the non-IID data, there is a model drift happening when we update the global model using the local updates. So this using the L1 and L2 terms, we can L1 will help you to select only main features of the data set, and L2 will help you to smoothness or to reduce the overfitting. So that's why we have taken.
Are you able to handle the overfitting also?
Yes, sir.
That was not shown in the like a graph about the performance in case of reducing the overfitting?
No, we have done the graph on accuracy loss, but not on overfitting, sir.
That's why my question was that only concern.
Okay. Sir, I will try to include.
Because without showcasing these factors, it's not able to accept the other results.
Okay.
So that is a primary concern. So other than that, like enhancing accuracy, anyway you covered. So these factors to be covered and given more stress.
Okay, sir.
And reducing the latency.
Yes, sir.
While deciding the evaluation of latency, which are the parameters you considered? Or like what is the scenario?
The parameter size, the parameter that is being sent back, the size of the parameter, its updates that is being sent back to the model, to the global server.
Okay, but that
and also the training time.
And that should be brought into the content also, showcasing the complete architecture scenario, what it is assumed to evaluate the latency factors.
Okay, sir.
Then that becomes clear.
Okay.
Thank you. Any other queries?
Pardon? Communication? Sir, we have the model updates that is being given back means it is a simulation result, not an actual result. So I have considered the size of the model updates that is being given back. Sir?
Whether you have used horizontal federated learning or vertical federated learning for training the data?
Vertical federated learning.
Vertical.
Any other questions? Okay, thank you.
Thank you, sir.
Next. Participant paper ID 90. Ash Kumar.
Close to you. Here? Okay, no? Hello? Yeah. Hello everyone, very good evening to all of you. So here I am presenting my paper, Efficient Self-Supervised Contextual Learning with Representation Mixing. So here we are going through this outline, self-supervised learning and what is the contextual learning, and after that we will discuss our model and mix, and then results on the downstream task, and then after that a conclusion. So apart from all that, where we got this kind of motivation that why we need a separate learning from supervised learning, semi-supervised learning, weekly supervised learning, many kind of learning we have, still we need a different kind of learning. So what was the requirement actually? So as all we know that deep convolution neural network based on large set of the data, and however we have the imaginary data, Facebook data, there are millions and billions of images, and for the annotation purpose it takes too much time. So what happens, these kind of problems arises which are very common while preparing a manual annotated data. Suppose if we have a 1 million images and we have to annotate that, it takes too much time, and after that suppose if we have to consider other tasks like localization and object detection, it will become bigger. And if we consider the real time data what we have on the online like Facebook and other online like Instagram, so these are all image data sets. If we consider those real time data, we will have much more bigger problem, because these are the real time data, they have the variations. So what are the actual problem in that problem of the rare concept? That means we don't have the equal data for each type of category. Suppose for one category we have millions of images, for one category we have less number of images. So how can we segregate? For the classification problem, still it is a big problem, because supervised learning can be easily biased to the large number of images. And the second problem is that problem of different domain. That means, suppose if we are training on imaginary data and passing my representation to different domain like medical image analysis, definitely that it will fail, because the complete different domain cannot be transferred the all knowledge from one type of data to another data. So this kind of problem was there, and that's why we need a different kind of approach which can fulfill this kind of requirement. So what we have, supervised learning, as we all know that for the each image we have a label, and we are minimizing the loss function with respect to that label. But in the self-supervised learning we have millions of images, and what we are doing, we are just preparing one intrinsic signal or the pseudo labels which can feed easily and prepare a complete representation for our data set. So this solution is known as the self-supervised learning, which completely based on the unsupervised data, where does not require any labels. And so how it is different from the unsupervised learning? So it is a two-way learning process. That means first you have to prepare a pretext task. Based on that, you are preparing your representation for your data, whether it is image data or other kind of data, and you are preparing that representation and then passing this representation to your downstream task. Downstream task can be a different downstream task we have. So first we will discuss about the pretext task. What is a pretext task? That means a person is manually finding a problem and suggesting a solution. Suppose a contrast learning. So what we have, that we are just assuming that we must have the positive at one side and negative on the other side. This is a completely simple segregation problem. So this is one kind of pretext task. Jigsaw problem and the colorization problem, these are the pretext tasks. Some of the model in this self-supervised model also based on the pseudo labels, that are creating the pseudo labels. That is deep clustering. So we have different kind of variation of pretext task in this self-supervised manner. So these are the downstream tasks: semantic segmentation, object detection, image classification, human activity recognition. Before consideration the self-supervised learning, what we have to do, for the specific task we have to train a model and we have to get the representation for that. Okay, but the self-supervised learning aim to get the representation for all kind of downstream tasks. We don't have to train again and again for our model for each and every downstream task separately. So here we will discuss about the contrastive learning. As I have said, that contrastive learning aims to segregate the positives out from the negatives. That means the representation of in the latent space, if we have the similar images that come closer to each other, and the negatives that will go far from each other. This is known as the contrastive learning approach. So what is our approach suggested? There is the key idea behind it, that I observed that there are many representations which are far from each other, and they are not playing any crucial role by making the decision. So what we have to do? So I got one anchor image and one a counterpart image, and I mixed those representations to prepare a common representation which has the positives as well as the negative representation. And one of those presentation I am just considering as positive, and apart from all of the pairs I am considering as negatives. That means on representation mixing, I am just putting the contrastive learning. That's the only idea I have. So intuitively, we want to increase the similarity between the sum of all positive pairs and decrease the all negative pairs. That is our goal. So as we have to minimize the minus log PS by NS. So this is the framework what we have. We are considering an anchor image. For an anchor image, I am just considering a counterpart image, passing into the augmentation. I am just getting the augmentation, one augmented view and the one normalized view with the respective of the image. And after that, getting passed to the encoder. Encoder can be any ResNet network, I'm just using ResNet 20, 32, and 18 and 50. These are the various architecture we have, we can use. And right now people are using VITs also as encoder. Okay. So projection head is a 2-layer MLP I have used. And after that, the aggregation unit, which are actually mixing the representation of one augmented image of an anchor plus the normalized image of an counterpart. So that will mix and come closer the representation with respect to the far representation what we have earlier. So after that, I'm just feeding these two representations into the contrastive learning. So what is the representation mixing? That means our aim is to get bigger and bigger gap between the positive mean and the negative mean. So this is the proof that representation mixing increases the score gap. That means the SimCLR what we have earlier, the model state of the art model, one of the popular model in this field, and we can say that cosine similarity of the positive pair and the negative pair are there, and what we are getting, that is continuously getting the good gap between maintaining the good gap between the cosine similarity between the positive pair and negative pairs. So for the training methodology, I have used the augmentations, color jitter, random grayscale, random resized crop, random horizontal flop, and Gaussian blur. These are the all same augmentation I have used as given by the SimCLR. And encoder, I have used 4 encoders, ResNet 20, 32 for the small architecture, ResNet 18 and 50 for the large architecture. For the projection head, I chose the 128 the projection dimension and the feature size multiplied by 4 the hidden dimension for the 2-layer MLP. I am also using additionally here one ReLU layer. Here I have used the leaky ReLU and one batch normalization layer. So actually this is the loss function of what we have, the minimizing our log function with respect to the similarity between the positive pairs and the negative pairs. So similarity between the mixed representation Z with respect to Zi1, and apart from that the all negatives what we have in a row. So this is the whole algorithm in one view. So we are getting the AG is here the augmented view, AN is the normalized view, passing from the encoder FNAT and passing from the projection head and getting the representation. After that the for loop ends. After that we are mixing the representation and feeding it to the contrastive learning. That means the minimizing the loss between the positive and negative pair. That's it. So here are the results we have on the CFAR10 small data sets. That is consistently we are improving, and with the number of effects, this is a top one test accuracy. Still on the various data sets we have done an experiment, still on tiny ImageNet data set I am not getting that much results. This is still I have to find out, because for the small architecture it is not improving that much. And this is the results for the ResNet 50 on the for our model. I have run for 200 epochs, and with the 200 epochs it is giving 63.40, which is 200 epochs. It is quite better in the comparison of other models what we have. And the ImageNet result with the ResNet 18 on 100 and 200 epochs we have already, we can see we are still improving. And this is the domain transfer result. Sometimes I'm getting good results. For the ResNet 18 is consistently good result, but for the small ResNet we are not getting that much good result, but still it is working. So what is the conclusion and future scope? That still we have to study that what kind of further representation can we lead to consistently grow that, maximizing the gap between the positive and negative, because sometimes it is happening that it is going down and up. So it may happen, it may cause the variation in the result. So we have to balance that, and later we have to explore the other kind of feature mixing method, and that can work on downstream task efficiently. Thank you. These are the references.
Any questions from the audience?
Yes, actually, instead, while decreasing the negative pairs, for example, if we ignore completely, then what happens?
Ma'am, it may lead to overfitting, because there are some models, I'm telling you, there is Swab, Bevel, these kind of models are doing SimSam. Recently, state of the art model SimSam, those are non-contrastive methods. They are using the image as positives apart from the negatives. But carefully we have to do the training, because it may cause the overfitting. It is really headache sometimes. I did.
And the second question is, in the self-supervised learning, suppose if you are relying on unsupervised data and due to the pretext or you are pseudo-labeling it, maybe there will be a chance of encountering some erroneous labels. So what is your stand in this case?
Ma'am, it may happen. It may happen, but that's why pretext tasks we have to choose carefully. Carefully designed pretext tasks cannot lead that much.
Okay. So in one of your results, maybe in the 17th reference, there are no slide numbers, that is very difficult.
Yes,
Yeah. Wait. Come to the next slide. Here, if we see one of the approach like MOCO is not capturing for epochs 100 and 200. What does that mean?
MOCO actually, ma'am, experiment, so that's why I didn't cap the result there. I was up to, but it was taking some time, that's why.
I think it's a suggestion that if you have not performed any experimentations, please, okay. Thank you.
Any other questions?
My query is with regards to your data set. How is your data set? Is it very similar, or how have you picked it? Or is it that you didn't do any study on that? When you presented, you've shown a monkey with the tiger.
Yeah, that.
So have you checked these results with images that are, very similar? Because contrastive learning is something to do with images that are too similar, and then you are still able to, make out which one is which.
Yes, ma'am. You are right. Contrastive learning is working in that way only. Yeah, ma'am. I studied, and that's why I choose these data sets, and I'm just actually contrastive learning I am also using, so by default it will do, because I'm just doing the representation mixing. Before the contrastive learning, I'm just doing the representation mixing. So it was not the new loss function, it was a contrastive learning only. So it will do the same, whatever you are saying, because the positives come closer, the same looking, the two objects will come closer. Like these two monkeys image in the latent space, that will come closer automatically. My point is that I'm just getting the closer representation by mixing. Just because if I'm mixing the monkey and the tiger, and one monkey and with another monkey, as we all know that both representation will come closer in the latent space if we are mixing positive with the negative also. So those who are making the, if we are considering the hyperplane and giving the points near the hyperplane, it is really hard to learn. So that's my target, to give the challenging to segregate through these kind of images. That's why I'm just mixing the negatives with the positives.
So regarding contrastive learning, the very important factor I think depend on the augmentation factors of image.
Yes, sir.
So if you go to that particular slide of augmentation factors of image, so the image what you have selected with a particular range of the contrast, range of the random grayscale value, jitter value, these plays a very important factors.
Yes, sir.
To give the similarity. And in that case, you used a similarity estimation parameter, I think cosine sine similarity parameter. Okay. So how it differs from the content similarity retrieval? You know about content based similarity images retrieval approach. That is called CSI-BR, where conventional approaches are only simple matching based on the statistics. Only now you are introduced the concept of determining the like a similarity based on the contrast level, okay, of an image. So in this regard, like we may not able to get the same, but the contrast of the image may be same. Other factors of a contrast may be like if you go for the like noise, suppose the noise level of image is high, but even though contrast is very much similar, so then also the similarity exists into picture. So how it can be resolved?
That means if we have some images which have the noises,
yes,
and still we are mixing, sir, that experiment I have done. It is a good point, sir. So we can explain, we can explore this possibility also. I haven't done that experiment.
Because the main objective,
it might be possible, sir.
Because the concern is the contrast of the image and projection of image to the particular 2D plane and getting the contrast factor estimation and mapping it with synonymous data set of values. That you can do with matrices also, simple mapping also. But that point you can take into account about adding a noise and coming up with the approach also.
Yes, sir, adding a noise?
Other one way other approach is you can able to do image generation approach, like in a reverse approach. Correct. Can you able to generate the pixels of image which can able to synonymous having a contrast values and can able to match it. So those are other factors which you can able to think.
Yes, sir. Yes, sir. These are the two different dimensions I have to think about it. And sir, second is the kind of GAN approach we have to
GAN approach, correct.
GAN approach. So generate the images and then do the same thing.
Yeah, because you may be not having a huge data set available for training and testing. Even you can, wherever the image set is not of having a limited size.
Yes, sir.
Imagine
it huge data set, sir.
Okay. Thank you.
Thank you.
Thank you, Bala.
Next participant, paper ID 120.
Good evening, everyone. Firstly, I wanted to thank the University of Hyderabad to giving this opportunity, and I wanna apologize for my other authors. They are not able to make it happen today because of some official commitments. And coming to my presentation, it is about smart e-learning development tool using generative AI and the RAG approach, using a prompt engineering. And the coming to agenda is problem statement, literacy survey, and other things. And coming to the problem statements, so basically, I want to develop a tool using both LLM and combining with a RAG, using a prompt engineering, in order to bring some develop an e-learning course to design and develop a tool. And what the objective we took here is to assess the course objective using the prompt engineering and the outcomes of the technical document, whichever we inference the model, and some assessment questions, and for a chatbot for out of the scope questions if anything comes into the picture. And the goal we receive from this scope of the project is that with the LLM we get the understanding of that domain specific knowledge, and while integrating with the RAG we can have the various external knowledge. So with the various external knowledge and the LLM understanding, we can make use this both knowledge and understanding. We can get a relevant response using the prompt engineering queries. And coming to literacy survey, initially we do have some tutors, cognitive tutors. Then the ML models came into the picture. We used to pre-train the models. Then again some neural networks came into picture, sequence to sequence learnings, and the multimedia learnings came into picture. Now the RAG came into picture, and the use of this RAG is in ML based models and LLM based. We used to pre-train the models every time with the updated data, but whereas with RAG, we don't need that pre-train again and again. It has some external sources knowledge, so it can, whenever we raise a query with an outbox question, so it goes to some external sources and fetches, and using this core function, it just give the response in a relevance response. Yeah. And coming to these are like various another literature service which came into the picture after the RAG. And the proposed method which I designed is, so basically I took a Mistral model which is 8 cross 22 billion, which is very hard to get in an open source, but not right now. And so basically I'm using an inference model, and I'm giving the a semi-structured data set, and I'm integrating this with the RAG model with the parameters as 2, scoring function as 2, and then I'm using different type of prompt queries. I'm designing the learning goals of that particular data set or questionnaires, outcomes, all of that, and a chatbot for an out-of-scope questions. So, for example, I submitted an document on this paper or any other paper on for an example on let's take a subject on OS. So in that OS, I do have all the old listed algorithms or other examples. But if we want to retrieve the current using algorithms which are using by industries right now, which are not present in that document, in that case, RAG will come into the picture. So for that reason, I place the chatbot which will make use of the RAG. And the best part here is we are not giving an option to give the response by everyone. Not everyone can give the response of the submit the feedback for the response by this model. Only the subject matter experts can get the feedback on the response which are developed. So what happened when the subject matter give the feedback on this? So the feedback used to fine tune the model again, or it can regenerate the response by using the feedback of the subject matter expert. And yes. And in this way, this model, we can call it as a AI RAG reinforcement model as well. And the challenges which we faced is we tested this model using various repeatable databases, and we checked the diversity of the data sets, whether it's giving the same response for every query or not. Or we changed couple of prompt engineering scenarios as well. And we updated the token length as well by shifting to the 8 cross into 22 billion model. And this was the results. So basically we are providing two modules where generative AI and the Weave. So the subject matter expert can generate, and he or she can submit the feedback, and whatever the feedback which was good and which used to share with others, they can weave from the Weave model. And these are the inference process which I am uploading a document at runtime. And these are some couple of other screenshots where I designed this for a learning goal and outcomes of a particular technical document. And yes, this was the learning outcome and some questionnaires. And this is the so this was the some third party LLM used model. So it doesn't contain any RAG model in it. So what I did is, you can see the consider given text as docs. That was my prompt engineering query, which I gave in the some external model. I tested it by giving a same technical document, and with this query, what it gave the response is as it's not, it doesn't have the information according to my query, and so so what I did is with my model, I gave the same prompt query and I tested with my model. So it gave the response, a relevant response. And coming to the conclusion, so with this I can call it as a personal chatbot for an can be for SMEs or for any students, or for even if you want to market any subject or anything, you can definitely refer this as one of the use case. And coming to future work, and if there are any lack of SMEs, or even SMEs can't able to give an feedback, then we can move to the multimodal resources, and we can integrate this as in with LMS models as well. And yes, we can collaborate with other models as well. And these are the references, and thank you.
Any questions from audience?
So in one of the slides you have written that there are 5 prompts that you have used.
Sorry?
In one of the slides you have written there are 5 prompts that you have used, right? If you go back. Yeah.
Yes, okay.
So you used 5 custom prompts, right?
Yes.
So what are these prompts, and how can you come up with which of these prompts were actually the best out of all these 5? So that's my question.
Okay.
Yeah.
So if you want to decide which prompt is best, so what I did is, so I just gave a role to a model. So I told model, you assume this design constructor, or assume you are architect, something. I gave a role to a model, and then I asked the model what I need. It's basically a question. Then I told the model, I need a response in this format, in this way. And even if you want to add anything using Bloom's taxonomy in order to get some critical questionnaires, so in that way I used prompts.
So I have one follow-up question regarding the Bloom's taxonomy. So like this is a Mr. Right?
Yes.
So do you have a document for the Bloom's taxonomy as well, so that you can update the memory of this model that you are using? So do you have any reference for the Bloom's taxonomy in your entire workflow?
No.
Say,
I just included the prompts document in this PPT. Okay. So if you want, I can include even that.
Okay.
Thanks.
Any other question?
So what is the accuracy? Can you comment on accuracy, actually, how it helped you?
I think that generative AI models, I don't find any evaluation metrics for accuracy and all of that.
The output somebody might have read.
Yes.
So what is that impression?
Yes, that's the reason I made only SMEs to give the feedback on the response which is generated. If it was a good, or it's not related to the questionnaire which subject matter asked, then the feedback can be in the form of normal English based. So I am taking this feedback and I am regenerating the query again by adding this feedback to the initial prompt which I added. So in this way I am regenerating.
Yeah, but after some cycles,
yes,
have you got the expected answer?
Yes. If the subjected matter is impressed by the model response, then definitely I can say.
So how many you generated such responses?
So many.
How many you generated?
Yeah, I think that quite more than 50 or 60 times.
So you are happy with all the 60 responses?
Not with all of them. I changed some of the prompt queries as well.
That's okay, but after some changes?
Yes, I'm happy.
Okay, thank
Any other questions from audience?
Regarding e-learning tools, like the basic objective of the tool is to be, it should support the learning methodology or learning approaches. So
Yes.
have you concentrated anything on that? Like how to make it as a smart learning approach or a tool?
Smart learning tool means, no, it's basically development tool.
Only
Smart only development tool. Whatever the only the development tool. Smart e-learning development tool. So it's developed based on our queries.
Correct. In that case, are you considering any other aspect of like a user interest?
Yes, for that
user level of understanding, or anything about user sort of feedback, capturing the feedback through some other mode of approaches.
Yes.
Not simple feedback approach.
Yes.
What you are taking into account.
Yes.
Anything other you thought it about?
No. Why? Because initially when we came across the ChatGPT at the first time, what we did, we raised a prompt for a ChatGPT and we somehow manipulated it. Some 2 plus 2 equal to 4. No, it's 2 plus 2 equal to 5. And it's believed that model believed, obviously. When you ask for the next time, 2 plus 2 equal to 5, it's automatically believed. So that's the reason I don't want to give the feedback to the model by everyone. So that's the reason I only kept a corner only for the SMBs.
Okay, but the concern is when you are designing with some sort of tools or any platform for e-learning, that should have a better mechanism through
I think I could have given the opportunity for the users to give the feedback, but not for regenerating using the model for users. I think that can be come into the picture. Yes, I can add that actually. Yeah, that's a good one.
Thank you.
Thank you very much. Okay. So thanks for taking care of the session. Okay. Right. Good evening, guys. So formally we are finished for the technical sessions. Okay. So now there is a cultural event which is there in the DST auditorium. All of you gather outside. Okay. We'll be going to the DST auditorium and we will have the cultural event. After the cultural event, the banquet dinner is again here in this same building. Okay. So we go there. After the cultural event, there will be no announcement. You directly come back and then we'll have the dinner. The reason is simple. The cultural event is open for everyone, but the dinner is only for the conference people. Okay, there will be no announcements there. Please remember that one. So we are going there for cultural event and we are coming back. Okay, right then. We had very good, interesting conference day today. Okay, let's go. Okay. And let's all talk in the banquet dinner.